Hi, I am Varun Joshi and I welcome you to Git Masterclass, complete Git and GitHub tutorial. This course was originally launched as a three-part series. However, I realized that many learners prefer learning a topic in one go instead of switching across multiple videos. So this version combines all three parts into a single complete masterclass. This course takes you from Git fundamentals to production grade workflows used by real engineering teams. We start from the ground up with commits, staging, branching, merging, and history. Then move into collaborative workflows like remote, pull requests, fetch, pull, push, and authentication. Finally, we cover advanced topics like rebase, interactive rebase, squash and merge, cherry pick, history rewriting, and production style integration strategies. The goal is not just to teach commands, but to help you understand how Git actually works under the hood and how teams use it in real world environments. Every major concept is covered both theoretically and practically with hands on demos, diagrams, conflict scenarios, and production oriented explanations. This course is designed to help you with real world work as well as technical interviews. This course also comes with detailed GitHub notes that will help you follow along during the lecture and revise the concepts later at your own pace. For your convenience, I have intentionally kept the original intros and outros from all the three parts intact in this combined version. If this course helps you, liking the video, subscribing to the channel, or leaving a comment goes a long way in supporting the work and helping it reach more learners. And if you like to support the channel further, consider joining as a channel member. I don't lock content behind paywalls, so membership is simply a way to support the free learning I share with everyone. Now let's get started. Hi, I am Varun Joshi and I welcome you to part 1 of this two-part Git masterclass. Git is one of the most fundamental tools in modern software engineering. Whether you are writing application code, managing infrastructure with Terraform, deploying applications to Kubernetes, or building CI/CD pipelines, Git becomes the system that manages changes across application and infrastructure. In this lecture, we will build a clear understanding of how Git works. We will start by understanding why Git exists and how distributed version control works. Then we will explore the core Git architecture, including the working directory, staging area, and repository model. From there, we will walk through commits, commit history, and how Git stores project snapshots. Next, we will dive into branching and parallel development. You will see how branches are simply pointers, how commit graphs evolve, and how teams develop features safely in isolation. We will also explore merging strategies, including fast forward and three-way merges, understand why merge conflicts occur, and learn how to resolve them. Finally, we will see how to safely undo mistakes using Git reset and Git revert and when each should be used. So let's get started. Git fundamentals for modern engineering. Why Git exists. First point is teams frequently overwrote each other's work. So, firstly, I want you to know that Git is a version control system which tracks changes that happens in your project over time. Now, let's understand if something like this did not exist, then how the life would have been. First is teams frequently overwrote each other's work, and that is understood. Let's say you have a file share where your application code resides, and you have multiple developers working on that shared remote location, and that location could be NFS, it could be SMB, and so on. Essentially it is a file share. Now when multiple engineers are working in the same file share, you don't know who has the file opened. So if multiple engineers are editing the same file, it is highly likely that they will overwrite each other's work. No reliable history of code changes, and that is true. Imagine your code base is 2000 lines and multiple developers are making changes, and let's say when you deploy the application using the recent code, your application broke. You will not know who performed the change to begin with, and then what exactly was changed, because you are dealing with files that are stored on a file share which does not track each and everything that is going on with your code. Next is rolling back broken changes was difficult, and that is true. If something breaks, you don't really know what changed, and even if you know, the things that you must do were manual in nature. You have to find the line where something changed and that edit that line to make your application work again. And the last point is collaboration across engineers become difficult, and that's true. If multiple engineers are collaborating in a file that is stored in a file share, it becomes difficult. And even if developers have the copy of the code onto their laptops, it becomes very difficult for developer 1 to share what he or she has done with developer 2. Even if they share, what if a new developer joins the team? Hence collaboration became difficult. So in essence, with file shares, it does not work. If it works maybe for a little time, it does not scale. Hence we wanted a solution that will track the growth of a project step by step, line by line. Hence we have Git that solves that purpose for us. Next is, what is Git? Now, before I start with this, let's talk about some history. This product was developed by the great Linus Torvalds in 2005, and he is the same engineer who gave us the Linux kernel. I want you to know that Git was developed without Git. Imagine how difficult it would have been for Linus. Now, let's talk about what we are trying to say in the first point. Distributed version control system for tracking changes in application code and infra. So we know two things here. First is, Git is something that we use for both application code and for infrastructure as well. But what in infrastructure, Varun? Imagine Kubernetes manifests, Helm charts, Ansible playbooks, CICD pipelines, Docker files, Terraform templates, and so on. All of these things are declarative in nature, and when something is declarative, you are dealing with a configuration file. And where do you store that configuration file? How do you check how your configuration files matured over time? And that is where Git comes into picture. So it is not just limited to application code. You also use Git to version control your infrastructure related component. So first is this what we learn. Second point is, we are calling this a distributed version control system. I will come to the term distributed in a little while, but for now, I want to talk about what is a version control system. Now, if you are working with an application, your application will mature over time based on the feedback that you receive from your end user, based on the analysis that you do within the team, or also based on the observability metrics that you receive for the application. Based on that, your application will grow, and you must track versions of your application. For example, today my application looks like this. Tomorrow I might introduce a new feature. 10 days later, I might introduce a new feature. 2 days later, I might fix a bug. All of these are versions of your application, and which is why we are saying Git is a distributed version control system, because it is managing different versions for your application or for your infrastructure. Because remember, Git is not just used for application code but also for the infrastructure and platform. We will see what the term distributed means shortly. Next is, every developer has full repository history locally, and locally is the keyword. So firstly, I want to define the term a repository. Repository is something that is managed by Git. So if you are in your laptop, you have a normal directory, and when you want Git to manage that directory, Git will call that a Git repository. As simple as that. Now these repositories, these can be local, or these repositories can be remote. We will come to that shortly, but for now, every developer has full repository history locally. What this means is, once you have the entire code base on your laptop, you can freely work. You do not need additional network connectivity. Of course, when you want to interact with the remote, what is remote? We'll talk about that later. You will, of course, need internet connectivity then, but on its own, when you are working on your project, you have the project copy locally so that you can work without any dependency on the network. Hence, Git is also very fast because it is not interacting constantly with something that is sitting at a different location. Everything Git needs is available locally. For synchronization, of course, we will need internet connectivity. Next point is, commits create snapshots of project changes, and we will be dissecting what commits are later. But if you see here, these green blocks and these pink blocks, these are commits. Now commits are what? They are snapshot of your application or your infrastructure configuration files at a certain point in time. Maybe this is my Kubernetes manifest where I have not added any requests and limits, but in the next commit, in the next version of my configuration file of my Kubernetes manifest, I added requests and limits. Hence, this became the second commit. I could have a third commit where I will evolve that template further and add pod security as well. So that is how project is tracked. You have commits in Git, which is why I'm saying commits create snapshots of project changes. And if, let's say, some of the changes break my application, then I have the option to just go back to the previous commit, which I know was already working. How good is that? And these snapshots, commits create snapshots, these snapshots are just like checkpoints. And if you remember, you also have these checkpoints in your operating system, in your laptops. If, let's say, your OS crashed for XYZ reason, you have the opportunity to go back to a different checkpoint, to go back to a different snapshot where everything was hunky and dory. Similarly, you can go back to a commit which worked if the recent commit has broken your changes. More on commits later. Now I want to discuss push and pull. I told you there is often a remote, and let's say this is a remote, and this remote is hosting my application 1. Initially, I only had one developer, and she is sitting right here, and this developer was working with application 1's code. Now, initially, the developer started working on the code on her laptop, and that is okay because I told you that Git is a software that you install locally, right? So she is working locally on her laptop, but now developer 2 joins. When developer 2 joins the team, developer 2 asks, from where can I find the code base? I don't see the code base for application 1 repository. Hence, remote is a place which is used for collaboration. So for example, when developer 1 has done her job, what she will do is she will use git push to push the entire code that is available locally on her laptop to the remote. And if developer 2 wants to work on that code, what would developer do? Developer 2 will clone that repository, will pull that repository onto his laptop, so that now the code base is available on his laptop as well. And when developer 2 does certain changes onto the code, how will developer 1 access that? Developer 2, like developer 1, will simply use git push to push the code that he has changed onto the application 1 repo, and developer 1 at that point can perform git pull to have those changes onto her laptop as well. So that is how collaboration works. If developer 3 joins, developer 3 can again use clone and pull to have whatever is there in the entire code base available to that developer locally. So push is local to remote, and pull is remote to local, and push and pull are used to synchronize repositories. Again, like I said, remote is essential when you are talking about collaboration, because if the remote does not exist, then again, how will developer 1 share the code base with developer 2? Now, before I move to the next point, I want to take you here and talk about what are various options that you have when we are dealing with remote. So if you want to use any cloud platforms, then you have GitHub, you have GitLab, you have Bitbucket. You can use all of these tools to host your Git repositories. And again, what is a Git repository? A Git repository is simply something that Git is managing. Rather, Git is aware of that. Hence, we are calling it a Git repository. Now, if you are on a cloud provider, there are different options at your disposal. For example, if you are on Azure, you have Azure repos that can be used to host your Git repositories. In AWS, you have AWS code commit. By the way, AWS code commit was deprecated, but it has now resurrected and available to use. Then there are self-hosted options. If you do not want to go with these providers, then you can always have your own remote server somewhere. You can use Git, Gerrit, GitLab CE for the same. Remote repositories enable collaboration, and we learned about that. Pull requests, CICD triggers, centralized backup, and access control. If any of these terms are not making sense right now, do not worry. As we progress with this course, we will be dissecting everything deeply. Now, let me come back and tell you why we used the term distributed. Now, distributed is not used because code is always available in the remote. And I want you to clearly know at this point itself, if you are testing something onto your own laptop, then and that testing is limited to yourself, then you may not have remote at all. Remote is essentially a place where you can have, let's say, backup of your code, and for collaboration, CI/CD pipelines and all of these things will use remote. But if you are an individual who is testing your application on local host, then you may not even have remote at all. You will be doing all that testing in your laptop itself. So why we are calling Git distributed? Because like I told you, all the developers that are working on your application with application one repository will have the entire code base locally onto their laptops or onto their thin clients. Hence, it is distributed. You have developer 1 who has the entire code copy, developer 2 and any more developers that are there, and remote also has that copy. Hence we are saying Git is a distributed version control system. It is not centralized, it is distributed because the entire code base is available at multiple places. The next point is branches enable isolated parallel development. Now we'll be dissecting this in greater detail as we move on with this course. But for now, I want you to understand then if your master branch that you see here, this is a branch, this is another branch. If your master branch has the code that is always releasable at all times, because that is your stable line of development, then you will not be making changes directly onto the master. You will be creating new branches to fix your bugs, to test new features, to have hot fixes, and so on. Branches enable isolation. Remember what was the challenge when you were using a file share? When you edit something, you were editing the main file, and here it does not work like that. If you want to add a new feature or let's say fix a bug, then you would create a separate branch. You will work on that branch, and once everything is working on that branch, then you will merge that branch to your stable line of development. What merges we'll be seeing later in this course, but for now I want you to understand branches enable isolated parallel development. Here you only see one branch. You could create any number of branches that you want. Next is Git versus GitHub. I see a lot of confusion. What is Git? What is GitHub? We have already dissected this. Git is something that you install locally. GitHub is something that is hosting your remote repository. So GitHub is required when we talk about collaboration. Git is a software that you install locally. I hope this makes sense. Now, the last thing that I want to discuss is Git in modern DevOps. Git stores application and infrastructure definitions. We have studied that. All your Kubernetes manifest, Terraform templates, Ansible playbooks, Helm charts, and so on can all be version control, and Git plays a major role there. The last point is GitOps uses Git as desired system state. Now, if you are familiar with tools like Argo CD or Flux CD, you would know they heavily rely on Git, because Git is the one that has the desired state. Desired state is something that you want your actual infrastructure or application to look like. So Git is the one that plays a pivotal role when you are dealing with GitOps. For example, when you are deploying resources onto your cluster using Argo CD or Flux CD. In case you do not understand this point, it is okay. Your Git journey that we are going to do here is not dependent on this point, but I wanted you to know that Git has a pivotal role when it comes to GitOps. Now, the summary. So what we know, any changes that are happening, Git solves it. And how it solves it? By creating different commits. History. You have the track record of the entire project, because you have different commits. So if you want to check the history, you can check that. You will know how your application or how your code or how your infrastructure configuration files evolved over time. Isolation is provided by branches. Collaboration is provided by remote. So I hope you now have a good basic understanding of what Git is and how it is different from remote providers such as GitHub, GitLab, Azure Repos, AWS Code Commit, and so on. In this course, we will be using GitHub as our remote, but you must know that any of these services can be used as remote, and locally we will be installing the Git software. So I want you to go to your browser and install Git if you don't already have that. So gitscm.com is the website. You open this, you go to install, and then based on your operating system you can install Git from here. I already have Git installed. So what I will do is, and it is also telling you what is the latest version, it is 2.53.0. so if I go to my terminal here and I run git hyphen hyphen version, then you see I already have the latest version installed, and I would also encourage you to install this version. Now, first thing that I will do is I will run mkdir, and then I will create a directory called project files. Okay, I'll make this, and then what I will do is I will cd into project files. I will run ls. I see this is empty. Now what I want to run here is I want to run git status. Understand that your laptop, your thin client will have multiple directories, and when you install Git, is Git tracking or managing all of your directories in your laptop, in your thin client? No, right? You must explicitly tell Git that this is the directory that you must be managing. So we have not told Git yet that you have to manage this repository. Hence, when I run git status, this gave me an error. So this is telling me two things. This is not a Git repository. And what do we understand by a Git repository? We understand that Git repository is a directory that is managed by Git. But right now, this directory where we are in project files is not a Git repository, and it is also mentioning something called .git. Now what is .git? .git is called a repository's brain. So once I make this project files a repository, a Git repository, then a .git will be created there, and .git acts as the brain of your repository. And as we progress, we will know more about these things. How do I make this a Git repository? Extremely simple. I will run git init and press enter. I want you to observe a few things. What we are seeing on screen is when we have version 3 of Git, master will be renamed as main. So right now the branch that you get by default, and remember you are always on a branch except there is a concept of detached head. We'll see that later in the course. But for now, understand mostly you will be working on a branch. And right now the branch I am in is called master. But what you see the note here mentioning is master will be deprecated soon and the new name will be main. And this name can be anything. You can call this anything that you want. You don't have to restrict yourself to main. What this message is saying, by default the name will be main once we reach version 3, and you would not see master being used because of historical reasons, master and slave. So master is not used anymore in most of the technical jargons. You would see main being used in Git often. And it is also telling you that you can change this default naming here, and once you do that, every time you run git init, your branch name would be whatever you define here, and most common names are also given here, and we'll be dissecting this as we progress. It is also giving you the command to change this name. And then what I want you to understand here is initialized empty git repository in this path. You will also be noticing that I have a master written here. This is not because of git, this is because I have done certain changes in my shell configuration file, which is why I see master here. So if I go to my browser and then I go to my GitHub page, here I will go to repositories, and then if I go to Git Masterclass, I will then go to part 1. And in part 1, what I can do is, if I come down here, initialize a repository, and if I scroll down, note about the terminal prompt. Now if you want a terminal prompt like I have, you can run this configuration. Now depending on which shell you are using, you have to change these things, but if you are on Mac, this will directly work, and if your shell is ZSH, this will work. Even with bash, with a few changes here and there, this should work, but I will let you explore that. What you can additionally do is, you can go to your prompt like here, take a screenshot of it and ask ChatGPT, I want a similar prompt like this, and it will help you how to achieve that. That's also doable. So for now, I'll again go back to the browser, and you can use this configuration to make your prompt tell you on which branch you are and to have a similar structure. So here you see in the first line, I see the entire, where I am, and then the next line is where the prompt starts. So if you want something clean like this, then you can always use that. Now let's understand the core constructs of Git. So what we have understood thus far is, to make something a Git repository, you run git init. Now git init is short for initialization, so it will initialize your normal directory as a Git repository. As simple as that. Now let's go here, and I also want to show you one more thing. If I run ls-l, I don't see anything, but if I add a here, this will show me the hidden files or directories as well, and I see .git here. Why do I see .git? I told you, as soon as you initialize, .git gets created, and .git is the brain of your repository. So if I delete this, all your history is gone. So this is a critical directory for Git. And if I run tree.git, then you would see all of these directories and files exist inside .git directory. Now I don't want to explain these things right now because you do not understand most of these terms. As we progress with this course, we will understand the architecture of .git itself. But for now, let's understand the architecture of Git. So I'll clear my screen here. I'll go back to my diagrams. I will scroll down, and this is the Git architecture for you. If I talk about Git architecture, there are three main components or three main core constructs: working directory, staging area, and a local repository. But I have also shown a remote here because in modern development, you always have a remote. If I talk about working directory, staging area, and local repository, all of these are in your laptop itself. You don't have to go anywhere for that. And within this larger bifurcation, you have staging area and local repository, which are managed by .git. So whatever is happening in these areas, .git is aware of that. Now let's see, what do we mean by working directory. Working directory is the place where you create and modify your files. So whatever files we create right now, whatever directories we create right now, they get created in the working directory. And understand we have already run git init. Git init, what did git init do? Let's say if you had a normal directory here, okay, it changed that normal directory into something that is managed by git, initializes git repository and creates .git. And we have seen this. So we have the working directory where you have files you create and modify, and then once you are done here, you move those files or directories onto the staging area. And how do you move those files or directories into the staging area? You use git add to do that. So what is git add doing for you? It is staging changes for you. So what is staging area? It exists to give you precision and control over what goes into the next commit. Now, why I am saying precision and control? Let's say you are working in a project and you have 10 files there, okay, and you are working with only 2 files. In that scenario, you would only want to commit those 2 files, and we'll see what commit is. You will only want to commit those 2 files. In that case, what you can do is you can only move those 2 files into the staging area, and then finally you can commit those files onto the local repository using git commit. So essentially, staging area exists to give you precision and control over what goes into the local repository. Now, why I am calling this explicitly is because a lot of folks think, why does staging area exist to begin with? Why can't I move files and directories directly from a working directory to the local repository? The staging area exists to give you control and precision. Now, staging area prepares changes for commit. But what exactly a commit is? Let's see that. What is a commit? Immutable snapshot of the project at a point in time. We are saying immutable. That implies the commit cannot be changed. I am not saying the files and directories part of a commit cannot be changed. I am saying the commit in itself has a commit hash and you do not have an option to change that, which is why we are saying commit is an immutable snapshot of the project at a point in time. So if you see this diagram, A, B, C, these are 3 commits. And this had, let's say you had file called app.txt. In that you said my name is Varun Joshi. In commit B you said I live in India, you added that line. In commit C you added Varun is a DevOps engineer. So the file app.txt matured over time. Each commit was holding the project at a point in time, and A only had the name, B also had the name along with where Varun lives, commit C had further information about Varun's job role, that he is a DevOps engineer, captures the exact state of files at that moment. We have already seen this. Stores metadata such as author, timestamp, message, parent commit. Now, this is extremely important, folks. Understand, if you had a file share like we discussed in the previous section, you didn't have any way to know who edited the file. When it was edited, there was no message associated. Let's say if someone is editing something, what if you could have a message that I added Varun's job description? That would have been nice, right? But there was no mechanism there that could do that. But in Git you have something called commits, and commits allow you to have author, timestamp, message, parent, commit. So if something has changed, I would exactly know who changed it, when it was changed, and if the author was good enough to write a good commit message, I would also know why that change was made, and we will see this as we progress. Now, commit also stores the parent commit. For C, the parent commit is B because C originated after B. For B, the parent is A. For A, there is no parent, which is why we say A is the initial commit or the first commit. So that's what the last point says. References a parent commit to form the commit history. Now imagine if I want to check the history of this project, I will just type git log. Git log is a command which tells you the commit history. If I run git log, it will tell me exactly what happened in A, what happened in B, what happened in C. So it forms a commit history. I hope what a commit is understood. Now let's go back to this diagram. If you want to commit something that is in staging area to the local repository, then what you do is you write git commit. Now what will git commit do? Create a commit. And what is a commit? It is essentially a snapshot or a checkpoint, and we have seen that. So in the local repository, commits stored in git. So history, if you run git log, you will see the entire history of all the commits. Now git is aware of the working directory, and .git, like I mentioned before, is aware of anything that is available in the staging area and also keep tracks of what is in the local repository, implying all the commits. So once you have done with this local work, what you can do is you can also push whatever you have done onto a remote. Now remote, like we learned, could be GitHub, GitLab, AWS code commit and so on, but in our tutorial we would be using GitHub as our remote. And then from local you can push to remote using git push, publish commits to remote. And if there is a new engineer who wants to work, he or she can just run git clone, git pull to have the working code onto their local repository. Now I want to move on to the logical flow. So first we had a normal directory. We used git init to make it a working directory, which is git managed. Then we used git add to add whatever we have done to the staging area. And whatever we have done, like I told you, you can be selective. If you have multiple files, you can only choose the ones that you move to the staging area, so that only those files are then committed to the local repository. So git add to move to the staging area, and then you use git commit to move the things that are in the staging area to the local repository. And finally you use git push to push your code changes or your infrastructure configuration files or whatever is there in your local repository to the remote repository. And if some of the things are not making sense, do not worry, we will move to the demo and all of these things will connect. Now that we have this understanding, let's go to the terminal. So I will come here and then let's run git status. Git status says on branch master. Like I told you, you are mostly on a branch, but there is an exception that is called detached head. In that scenario, you are not on a branch, and we'll see that later in the course. This says that there are no commits yet, nothing to commit, and it is saying you can do all of these things. You can, and it says nothing to commit. So let's do one thing. I will run touch file1.txt, and now I will run git status. And this tells me untracked files file1. It is saying untracked. Remember what I told you. Whatever you are doing right now, files you are creating, they are all in the working directory. Git will start tracking those files once you move those to the staging area, because .git has visibility on the staging area and the local repository. So if I want git to manage file1.txt, then I will have to use git add to move this file to the staging area so that Git can track it, because right now it is untracked. Now let's use git add to add this file to the staging area. Now I can run git add dot will move everything that is there in the current directory in the Git repository to the staging area. But if you have file 2.txt, file 3.txt, and you only want to move file 1.txt to the staging area, then you will have to explicitly call that name. So let's say git add file 1.txt and press enter. Now if I run git status, I see that changes to be committed. So I told you, once the file is in staging area, then you can run git commit to move that file to the local repository. So for now, our file is in the staging area. Now I understand that we are humans and we may make mistakes. If you want to bring that file back to the working directory from staging area, that is, if you want to unstage that file, then you can always use this command, and this prompt tells you what the command is: git rm -- cached, and then I can write file 1.txt, and once I press enter, and if I now run git status, you see we are again at the same place, untracked files. So let's do one thing. I will run git add file 1.txt, and if I now run git status, then what do I see? This file is in staging area now. Now I want to also cover a scenario when the file is in staging area, but you make changes to the file that is in the working directory. So for example, if I run ls now, right now file 1.txt exists here, and if I cat on this file, this does not have any data right now. So let's do one thing. Let's add echo. Let's write here God is great, and then I'll have close my double quotes, and then I will direct this to file 1.txt. I'll press enter. Understand, the file that was moved to the staging area did not have anything, but what I have now done is the file that is in working directory, I have added some content to it. So if I now run cat file 1.txt, I see there is data in it, but if I now run git status, it will tell me that you have modified file 1. You can use git restore to discard those changes, or you can use git add to move this file to the staging area. So what we will do is, right now the file that is in the staging area does not have anything. We know that. So if I run git restore, whatever is there, God is great, this will be removed. So let's see both of these things. So I will first run git restore, and the file name is file 1.txt. I'll press enter. Now if I cat file 1.txt now, you don't see anything because I restored that. Now let's modify this again. So I will echo God is great in file 1, and if I now cat file 1, I will see God is great there, and if I now run git status, I see that you have modified this file. Now what I want is, I want the modified file to be in the staging area, so I can use git add again. So git add file 1.txt, I will press enter, and if I now run git status, I see that this file is here and this is ready to be committed. It is saying changes to be committed, and if I cat on file 1, I will see God is great written in there. So I hope git restore, git rm, these things are clear. Even the terminal will tell you these commands and how to use them. Now what I want to do is, I want to commit this file. The file is here right now. I want to move this file to the local repository. So what I will now do is, I'll come here, I will write git commit -m. -m is used to give a message to a commit. Now, like I told you, if you have been following along this channel, you know that we are very explicit about nomenclature and descriptions. So whatever naming that you give, whatever messages that you give, whatever description that you give should be useful for you, when you look at the project 2-3 months down the line, and also useful for your fellow collaborators because you don't want anyone to look at your work and feel lost. So here we have to give a commit message and always have good commit messages. So for now I will just write initial commit, and then I will write add file1.text. I will add file1 here, and then I will close this and I'll press enter. Now read carefully what you are seeing. Your name and email address were configured automatically. And what did it configure automatically? You see, committer is Varun Joshi. That's fine. But committer's email address is this, but this is not my email address. And maybe I have named my laptop Pink Floyd or Led Zeppelin, then the committer would be Pink Floyd or Led Zeppelin, and I really do not want that. What I want is the committer name should be my name, which is correct here, and the email address should be my email address, so that if anyone looks at the project history, they know that Varun Joshi is the one who performed the commit. Varun Joshi was the author, and then this is Varun Joshi's email address, and this is telling you how to do that. So let's configure our correct username and email address so that we do not have to look back. It tells you as well how to do it. So here I will copy this, I will paste it here, and my name is Varun Joshi. This was already correct, but let's do it anyway. I will do this, and then here I have to change name to email, and here I will write cloud with varjosh@gmail.com. So I have set both my username and email address. Now why this is important, I will run one more command for you, and that command is git log. And when I run git log, you ignore the things that you do not understand right now. So initial commit, this is my commit message, and then it is showing me author is Varun Joshi, and the email address is wrong because I have done this configuration, username and user email, after performing the first commit, which is why my first commit does not have proper details. When it comes to date and time, that are fine. Commit message, that is fine, but the author email was wrong. So once we move to the next commit, once we perform the next commit, we will see the correct email address here. Now I want to show you a few more things. So let's go to the browser, and here Git architecture we have discussed, core workflow we have discussed, and this is also what we have discussed. Now I want to talk about this. Like I told you, your commits should have proper name. So you can have type first. Type is a high level thing, and then a short description about it. So if you are adding a feature, you could start with feature and then write description about that feature. If you are fixing something, you can have fix and then write what that fix was. And here I have shown a few examples as well. So for example, feature, add Argo CD application deployment pipeline. Fix, resolve failing Terraform state lock issue. And I want you to notice one more thing. In here we are saying add Argo CD application deployment pipeline, upgrade Kubernetes cluster to version 1.2. We are not saying upgraded Kubernetes cluster. No, add Argo CD application, implement password strength validation, prevent null pointer. Similarly, the message that we gave in our prompt was also add file1.text. We did not say added file1.text. So your commit messages should adhere to this format. Now when you are working locally, you may diverge from this because you are learning right now, but I want you to make a habit that your commit messages should be descriptive enough. Now one more thing that I want to add is we have used this command to store our username and email address. I want you to know that we have used the flag hyphen hyphen global, which is most common because it applies to the current operating system user across all repositories. Now, whatever repositories, Git repositories I create in future, whenever I run git init, automatically it will take my name and email address from what I have configured here, and that is what you want. So most of the times, rather 99.99% of the times, you would be using the global flag to configure your username and email, but there are other options as well. So if you are dealing with a repository where you want a different email address, or let's say a different username, then you can in that repository explicitly set that using hyphen hyphen local. And when we talk about precedence, hyphen hyphen local has a higher precedence than global. Then you have hyphen hyphen system, applies machine wide for all users. So that is why you see the changes for these, the global, they are stored in your home directory because they are applicable for your user. But if I talk about hyphen hyphen system, when you use this file, the changes are stored in a file that is stored in etc. So this is system wide in nature. Now there are other options like worktree file. I personally have not used them ever, but I am mentioning this for completeness. Then configuration precedence, you can also see, like I told you, local is preferred first because this is specific to a single Git repository. That is what you see here, applies only to the current repository. Now it is saying when you use this flag, you can see the configuration here. So I can copy this and then I can go to my terminal and then I can cat on this one. Oh, it did not copy. Hold on. So let me just quickly write that. .git config was the file name. Yeah. So if you see, when I did that, these two lines were added. Now I could have modified this file manually, but why do it when you already have a command to do that? So let me now clear my screen and then let's create another file. Touch file2.txt, simple. Then I will use git add file2.txt. I will press enter and then I will write git commit -m. I'm walking you to the entire flow. So first we create a file, then we move that file to the staging area, and finally we commit that file. And the commit message, like I told you, should be descriptive. So here I will write addition because I'm adding a new file, and then I will write here add file2.txt and I will close the double quotes. I'll press enter. I want you to know very clearly that you do not see any message about email address now because we have configured both username and email. So if I now run git log, you see the second commit that was done was performed by Varun Joshi and his email address is cloudwithvarjosh@gmail.com. I hope this makes sense. Now another thing I want you to know, that not at all times you would want to see the date, the author. You may not want to see these things at all times. So what I can also do is git log -one line. And when I do that, I see only 2 lines. So 1 line per commit, and which is very good when you are working with a big long commit history. So here you see, this is the initial commit. And I also want you to know, here you see the full commit hash. Here also you see the full commit hash. But here you see a shortened commit hash. So these are the first 7 letters of your commit hash. Now I will again clear my screen. I will create one more file. Touch file3.txt. I will run git add file3.txt. That's fine. And now what I want to do is I want to use git commit, but I will not add a message now. I will not use -m, but we know that commit messages are must. So I will run just git commit and I'll press enter. You see what happened? It opened a file for me. Whatever you see with hashes are comments, and it is essentially asking me to give a commit message here. So if you are not using -m, which pretty much always you would use. But in case you do not use, you would see an editor open, and then you can add your commit message here. So for example, here I will add addition, and then I will write add file 3.txt, and then I will save this, hit escape shift ZZ to save this. And if I now run git log -- one line, what I would see is you have a third commit now. What is this? We'll see later. Addition add file 3.txt. Now let's talk about something called git ignore. What does .git ignore do for you? So let's go to our browser, and here I want to go to ignoring files with .git ignore. Now I want you to clearly know that your Git repository can hold multiple files, because you have your code here, you might be testing, you might be building your code locally. In that scenario, you will have multiple log files, multiple orphaned files as well, multiple system level files, and sensitive information too. For example, API tokens, private keys, environment configuration files, API keys, secret keys, and so on. You may not want to commit those things. Of course, sensitive files you do not want to ever commit onto version control. Mark my words, even if your repository is private. What does this line mean? Private repository, we'll learn later, but for now, understand you must never commit your credentials, your API keys, your tokens onto version control. Never push them. Then there could be other files that are log files, that are system generated files, that also you do not want to commit or push to your remote. In that scenario, you can always use .git ignore file, and whatever you add inside this file will be not taken care by Git. So that will not be entirely tracked by Git. So that is what we want. Let's go to our terminal, and here what I will do is, first I will run ls. You see file 1, 2, and 3 here. What I now want to do is I want to touch my.log, and then I want to touch my.key. So I have created two files with extension .log and .key. So if I now run git status, you see that Git is saying that these files are untracked. And what we want is, when we run git status, we don't want to even see these files, because I don't want to version control my logs or my keys. So what I will now do is I will write vim, and I will create a file called git ignore, right? And then I will go in this, and I will go in insert mode. I will say anything that has .log extension and anything that has .key extension. I don't want you to take care of those files. Now, if I now run git status, I don't see my .key or my .log. I don't see them because these extensions are part of my git ignore. So Git listens to what is there in .git ignore file and ignore those files. Now I want you to also know that you would see that .git ignore is often version controlled. So you would see these in your remote repositories. Now why is that? By committing .git ignore, the ignore rules themselves become part of the project, so that all collaborators follow the same rules about which files should not be tracked. So which is why you push this file onto your remote as well, so that all the collaborators can see what .git ignore holds. I hope this is clear. Now before we move on from this section, I want to talk about two more things. How do you create .git ignore? So firstly, there is a repository. So if I open this repository, you will see that they have .git ignore file for most of the programming languages. So you can always use that. So if I talk about Android, they will have a .git ignore file, and this will have most of the things that you want to exclude for Android. And similarly for other languages. So if I search for Python, then they will have a .git ignore file for Python as well. Of course, you will have to name it .git ignore, get rid of this Python. And you see whatever files are highly likely to be ignored, they have mentioned these here. But I also want you to know that once you are using the files that are already available, do cross check that they are not ignoring something that your project wants to version control, because these things at times can be subjective. So I want you to be careful of that. One is this: you can refer this repository, and this repository has a collection of gitignore files. And then there is also git ignore generators. So if you Google this, you can find this here. So if I go here, I can just search for, let's say, Python here. Yeah, Python is here. Create. So it will give you a .gitignore file. So you can also use this to generate .gitignore files. Again, as the last point says, always review generated files carefully, as they may ignore files that you actually want to track. Okay, now let's go to the diagrams and see what we want to discuss next. Git branches. Now, Git branches are extremely easy concepts. Once you have understood them, you will not find them challenging. So let's focus and dissect this topic step by step. First question is, why create a branch? So when you are working with remotes, and I told you that it is pretty much always that you will have a remote when you are dealing with enterprise applications. So in that scenario, you always have a primary branch, and then you have multiple feature branches. Primary branch could be named main, trunk, primary, release, but you won't see master. Master is getting, deprecated, and it is not suggested you use this name. However, in this course, at till a certain point, we will be using master only, because that is what is the default when I talk about Git. There is a primary branch, like I said, and whenever you want to release a new feature, you create a new branch. Whenever you want to fix something, you create a new branch. Whenever you want to change something, you create a new branch. And why is that? So why create a new branch? The point is, the primary branch must always be releasable, because that contains the stable code, production ready code. So at some point, commit A had the code that was releasable. At certain time, commit B had the code that was releasable. So when commit B was the latest, then commit A became n-1 version. If commit C is the latest, then commit B became n-1, commit A became n-2, and C became n, that is the latest stable version. So what we understand here is, when I talk about the primary branch, that is the stable line of development that will always have the production ready code. Now, if something is holding production ready code, then would you want to edit that if you want to make any changes? No, right? You will not want to disturb anything that has the stable production ready code. So what you do instead is, you create a new branch. So that is what a new branch will do for you, and this is the reason why new branches are created, because the primary branch holds your production ready code. Next is risk isolation, and that's true. Avoid breaking stable code with in progress changes. Protected workflows, no direct commits, changes via PR, MR, and we will be dissecting this point later in this course. But for now, understand that in our workings that we have done thus far, we have been working directly with the master. Okay, and we are directly committing onto the master and working with the master directly. But when we are talking about remote, your primary branch will always be protected. What does protected mean? Protected mean that you directly cannot use git push to push onto the primary branch. That is disallowed in production. So what you do is, you first push onto a feature branch. Let's say that you see here. So let's say your primary in the remote is called master, and then you have a second branch that is called feature login, and in this branch you are introducing a login feature. I want you to pay attention that there is a specific naming that we have done for this branch. We'll be seeing that later, but I want you to keep that in mind. So what I'm saying, you have a master, that is the primary, then you have a feature login, that is the branch that you created to introduce the login feature. So what your developer would essentially do is, your developer will not be allowed to directly push to the primary branch. So developer will be pushing on to the feature branch, and once the code is in the feature branch, then the code will be tested. How the code will be tested? There will be automation under the hood that will be running CICD pipelines, that will be building the code, deploying the code onto, let's say, a development environment or onto a pre-stage environment. And then if the code works all right, everything is working as expected, only then a PR is raised. PR is a pull request, or MR is raised. MR is a merge request. They both mean the same thing. It is just one. PR is used by GitHub. GitLab uses MR. Now, what will PR or MR do is, once these are raised, someone senior will approve that, or it will be automatically approved based on what was the result of this code, and then the changes that were performed here will be merged here. We will be seeing this concept later, but I want my students to plant this concept in their head that this is how it works at a very high level. So once this branch has the working code, this is merged here. If, let's say, it fails, let's say if the testing that you are doing fails, then this developer will again work on this and again push to feature login. And once everything is working, only then the merge happens, which is why we are saying protected workflows. No direct commits onto the primary branch, changes via PR and MR. Parallel work, multiple feature and fixes developed independently, which is correct. Right now I just have feature login. If I am fixing a bug, I will have another branch called bug fix. If I'm introducing another feature, for example, let's say feature UI enhancement, then I can have another branch here. I can have multiple branches, which is why we are saying parallel work, multiple features and fixes developed independently. Now what happens is, when I am working with this branch is not disturbed. That is why we are saying branch is independent line of development. If something breaks here, our this branch will continue to work fine. If you have 10 more branches here, if this breaks, all of them will continue to work they were before, because branch is independent line of development. Last one is controlled integration. That is what we discussed. Merge only tested and reviewed changes. So if whatever is done here works perfectly, only then merge with the primary branch. I hope why we need branches is clear now. So now let's understand what is a branch. Independent line of development. Internal structure is lightweight pointer to the latest commit. And what is the latest commit? Branch tip. So conceptually, you already know that branch is an independent line of development. But what exactly is branch? It is a lightweight pointer to the latest commit. And latest commit is what? Latest commit is the branch tip. So master branch points to the latest commit, which is why we say branch is a lightweight pointer to the latest commit. That is the branch tip. For feature login branch, it is a pointer to commit E. Why commit E but not D? Because E is the latest commit in feature login branch. If E didn't exist, then what will be the branch tip? Branch tip would be D. Hence, feature login will be a pointer to commit D. Because what is a branch? branch is a lightweight pointer to the latest commit. So if you understand this point, your life will be so much easier. Branch points to the latest commit. Here that latest commit is E. Here that latest commit is C. Branch creation does not duplicate project files. So understand, when I'm creating this feature login branch from commit C, mark my words, I am saying when I am creating this branch from commit C, so whenever you create a new branch, that automatically gets created from the latest commit in the branch from where this branch is getting created. So this branch is getting created from master, and the latest commit on master right now was C, which is why this feature login branch was created from commit C. And when it was created from here, this branch, it is not that all the files that existed because of these three commits will be copied here. No, it does not work like that. It does not duplicate files. What happens is branching in Git is lightweight because it operates on pointers and snapshots, not on copying files and directories. So initially the featured login branch will point to the commit from where it was created. So for example, let's say when this feature login branch was recently created, these two commits will not be there, right? So feature login branch will point to the commit from where it was created. So initially feature login branch points to this commit, and then as and when you perform commit E, then feature login will be pointing to the latest commit on that branch. So if E is the latest commit in the feature login branch, and we'll be seeing this as we progress with this lecture. So key benefit of branching: parallel development without breaking stable code, fix bugs independently, experiment safely. Branch lifecycle: changes later integrated through merging. So once this is working, this code is working, you merge it with the primary, and once the merge is successful, you delete the feature branch. So all these feature and bug fixes branches, they may come and go, but the primary branch will always remain. Now branch naming convention. So let's see what we want to convey here. So I will go to my browser, and then I will go to the top. Here we are discussing branching, and here I want to talk about common branching naming conventions. So here branch naming is also done in a certain way. This is what industry recognizes. You may call your branches anything, but it is recommended you follow some structure. So that structure is high level what you are doing. So let's say if you are releasing a new feature, then you will have feature forward slash description of what you are doing. So for example, if it's a login system, you can write login system. If it's a Terraform VPC setup, you are creating that branch to introduce that feature, then you can name that branch like this. Bug fix, you can call it bug fix payment calculation error, bug fix helm values misconfiguration. And I will let you read these. If you are performing regular maintenance tasks, then you can use chore as well, like chore upgrade Terraform module. Now another thing I want to discuss here is atomic development. So if I go here and I come here, atomic development in Git, now we have understanding of both commits and branches. Okay, but in Git, both commits and branches are most effective when they represent small focused unit of work. So what we are saying is, do not combine multiple things together. So if you are performing a commit and in that commit you are doing some UI changes, then do not introduce a new feature with that commit itself. So your things should be focused on small amount of work, because if something breaks because of that commit, you wouldn't know why it broke, because you performed multiple changes in the same commit. And same implies for branches. If you are creating a branch to introduce a new feature, then do not fix a bug in the same feature branch. Do not do that. Do not combine things. For example, you must be doing things in an atomic way. What does atomic way mean? One branch should have one purpose, one commit should have one logical change. For example, for commit, feature add user login API, not feature login plus payment plus UI changes. If you combine changes, things might break. And same applies for branches. So if it is a login system, you just have a branch for login system, not for login and payments and UI. If you are working with Terraform, you create a new feature for Terraform VPC setup, not for full infra setup. So keep these things in mind. These are best practices. Now let's go back to the diagrams and see what I want to discuss next. I want to visualize branches with you, because when you visualize things and then do demo, I feel things click in a better way. So visualizing branches, a branch is just a pointer to the latest commit. We are mentioning this again. So let's walk through how a development flow might look like. So you start with the primary branch, and in our primary branch we have three commits A, B, C. Each commits capture project's state at that moment. So A might have my name is Varun Joshi in the same file. B may have a second line in that file, he lives in India. Commit C might have a third line that says he is a DevOps engineer. Now, I want you to know that commit A could also be introducing 10 files. Commit B could also be introducing 20 more files. Commit C could be deleting 5 files. So understand that these are tracking changes. What those changes are subjective based on what you are working on. For me, the example I gave, we only had one file. The first line had my name. The second line had my country's name. The third line had my profession. So each commit captures project state at that moment. Master branch points to the latest commit, and this is what we see here. The primary branch is pointing to commit C because commit C is the latest commit, and we know branch is just the pointer to the latest commit, and the latest commit is often called the branch tip as well, like we learned in our previous section. I am sorry if I'm repeating a few things a lot of times, because I want these concepts to find home in your brain so that you do not forget these things. Because when you run git log, all of these things, whatever we are doing, will only make sense if you understand these things visually. In the demo and while working with production implementations, all of these things matter, and especially in interviews they would see whether your foundations are good or not. So master branch points to the latest commit here. New commits move the branch pointer forward. So if a commit D comes, master will start pointing to commit D. That is what we imply. New commits move the branch pointer forward. The next is create a feature branch. Now what you would often see in production is, let's say you created a branch here, and you see I have mentioned C in square brackets now, and I have also written feature forward slash login. Understand that when you create a feature login branch, for example, that branch initially will be pointing to the commit from where that branch was created, and feature login branch, let's say, was created from the latest commit, which is commit C. Initially, when there is no commit in that branch, it will point to the commit from which this branch was created, which is why feature login points to commit C. In case this feature login branch was created from commit B and you have an option to do that, we'll see that in the demo. In that scenario, feature login branch would have pointed to commit B, but most of the times, rather 99% of the times, you would see that new branches are often created from the latest commit. And master will, even if feature login was created from commit B, master will still point at commit C, because commit C is the latest commit in master. And for feature login, since feature login doesn't have its own commit, so to speak, hence it will point to the commit from where it was created, and that could be B as well. So in our example, feature login branch was created from commit C, which is why both master and feature login are pointing to commit C. But as soon as you add a commit in feature login branch, let's say E was not here right now, let's remove this for now, and then only D was there. Okay, if D was there, feature login will point to commit D now, because that is the latest commit in that branch. And once you add another commit, let's say you added commit E, in that scenario feature login will point to commit E, because E is the latest commit in feature login branch and is the branch tip. So separate branches protect the stable working version. New branch feature login created from commit C. Development continues independently on that branch. Primary branch remains unchanged during development, and this is important. Now, does not remain unchanged, but the changes that are here, they are only done using pull requests or merge requests. Now let's talk about parallel development. Like I told you, you can create as many branches as you want based on requirement. So here you see from C we have created 2 branches, and we'll see why C has a square bracket later in this course. But for now, you see that from commit C there are 2 branches that were created, and feature login branch is a pointer to commit E, because E is the latest commit. Bug fix typo is a pointer to the latest commit, which is H here. Another thing I want you to know, that there is also a commit F here, but these 2 branches were created from commit C. Now, why does F exist here? Maybe there was a 4th branch in this scenario which got merged into main, and that's the reason F was created. Maybe we are working locally and we directly performed a commit in the master branch, which is why you see F commit here. There could be several reasons for that, but the critical part is whatever was done in commit F, that something will not be visible onto these branches. These branches will only know what was done in commit C, but they will not have any additions, deletions, or modifications that were done in commit F, because these branches are created from commit C. Next is good practice. Keep commits and branches atomic. We just learned about atomic development. Atomic changes simplify debugging, review, and safe rollback. Now that we have a good visual understanding of branches, I now want to move to the demo. So let's go here. I'll go to my terminal. I will clear my screen. Now I want to work in the same directory, but I don't want to have all these files. So what I can do is I can run rm-rf, run this cautiously, folks, and this will ask me that do you want to delete everything in project files. I will say yes, but this will not delete the hidden file. So if I run ls-la, I see .git and .gitignore still exist. So let me first delete rm-rf.gitignore. I'll first delete this, and you see master is still written here. Why is that? Because if I run git status, you know that this is a git managed directory. So what I told you, .git is the brain. So if I delete the brain itself, then this will not be a git repository anymore. So I will run rm-rf, and then I can just write .git, and you can see I deleted these files, but there is a way I can restore them as well. So go through this if you want to, and I will delete this, and you see master is gone, because this is no longer a git repository. If I run git status, we see the same error. Now I will run git init here, and we see the same message like we saw before, and it says we are on the master branch. Now what I want to do is I want to perform 3 commits. Now here I will be using copy paste so that we can be a little fast, and still our commit messages are complete. So what we are doing is we are echoing application initialization. We are creating a new file app.txt, and then we are moving that file to the staging area, and then we are finally committing it, and we are writing chore initialize application. This could very well be the initial commit, but we chose this nomenclature here because I want you to know it depends on your project what and how you want to do things. As long as you are following a certain standard at a high level, nitties and gritties are dependent on application to application, project to project. So this is my first commit, and then I will make my second commit, and this is my second commit. Here I am modifying app.txt. I'm adding one more line here, updating application header styling, and my commit message is also there, style improve application header styling. So understand how detailed your commit messages should be. They should be crisp, but they should still convey what you are doing, and hence that's why we say commits should be atomic, so that whatever you want to convey is about a single thing, so that can be crisp and descriptive at same time. I'll press enter. Then comes the third commit. So I'm creating these commits so that we have something in our master branch. And if I clear my screen now, if I run git log hyphen hyphen one line, I see that I have three commits. First is a chore, then a style change, and then a feature. So all this happened in the same master branch. I have three commits here. So if I run git log, you would see all my commits now have Varun Joshi and my correct email address as well. So once you are done with this, you can also run cat app.txt. This will show you all the three lines that we have added here, and then we can write git log to have descriptive message like we have seen before. Now is the time I want to show you one more thing. So I will write git one line again, and I want to tell you what head is. Head will mostly point to the currently checked out branch. And why I say mostly, because there is a scenario that is called detached head. In that scenario, head directly points to a commit, but mostly what you would see is head points to the currently checked out branch, and the currently checked out branch is master because we are working on the master for now. We have not created any new branches, hence head points to the currently checked out branch. And then we know to which branch points to. Branch points to the latest commit or the branch tip. So understand that hierarchy. Head points to the currently checked out branch, branch points to the latest commit, and you can see here branch is master, which is pointing to the latest commit, and you see head here, which is pointing to the currently checked out branch. Now in the next step, what I want to do is I want to create a branch. I can write git branch feature login. This will create a branch for me. And then right now I am not working in this branch. Right now I am working in the master branch. If I want to go to my recently created branch, I can run git checkout feature login. But before I do that, I want to run another command. I want to write git branch. This will show me what all branches exist. So here we can see that there is a master, and you see asterisk here, which implies that you are currently on the master branch, and whatever I've added in my shell configuration file is also helping me see in which branch I am working. And now you will understand why something like this is so powerful. So now I want to go to this branch. To go to this branch, you use a command called git checkout, and then you type the branch where you want to go. So I'll add feature login here. I'll press enter, and it says switched to branch feature login, and you see you are on feature login here. So if I run git branch now, you would see that feature login has an asterisk. But One more thing, I followed a two-step process. First, I created a branch and then I switched to that branch. What if there is a single command that does both of these things for you? And yes, there is a command. So while we are at it, let's delete this branch. Git delete feature login, not git delete. It is git branch hyphen d feature login. This is the command. Hyphen d is for delete. That is how you delete a branch. And then you press enter and you see a message here: cannot delete branch feature login used by work tree this. Now what this is simply saying is you cannot delete a branch that you are sitting in, and we are sitting in the feature login branch. So let's delete this branch first. So first let's git checkout master. Let's go to master and then run the same command again. So this branch is now deleted. Now let's create and check out the branch with a single command. So I will write git checkout hyphen b and the branch name I want is feature login. So what this will do is this will create the branch and also switch to that branch. You see it has created the branch and we are in feature login branch. You can run git branch to also know this. Now let's run git log hyphen one line. What did I tell you? Head points to the currently checked out branch. Previously, where was head pointing? Head was pointing to master because we were in master branch. And here head is pointing to the feature login branch. And what did I also tell you? We created feature login branch from this commit, from third commit, which is why feature login branch pointer is pointing to this commit itself. And once we make new commits in feature login branch, then of course it will point to that commit because branch is a pointer to the latest commit. Now since feature login was created from third commit in the master, it is pointing to the third commit, and master is also pointing to the third commit. And if I go back to my diagrams, we saw this here. When you create a new branch, it points to the commit from where that branch was created. So this branch was created from C in our demo, hence it is pointing to this, and master will be pointing to the latest commit on that branch, which is also the third commit that you see here. Now let's see what I want to do next. And before I do that, I want to tell you that when I created this feature login branch, it does not copy code or create a commit. It simply creates a new pointer to an existing commit. And what is that existing commit? The commit from where you created that branch, and we created this branch from commit 3 that you see here. Let me clear my screen for few more headroom. So if I run git log one line, I see this is here, and I also want to compare something. So I'll run git checkout master, and then here also I will run git log one line. So what we see here is this, and now I will again check out feature login. Now before I run anything here, I will type ls. You see this has visibility on app.txt. And why does it have this visibility? It has this visibility because app.txt was created in our initial commit. In this commit it was created. We added a line in this commit, we added a line in this commit, and we added a third line in this commit, which is why if I am on feature login branch and I cat app.txt, I see all the three lines. Because what did I tell you? Branches are just pointers. So now what I want to do is I want to perform a commit in this branch, and if I perform a commit in this branch, that something will not be available for the master. Remember, what did I tell you? If I am making this commit here, branches are independent line of development. This branch master will not be able to see this commit history because it is independent line of development. So let's do that. So I will copy this and then I will paste it here, and then I'll press enter. So this is the commit that I'm doing in the feature login branch. And now watch very carefully. If I now run git log one line, you see what happened. Head is pointing to feature login, which is obvious because feature login is the currently checked out branch, and feature login is now pointing to the latest commit on feature login branch, which is this one, which we did just now. C6F 6F, feature implement login functionality, feature implement login functionality, and again master is pointing to this commit. It is the third commit, and now comes the interesting part. If I run ls here, I see login.txt, and if I cat login.txt, I see this here. But if I git checkout master, and if I now run ls, I don't see login.txt. What did I tell you? Branch is independent line of development. Master does not have any visibility into app.txt. But how do I bring that visibility to master? Now, if you want to bring the visibility of login.txt or whatever you have done in this feature login branch to master, then you will have to merge this branch with master, and that is what I want to work with next. I want to tell you what is branch merging. So let's go back to our diagrams. I will come here and then I will scroll down, and here we see git merge integrates commits from one branch into another. There are two types of merges that are mostly used. First is the fast forward merge, and second is a three-way merge. Now there are other merging strategies that are used. Those strategies are octopus, hours, subtree, and there could be more, but 99.99% of the times you would be using these two strategies, which is why we will only discuss these two strategies. Now I want to discuss branch divergence, because once you understand branch divergence, then understanding these merges become easier, because fast forward merge happens when there is no branch divergence, and three-way merge happens when there is branch divergence. So we must first understand branch divergence. So what exactly is branch divergence? Branch divergence occurs when both the branches introduces new commits after the common ancestor. What is the common ancestor? Anything that you see in square brackets is a common ancestor. And what is a common ancestor? Common ancestor is a commit that is shared by both the branches. If I talk about this diagram, who is the common ancestor? Common ancestor is C, because it is from C where this branch was created. So feature login branch can see C, master can also see C, which is why we say common ancestor commit is the most recent commit shared by both the branches, and this is the most recent commit which is shared by master and feature login. If I talk about this diagram, it is also commit C, because commit C is the recent commit that is shared by both master and feature login branch. Why not F? Because feature login does not have any visibility about F, because feature login was created from C. If feature login was created from B, then the common ancestor for both of these would have been B, because again I am repeating the definition. Common ancestor commit is the most recent commit shared by both branches. In this example, commit C is the common ancestor. In this example as well, commit C is the common ancestor. Now, what does branch divergence means? Branch divergence occurs when both branches introduce new commits after their common ancestor. Now, if you see this diagram, only feature login branch has new commits after the common ancestor. Master does not. So this is not branch divergence. Here you see both master and feature login has new commits after the common ancestor, which is why we say in this diagram there is branch divergence. Now I hope the concept of common ancestor and branch divergence is clear. So let's understand what is fast forward merge. Occurs when the target branch has no new commits. Now what is target branch? So when we talk about merging, and that is what we are discussing, something that you are about to merge is called source. So for example, in this scenario, in our example, we are merging feature login with master. Hence feature login becomes the source and master becomes the target. So because you are merging feature login with the master branch, occurs when target branch has no new commit. So the target branch has no new commits, and of course feature branch will have new commits, and that is the reason you are merging to begin with. If I didn't have anything worth merging in feature login, if I didn't have any commits in feature login, then why would I merge that with master? That is why we are saying occurs when the target branch has no new commits. So here the target branch has no new commits, but what we want to do is whatever work we have done in feature login, and the work that we have done is we created this login.txt file. We want this login.txt file or whatever you have done in that feature login branch to be accessible to the master, and for that we'll have to perform that merge. And the second point is no new commit is created. When a fast forward merge is performed, no new commit is created. It is just that the branch pointer, this master, will start pointing to commit D. So no new merge commit is created. On the contrary, here merge commit is created. We'll discuss this later. But here with fast forward merge, no new commit is created. It is just that the branch pointer simply moves forward. Commits are not moved and copied like we have told before. Commits are not copied when you create a new branch or when you are merging. It is just that the branch pointer simply moves forward. So in this example, let's see what we are doing. And this is exactly what we are going to do in our demo as well. So here you see master, and master is the target because we want to merge feature login, which is the source, with master. So here C is the common ancestor, and now we first run git checkout master. Why we are running this? Because the merge command is always facilitated from the target, because that is where you want to merge the incoming branch, and the incoming branch, the source branch, is feature login, and then you just run the command git merge feature login. As simple as that. And once you do that, you will see a structure similar to this. Now understand, this is very critical. I told you branch pointer simply moves forward. So master has now started pointing to commit D, and this is commit D, whose history was moved from feature login to our master branch. You can see here branch pointer simply moves forward. Target branch has no new commits. You don't see any new commit. It is just D that is now part of master's history. Git simply moves the branch pointer forward. So let's do this practically and see how it looks like. So I am here. I will first clear my screen so that we have some more real estate. And then I am already in master. But if you are in feature login, then come to the master branch using git checkout master. And then I will run the important command. I will run git merge feature login. I will press enter, and this says the merge has happened, one file changed, one insertion. So now let's run git log hyphen hyphen one line, and you see what did we discuss. Master has now started pointing to this commit. Previously master was pointing to the third commit, and feature login of course was already pointing to this one. And now another important thing, feature login branch is already merged and we are on master. And if I run ls now, login.txt is now available here because master now has access to the branch that was recently merged with master, which was feature login. So if I cat this, I see whatever we added is here. Now I want you to notice one more thing. We have performed a merge, but there is no history here, right? Nothing says that a merge was performed. How do I know a merge was performed? I can run something called git reference log command. Now, git log only shows you the commits that were performed. And what did we learn? There is no commit created when you perform a fast forward merge, right? What we said is it's just master now gets integrated with the history of feature login branch. So commit D is now available to master. That is what we said. But there is no merge commit. So how do we know a merge was performed? You can check that using git ref log. If I press enter, you can clearly see here a fast forward merge was performed. Now, why is git ref log important? So it will tell you the entire history, commits, checkouts, merges, and in the future we'll be discussing resets and rebases. You can always find the detailed history in reference log, and you can see here it says that a fast forward merge was performed. I hope this is clear. Now feature login branch has no use for us, so what I will do is I'll write git branch -d feature login. I'll press enter, and if I now run git log one line, you see there is no reference of feature login. It is gone. Previously we did have feature login here, right? But now feature login is gone because we have deleted that branch. Why we have deleted that branch? Because the work that feature login was supposed to do, it already did. It gave me a working login.txt, and since I merged whatever was there in feature login in master, I deleted feature login. So easy to understand, right? So I will now clear my screen, and then I want to show you a diagram where we see whatever we have done thus far. So I will move to the left. I'm showing these things to you because I want you to have the complete end-to-end picture, because once this sticks with you, it stays with you, right? So what did we do in this demo? We created 3 commits, then we checked out a feature login branch, and once we did that, we saw both master and feature login were pointing to commit C, and then we did a new commit in feature login branch, that was commit D, and then we ran git merge feature login, and this was a fast forward merge. And why it was a fast forward merge? It was a fast forward merge because there was no branch divergence. Branch divergence would have occurred if there were new commits in both the branches from the common ancestor. So C had D, but this master did not have any new commits, which is why there was no branch divergence. Hence, fast forward merge was performed for us, and branch pointer moved forward to D. And finally, in the last step, what we did was we deleted feature login branch, and delete branch pointer commit remains. Commits that were part of feature login branch remain in the history. So this is the state we are in right now. I hope everything is understood. Now let's discuss three-way merge. Firstly, why is it called a three-way merge? It is called a three-way merge because while merging, Git accounts for 3 things. First is the base, which is the common ancestor, and then it also takes into account the latest commits in feature login and in master, because these are the branches in question, which is why we are talking about these. If these branches had different names, we would be calling them with that names. Now I want you to know from this point itself that you can also create a new branch from feature login, and then you could be merging whatever branch you created back to feature login. So do not limit yourself to thinking that whatever merges are performed, everything is performed in the master branch or the primary branch. It does not work like that. It could be the most common design, but branches can be merged with any branch that you want to. I hope this is clear. Now let's talk about this. So we said that three things are compared. First is the base, that is the common ancestor, then ours, that is target. Target is this one, the master. I move target and source here now. So ours is latest commit on the current branch. So in target, that is F. In theirs, latest commit on incoming branch. So what is the latest commit on the incoming branch? It is E. So while performing a three-way merge, common ancestor F and E will be considered. Occurs when both branches progressed independently, and this happens when there is branch divergence. From common ancestor, you see both the branches have new commits. Git creates a new merge commit. Now this is an important concept to understand. With three-way merge, a new commit is created for you. Now let's see what does that mean. Here you see you had D, you had E. When you performed the merge, there was a new merge commit created, and this merge commit was a resultant of a three-way merge. Merge commit links both the branch histories. Now merge commit will have histories of both the branches, which is why when you look at the history of master, you would see the merge commit as well, along with E, D, and all these commits. So master already had 1, 2, 3, 4 commits. It will now also have 5, 6, and this 7th commit as well. And merge commit is helping by linking the history of both the branches, and that is why master will have visibility to all of these. Now once this merge is performed, we can always delete this feature login branch or whatever branch you were dealing with. Now let's go to the CLI and perform a demo for this. I'll come here, I will hit ls, and what I'm doing is I'm continuing the same demo for git merge conflict, because I want you to know the entire workflow. I could have performed these demos in silos and it could have been easier, but I wanted you to have the complete picture end to end, which is why I am using the same files in continuation. So let's see what I want to do next. Now I will create a new branch, git checkout -b, and I will call this bug fix typo. So let's say we are bug fixing a typo error with this branch. Understand, in master I already have app.txt and login.txt. Since I am creating this branch here, and by default we know the branch gets created from the latest commit, so the latest commit has both of these files, which is why when I run git checkout -b bug fix typo, I will have both of these files accessible in the bug fix typo branch. So I'll press enter, and this says that we have created the branch and we have also checked out that branch. Now if I run git log one line again, then you see the same thing. I see all the 4 commits which were already existing, because remember where we left here. And what was this state? This state had 4 commits already. So we already have all those 4 commits. It is now that we have created bug fix typo. Bug fix typo is pointing to the same commit from where it was created right now. So once we have more commits in here, it will start pointing to them. And as we know, branches points to the latest commit and head points to the currently checked out branch. And we also know there is an exception when there is a detached head scenario. In that scenario, head will point to a commit and not to the currently checked out branch, and we'll see that later in this course. Now I want to show you one more thing right now itself. So let's do one thing. I will git checkout master. I will delete what I created. Okay, I will write git branch -d, and then what was the name of the branch? It was bug fix typo. I have deleted this branch. Now what I want to do is I want to recreate this branch git branch git checkout -b bug fix typo. But this time I want to create this from a different commit. So by default, if I press enter, it gets created from the latest commit. But this time I want to create it from this commit, the first one. If I paste this commit here, this will create this branch from this commit. And if I now press enter, it says that it has switched to this branch. So if I now run git log -- one line, the important thing, guys, I want you to understand is, see, now it is pointing to this commit. It does not know anything about the files, the lines that are added in this commit, or login.txt that was added in the fourth commit. If I press ls, you see only app.txt exists, and app.txt will only have one line, because in our initial commit we only added one line. In commit 2 we added second line, in commit 3 we added fourth line, in commit 4 we added a new file altogether, login.txt. But we have created this bug fix typo branch from here, hence this will only know about the first line. So if I do cat app.txt, I only see the first line. And understanding this is so critical. This is the one that will connect the dots for you. So what has happened right now is, if I show you here, so what we have done is, we have, instead of creating this from commit D, I mean, this diagram is not doing justice. Let me show you the diagram that is meant for this one. So this is the three-way merge that we are trying to do. So we created a bug fix branch. Initially, we created it from commit D, but now I created it from commit A. So if I create this from commit A, then bug fix typo will not point to D. It would point to D if I would have created it from the latest commit in the master. I have created it from the very first commit. So this is now pointing to commit A. That is what you see here. It is pointing to the first commit. I hope this makes sense. Okay. I will now run git checkout master, and then I will again git branch -d. I will delete this bug fix, and then I will recreate it. And this time I will not be naming a commit, because I want to create this from the latest commit itself. Now if I run git log one line, I would see all the 4 commits here. Now let's do a new commit in bug fix typo. So what I am doing here is, I am creating a new file called bugfix.txt, and I'm creating this file in bugfix typo branch. And then this is the commit message I am doing. I'll press enter. Okay. If I now run git log one line, you would see that now bug fix typo is pointing to this 5th commit, and this 5th commit that we have just performed, now bug fix branch is pointing to that commit, because a branch points to the latest commit. And then you have head, which is pointing to the currently checked out branch, which is bug fix typo. Now let's add some new work in master as well. But Varun, why are you doing so? Now to demonstrate branch divergence, what do I have to do? To demonstrate branch divergence, I must have new commits when compared from the ancestor in both target and source branch. So in source branch, we have already added a new commit, and let me show you the exact diagram. So what we have done thus far is, we have added this commit. Okay, this is our git merge 3-way. So we have added this commit. Now what we are doing is, now we are adding commit F in the master. So let's go to the CLI. And again, I'm doing this in continuation because I want you to understand how typical workflows look in production. So git checkout master. And here, what I will now do is, I will add some change in master as well. So what I am doing here is, I am again creating a new file, layout.txt, git add layout, and I'm adding this. Now, if I run ls, I see layout.txt and app.txt and login.txt already exist. Okay. But if I check out git checkout bug fix, and if I run ls here, I won't see layout.txt, because layout.txt was created here, right? And our branch was created from D, so it will have knowledge about E and of DCBA, but not of F here. Okay, I hope that point is clear. So now, since we have done this, I will run git log one line. This will show me only bug fix. Okay, but what if I want to see everything? And even when I'm here in this branch or from any branch, I want to see every commit that has happened. I can add hyphen hyphen all. So this will show me all the commits. So see, now it is showing master as well. So this is the commit that we performed in bug fix, and this is the commit that we have performed in master just now. Now what I want to do is, now I want to perform a three-way merge. So what I will first do is I will go to the branch where I am merging the incoming branch, and that branch is master. So first I will go to master, because like you see in these diagrams, you must be in the branch where you want to merge an incoming branch. So I will be in the master, that is the target, and I will be merging the source, and the source is bug fix typo for us. So let's go to the terminal, and here I will write git merge bug fix typo. And as soon as I did it, it opened an editor for me, and in this editor you see a commit message is already there, and this is a genuine commit message. Most of the times you will leave it as is, but for now I will just add a VJ here, Varun Joshi, so that we know that this was something that we modified as well. So this is merge branch bug fix typo, which is a good commit message. I'll have save this, and now you see it says merge made by the ORT strategy bugfix.txt, one file changed, one insertion, and whatever this is. And previously, what did we create in bugfix? We created bugfix.txt, right? And we are in master. If I now run ls, bugfix.txt is here because the merge was successfully performed. And if I run git log one line, then you see currently checked out branches master, and now there is a merge branch typo VJ. So this is the merge commit. Now what I can also do is I can see what is inside the merge commit. So what I can do is git show, and what is the merge commit? This is the merge commit, right? So I can copy this, I can paste this here, and it will show me who all are the parents of this merge commit. And you see here merge, this is a merge commit, and the parents of C6 is DD and E5. DD and E5. E5 was the commit that was performed in bugfix, and this was the latest commit that was in that, master branch. And when we merged this branch bugfix with master, a merge commit was created, and this merge commit is saying my parents are this and this. See how simple it is to understand. Now I want to show you one more thing. Git log one line. I'm adding one more thing here now. Graph. This will show me properly what happened. So the asterisk that you see here at the very first, they belong to a single line of development, and asterisk that you see here, they belong to a different line of development. For example, this commit ID belongs to bug fix typo, and even if I delete the branch, I will see this kind of design itself. That's the reason when you look at my diagrams, even when merge is performed, I still show it like this. I do not move this here. That is because this, when you run git log, it shows you history in a similar fashion, which is why it is denoted in a similar fashion in diagrams as well. So if I go here, it clearly shows me that this was, a merge commit, Okay, and then this was a different line of development, and this line of development had this, fix correct footer typo. And then this was the commit that was in the master branch itself, which, because this asterisk is at the extreme left, this line is representing master right now, and this asterisk is representing bug fix typo, anything that was committed in bug fix typo, because git log only shows you the commits. If you visit git ref log, it will show you more. I hope that point is clear. Now, one thing is this, and you can also see this in Visual Studio Code. So if I go to Visual Studio Code right now, we are dealing with project files. Okay, and if I go to this symbol here, and then if I click here, you might not see this right now. So if you go to your extensions, search for git graph. So git graph is the extension which is helping me view this in a better way. So now let's go here and then click here. So you install git graph. If you don't see this, now you see whatever we did, I mean whatever we saw in CLI is available in the GUI format as well. So this will tell you your commit hashes, short form of commit hashes, who was the author, what was the date, and all of these things. And you can even click on these to know more about these things. So how good is that? So I would suggest you'd run these commands in your lab so that you also understand how this structure works. Now that we understand this, okay, we understand fast forward merge, we understand three-way merge. Now let's understand what are merge conflicts. But before we do that, let me do one more thing. I will delete this branch. I will run git branch -d. And what was the name of this branch? Bug fix. I'm sorry, bug fix typo. And now if I run that again, the graph remains the same, guys, but it is just that bug fix typo is not shown here. But if you want to know what was the name of the branch that resulted in this, you can always run git ref log and it will show you what all things happened. You see that bug fix typo, it is retains the history, even the checkouts that you are performing, git checkout, feature login, git checkout master, it will tell you all of those things as well. So git ref log is the command that you would be using a lot. Now that we understand it, now let's go to diagrams and see what I want to discuss next, and that is merge conflicts. Why a merge conflict occurs? Branch divergence does not cause conflicts. Overlapping changes cause conflicts. Now understand what we are saying. We saw branch divergence before, and Git was able to merge successfully. And why Git was able to merge successfully? Git was able to merge successfully because in this we added a different file, in this we added a different file, and when a merge was performed, Git kept both of those files for us. Okay, but what happens when you are dealing with a single file and you modify the fourth line? This commit would have modified Varun Joshi is a teacher, and this commit, let's say, would have modified Varun Joshi is a good teacher. Both of those lines, both of these lines are different. How would Git know which line to keep? Git cannot decide that for you, right? This results in merge conflicts. When you make changes in the same line, in the same file, Git cannot take the decision which line to keep for you. Hence, there is a merge conflict. So what is a merge conflict? A merge conflict occurs when Git cannot automatically combine changes from different branches because the same part of a file was modified differently. This is the important piece. Both branches modified the same line differently. Like I said, let's say we have app.txt, it has footer color changed to green, and then another branch, that is conflict demo in our example, changes app.txt to have footer color changed to blue. in the same line. So if they are in different lines, that's a different scenario altogether. But if these are, let's say, in the fourth line, then how would Git know which line do we want? It would want your help to decide which line to keep. Hence, you must resolve these conflicts yourself and then move forward. This is all a merge conflict is. Okay, so let's go to the CLI and do a demo on merge conflict. So I'll clear my screen here. I am again continuing from the same place where we left. So git log one line, and we have 7 commits. So if I show you the diagram for this is the diagram. We are starting here. We have 7 commits. So we are starting from here. So let's go to our terminal, and then I will create a new branch, git checkout -b conflict demo. I'll press enter. Understand that app.txt already exists. So if I cat in app.txt, it already has these 3 lines that were available from our initial 3 commits. Okay, so if I add this, what I'm saying is footer color changed to blue. I'm writing in app.txt and I am in conflict demo. So in conflict demo, I'm writing the color blue. Let's say I'll press enter. And if I cat app.txt, this has footer color changed to blue. Now what I will do is I'll do git checkout master. Now what I will do in master is I'll modify the same file. I'll modify the same line there. Okay. So if I cat app.txt here, it has only 3 lines. It does not have information about the 4th line, and we know why. We are studying this from the very beginning. Okay, so here I am adding footer color change to green, and I'll press enter. So if I cat app.txt here, it has footer color change to green. If I look at conflict demo, it has footer color change to blue. We have modified the 4th line in both of these, and now we want to perform a merge. Git will say, dude, how would I know which line to keep? You tell me, how would I decide? Now I will run git merge conflict demo. And again, I am in the target branch, that is master. You have to run merge commands from the branch where you want other branch to merge. Okay, so that's why I'm running command from the master branch, which is also the target branch. I will press enter now, and auto merging app.txt conflict content merge conflict in app.txt automatic merge failed, fix conflicts and then commit the result. And you see this prompt has also changed, master pipe merge. And if I run git branch, we are already in the master branch as this shows, but this my prompt is also telling me there is some problem that you need to fix. But Varun, how do I fix that problem? I don't see anything here. So I will go to Visual Studio Code here, and I will first close this. I will go here, and you see this app.txt has an exclamation mark. I go here and it says, and head, this says current changes, and head implies the currently checked out branch, which is the master in our scenario. Footer color changed to green. It is saying that when it comes to master, you have that line, and this is true. Master has footer color changed to green, and this is the separator here, and this is saying footer color changed to blue when it comes to conflict demo, and that's conflict demo has footer color changed to blue. Where is that? Yeah, footer color changed to blue. So what it is saying is, what is that you want to do? Now either I can edit this directly, I can remove whatever I want and I can do it, or Visual Studio Code is telling me accept current changes, as in I want this to be there, accept incoming changes, I want this to be there, this, accept both changes, so as in have a 4th line and have a 5th line, or compare changes. Compare changes is simple, it will tell you what is changing. I don't want that. What I want to do is I want to, let's say, accept incoming changes, or let's do accept both changes and see how it works. So if I do this, then this green will be discarded and this will be taken. If I do accept current changes, then green will be taken and this line will be discarded. If I accept both, I will see both. So let's do accept both. I'll press this and you see, first I see green and then I see blue. How good is that, right? Now I've saved this, but if I go here to my terminal, I still see this master merge, but I have fixed the problem, right? But if I run git status, that file is modified. It is modified. So what I will have to do is I will have to move this file to the staging area, and then I will have to commit this file and see how this works. So I will just write git add app.txt. I'll press enter and see the merge is still here. And then I will just write git commit. I'm not providing a commit message. I'll press enter. Voila. And you see merge branch. It is saying, I told you that three-way merge always creates a merge commit. But to be descriptive, I'll still write here resolved merge conflict. I'll also write accepted blue green because we said both. So I'll do escape shift ZZ and you see now master is alone. There is no merge here. I hope this makes sense to you and I can run that command again. Git, let me type it, git log one line, and you see everything is here now. And if I also write graph here, then you would see the entire graph that there was a new line of development which was called conflict demo. And now that the merge is successful, what I can also do is I can write git branch -d conflict demo, and then I can run this again. I don't see that anymore. What I can also do now is I can run git reflog, which will tell me everything step by step, whatever happened in my git repository, starting from the initial commit that was chore initialize application. And I can also go to Visual Studio Code. I can come here and I can visualize this here as well. And you see how Visual Studio Code is adhering to the same structure that you see here. Okay. And it is also having different colors. So here you have different colors. That implies that this was a different branch and this is a different branch, which is why you see different colors. And this commit here represent a commit that was performed in this branch, this line of development. And similarly, this implies this commit was performed in this line of development. It is imperative to understand these graphs. Okay. And similarly, this is saying the same thing. And then details can be found if you do this. And similarly here, if you write git log, just git log and remove everything, then it will show you everything in detail, all these commits. And I'm not sure if decorate or graph will work here with this. Yeah, you can also see graph. Okay, longer commits and all these messages. If you want, you can see that as well. I hope these things are clear. Now let's see what I want to discuss next. What we have seen thus far is we are working with the master branch. What you can also do is you can run the command git branch -m master. That's the current name, and I want it to be renamed as main. So this is what you can do. If I press enter, you see it is now renamed as main. So if I now run this git log one line graph, for example, it will show me main here. So that is one way to do it. But what I want to do is whenever I initialize any repository for user Varun Joshi, I want the branch name to automatically be main. So for that, what I can do is I can run this command, and this command was shown to you when we ran git init initially. So here I will write main, and this will ensure whenever a new branch is created on this machine, it is always created with the main name. And since most of our work is done, what I will do is I will do rm-rf dot git, and then I will run rm-rf star. That will delete everything that is in this directory. And you see now the name is gone. So if I, let's say, initialize this again, git init, you see automatically I am given the name main, and the lengthy message that we used to see is no longer here. I hope this is clear. Now I will clear my screen. I will do rm-rf.git again, and I have project files. Now the last topic that I want to discuss today is undoing commits, because we are humans and we make mistakes. So there must be some way via which you can undo a commit, and that is what we are discussing. There are multiple ways to do it. You can use git reset and git revert to undo commit. During development, you may realize that a commit was incorrect, incomplete, or no longer needed. Hence, you must have ways via which you can undo a commit. I again want to reiterate what I said at the very beginning. A commit is an immutable snapshot. You cannot change the commit hash. Of course, you can change the commit, the files that were part of a commit, the directories that were part of a commit, but you cannot change the commit hash itself. So even when you are undoing commits, what changes is the history. It is not that you are modifying the commit. Of course, there are ways via which you can delete a commit entirely, and we'll see that in the later part of this course. So we have techniques which will help you undo the commits in some way. When you use reset, you can, you can rewrite the branch history. When you are using revert, you are creating an additional commit. So let's see both of these in detail. So first we'll discuss git reset, then do demo of git reset, then we'll do git revert and demo of git revert. Moves the branch pointer backward to an earlier commit. So for example, if let's say commit C was a mistake, then you would say reset me to commit B. And when you do that, you get this. A and B are here. C will no longer be part of the history for main. I am saying it will no longer be part of the history of main. I am not saying the commit will be deleted. So mark my words. Second point is rewrites branch history, which is true. Previous history was C was there. C was the commit on which the branch was pointing. And when you run git reset B, understand, if I want to undo C, I won't run git reset C. I will say reset me to commit B. That is what I would do if I want to discard, let's say commit C was a mistake. I will do git reset B. This will take me here, and C will no longer be part of history of main, used for correcting local commits. And this is the key part here, local commits. When you are working with remotes, things change. It's likely that you would be using revert, but when you are working with your local development that only impacts you, then you would be using git reset, because it simply move branch pointer. And how it moves, for example, if you reset to B, the branch pointer will move to B and C will no longer be part of the history. So let's go to our CLI and do a demo for this. I'll come here and I will first run git init, and then I will add feature A like this. Then I will add feature B like this. I'm just creating a few commits. Okay, so we have something to work with. And then I will add third commit. So what we have done is we have app.text, and in app.text we have added 3 lines: feature A, feature B, and feature C. So if I cat app.text now, I see feature A, feature B, and feature C. Now let's say feature C was a mistake. So I can also run git log one line here. And you see what we have seen thus far. Head points to the currently checked out branch, and the branch points to the latest commit in that branch. Now, like I said, let's say feature C was a mistake, commit C was a mistake. What I will now do is I will run git reset, and then I want the commit hash. What is the commit hash that I want to reset to? Again, if you use this, you won't see anything. Let's say you wrote this, and if you run log one line, you still see the same thing. I told you, when you are resetting it to what was there in commit C, and commit C was this only. You want to reset to commit B so that commit C is gone from the history, right? So I will run git reset, and then I will type the hash for commit 2. I'll paste it here, I'll press enter. Unstaged changes after reset, but before I do anything, git log one line. Commit C, commit 3 is gone, right? If I cat app.txt now, I see A, B, and C, all three are there. But let's see what will happen now. So if I run git status, you see this file is modified. Now this has feature C, but now app.txt is modified. Now what we want to do is, I will now correct what I wanted to correct, and then re-add that file. So if I do vim app.txt, then I can always write here feature C added a few more things. Let's say I wanted to add this. I'll hit Shift ZZ. Understand what is happening right now. See, our that commit is gone. Our file is now in the working directory. We have been asked to modify that file, and we will reperform a commit. So we'll have a new commit, but the commit that was here, commit C, this is gone. I don't see it anymore here. Commit ending with 2.1, I don't see it anymore. So that is what is happening. But if you run git reflog, you might be thinking, Varun, but I will never know what was here. I mean, whether there was a commit 3 ever, how would I know that? So if I run git reflog, I see that commit, this commit C, it has 1 to 1 at the very last. You see 1 to 1, you see a reset there. Reflog will tell you that someone did a reset. Now we have made changes in our app.txt. If I see it, we have added a new feature. Now I can simply run git add app.txt, and then here I can run git commit -m, and I will have a commit message, and let's call it feature, and then I will say add updated feature C. That's it. And let's do this uppercase, and let me spell this correctly, and then I'll press enter. And if I now run git log one line, then see, you have this with the new commit message. And if I, of course, now if I cat that, it will also have that, and there is a new commit that was created. But if I run git reflog, it will tell me that there was a reset that was done. I hope this is clear. Now let's go to our notes. I want to explain you a few more things. I'll go at the very top. And if I talk about reset, there are different types of reset. So let's see what are these. In this example, we have commit A, B, and C. Then let's say commit C added a new line to app.txt, and that line was login feature added. Now, if you run git reset B that we just did, this is called a mixed reset type. And what is mixed reset type? What happens? Branch moves back, changes becomes unstaged. That is why we had to run git add again. Example is commit C is no longer in branch history, which we saw when we ran git log, but the line remains as an unstaged change. So that line was never gone. Feature C was still written there. And finally, what would be our next action? Our next action was edit if needed. then we ran git add, and then we finally committed again. So this is the default that you would use 99% of the times. Now let's say when you were performing a commit, your commit message was wrongly put. In that scenario, you can use hyphen hyphen soft reset type. Branch moves back, changes remain staged. In here, changes were unstaged. You had to run git add again. But in here, changes remain staged. So you won't have to run git add again. But here is the key part. Commit C is no longer in the branch history. We understand that because we are resetting. But login feature added is still staged. So you have the file that is already staged. Next action would be you will have to recommit it. So you would recommit with possibly with a corrected commit message. So soft is typically used when you want to correct your commit message. Last one is hyphen hyphen hard. Branch moves back, changes are removed from working directory. So if I had used hyphen hyphen hard in our example, then feature C, which was our third line. So if I go to our terminal, this line that you see here, features C, this line would have been removed, and commit changes are removed from working directory. Commit C is no longer in branch history, which is obvious because it's a reset, and the line is removed from app.txt, which we just discussed. Feature C, if there was, will be removed. Here you can start fresh, make changes, stage, and then commit again. I hope this makes sense. 99% of the times, rather 99.99% of the times, you would be using the default, which is hyphen hyphen mixed. The commit is not immediately deleted. It becomes unreachable from the branch and can often be recovered using git reflog. And we'll see as we progress with our lectures how this works. Now, let's talk about the other type, that is git revert. Git revert creates a new commit that reverses an earlier commit. So what this will do is creates a new commit that reverses an earlier commit. So let's say in commit C, you added a third line called feature C, and then you hit git revert. Then feature C line will be removed and you will get a fresh start from here. But why this is used is it preserves the history. So commit C still stays, but the commit D that happens does not have the changes that were done as part of commit C. So for example, let's say you had 10 files and you deleted 2 files as part of commit C. When you revert this, commit D will not have those 2 files deleted, as in creates a new commit that reverses an earlier commit, preserves existing history, commonly used in shared repositories. Now, what are shared repository? Shared repository is a repository that is hosted on remote, like GitHub, which is used for collaboration, that is used by multiple developers for collaboration, as we have seen thus far in this lecture. Git log will show both commit C and D, that is history is preserved. And why this is useful? Because when you are collaborating with different engineers, when different engineers are working on a single repository, then you would want that whatever changes you did mistakenly should also be visible to others, so that others know why something looks like this. Hence it is important that you know git revert is predominantly used when you are working with shared repository, and git reset is used when you are working locally, that is your changes only impact you. Simple rule: if the commit exists only locally, git reset is usually appropriate. If the commit was already pushed, use git revert. So if you have pushed once, then it is recommended you always use git revert so that the history remains intact. Now let's see a demo for this. I will go to item. So this is the last topic. I'll end this lecture after this. Then I will do rm-rf.git. Do we have any files here? rm-rf app.txt. Now what I will do is I will again have 3 commits, right? I'll copy these three commits, and this time I'll copy all of them at once. I was copying one by one because I wanted the commits to have different timestamps, but now we already know those things. So I'll press enter. And as expected, I should be running git init first, and I'll run git init, and then I will do this commit. So if I run git log one line, I see I have three commits with feature A, B, and C. What I can now do is git revert. Let's say I want to revert whatever was done in the third commit. Now I want you to know one more thing. I can either type the commit hash, or I can just type head. Head, head points to the currently checked out branch, and currently checked out branch is pointing to the latest commit. So if I write head, head implies this commit. If I write head tilde 1, this implies this one. If I write head tilde 2, it implies this one. So head 1, 2, and so on. So with git reset as well, if you don't want to specify a commit id, you can also specify this, but I have always preferred commit ids. So I will write git revert. I want to revert what was done here. So what was done here, we added feature C, right? So I will add this here. I'll press enter, and this says revert feature, add feature C. Now this is the commit message I want to see. Understand what did I mention. When you are using revert, the history is preserved, and which is what we learned here. Preserved existing history creates a new commit that reverses an earlier commit. So if I go here, I'll save this, and if I it shows me one file changed, one deletion. So if I run git log one line, I see that here feature C exists, okay? Because this commit has not gone anywhere. What we now have is we have a new commit that says it was part of revert, and then this was the automatic message, and these are always good. I mean, you can keep it at here, or maybe you want to add some more, words to it, you can. So feature, add feature. See, now what I would now see is if I do cat, first let's run git status, you don't see anything. But if I cat this file app.txt, you would see that feature C is gone, because that part was done by me by mistake. So if I had deleted, let's say 30-40 files, or I would have changed code at multiple places, and if I wanted to go back because I messed up something, then I can quickly use git revert, and it will take me back to the working stage. And working stage, let's say in our example, was this one, when commit third was not performed. So git revert is extremely useful when you talk about such scenarios. I hope this is clear, and I have discussed all that I wanted to. That concludes part 1 of Git Masterclass. In this lecture, we explored the core foundations of Git. You saw how Git manages history through commits, how the working directory, staging area, and repository interact, and how branches enable safe parallel development. We also examined fast forward and three-way merges, why merge conflicts occur, and how to resolve them. Finally, we looked at how to undo mistakes using git reset and git revert, and the differences between writing history and preserving it. These concepts form the mental model required to use Git confidently in real engineering environments. In part 2 of Git Masterclass, we will explore remote repositories, push and pull workflows, pull requests, rebasing strategies, and collaboration pattern used by real teams. If you have any questions, feel free to ask them in the comments section, and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi, and welcome to part 2 of this 3-part Git masterclass. Initially, this was planned as a 2-part series, but when I started working on part 2, I realized that to properly cover how Git works in production, this needs to be a 3-part series. In part 1, we already built a strong foundation by understanding how Git works locally, including commits, branching, merging, and history. In this lecture, we move into collaborative and production grade workflows. We will start by understanding why remote repositories are needed, how they act as a shared system. Then we will look at authentication and how your machine securely communicates with the remote. From there, we will be doing a hands-on demo connecting local repository to GitHub and pushing changes. Next, we will understand Git fetch and Git pull and how changes flow across developers. We will then introduce pull requests and see how teams control and validate before they enter a stable branch, followed by a production style workflow demo. Finally, we will understand Git stash and how it helps safely switch context when working with incomplete changes. By the end of this lecture, you will understand how Git evolves into a system for managing collaboration and controlling changes in production. So let's get started. Understanding remote repositories. Firstly, why remote? Why do we need a remote? So up until now, we have been working in silos. So let's say we were this developer. What we did was we performed changes, commits, all of those things into our local system. And when things are there only in your local system, then how do you do collaboration? We know that we want a remote system that understands Git. So if you are dealing with, let's say, a shared file system here, and both dev1 and dev2 have access to that shared file system, you can of course store your code here so that dev1 and dev2 can download the changes that either one of them has done or modifications that either of them has done. But the problem is that file share will not understand Git commands. So we want something that understands the Git language, because when something understands that language, we can speak to the system with the interface that is Git that we are already familiar with. So without that remote system right now, the work is only local and there is no collaborative environment which works and understands the Git language. Independent changes is another. So for example, if dev1 is doing certain changes and applying those changes, then dev2 wouldn't know completely what those changes were, and this can always lead to conflicts during your merging process. No shared state that is understandable, no single reliable system to version everything. Lastly, there is no backup. So as I mentioned, all of these developers will be working in silos. We want some place that understands Git and also acts as a place where you can have backups of your entire code, and backup that is highly available. Because right now, if developer 1's laptop crashes and developer 2 does not have the recent changes, then the work is gone. We want some place that is highly available, that is fault tolerant, so that even if something dies, some hardware underneath dies, our code still survives. So we want all of these things, and without a remote, all of these things are not possible, which is why Git has a concept of remote. Now, what exactly is remote? Remote is essentially a server that is hosting your remote repositories. Now, Pay attention to my words. Previously, when we were dealing with local Git, the words that we were using were local repository. We didn't use the word remote repository. So, what is a remote repository? And the definition is in the word itself. So, when you were working locally, you were calling that a local repository. If your repository is stored somewhere on a remote server, you call that a remote repository. So remote is a place where you host your remote repositories. Again, I want you to know one thing very clearly, that we are calling it local repository, remote repository. You will often see that when you are dealing with production workloads, or when you are speaking with your colleagues, you would just use the word repository or repo. The meaning is inferred from the context, because both local and remote, they are often used in conjunction when you are dealing with production systems. Now let's see what are the examples of remote servers. So you have GitHub, you have GitLab, Bitbucket, AWS Code Commit, and so on. There are plenty of options to choose from, but which remote repo provider to choose? Now it depends. So for example, if let's say you are developing a new application and you are on AWS, then it is likely that you will be using AWS's code commit. If you already have your application version controlled onto GitHub and your workloads are running in Azure, then it is likely that you will continue to use GitHub. If you have a multi-cloud environment, let's say you have presence in both Azure and AWS, in that scenario you may choose to host your repositories onto systems like GitLab, GitHub, Bitbucket, and so on, just for vendor neutrality, just to be cloud agnostic when it comes to your repos. But again, the convenience wins over everything. And let me tell you one more thing, the thing that drives the decisions most of the time is who can provide you with a better discount. That always has a role to play when you are deciding on which provider to use. And I'll give you one more perspective here, not to confuse you, but just to let you know that when you are taking these decisions, a lot of things matter. So for example, if my CI, that is continuous integration system, is GitHub Actions, then it's likely that I will use GitHub. If my CI system is GitLab, then it is highly likely I will use GitLab to host my remote repositories. So there is no definitive answer that I can give you that choose this, choose that, because it depends on so many things. In this course, we will be using GitHub. The reason is simple. GitHub is quite popular when it comes to hosting your remote repositories, and the CI system that GitHub has to offer, which is GitHub Actions, is also getting so much popular these days. That is why you will often see in production that GitHub Actions and GitHub are used in conjunction for your application. Additionally, what is remote? Shared point of synchronization. Now, if you see here, both developer 1 and developer 2 have a remote location, which is GitHub in this scenario, and they can share their code with this remote repository. And whenever there are new developers in the team, they can simply pull the code from this remote server. They will not have to reach out to developer 1 or developer 2. Other developers can just be part of this application 1 repo and pull the code from there. And as we have seen in our previous lecture itself, there is push and pull. Push simply implies sending your local commits to the remote. Pull, as the name implies, get others changes or commits locally. Source of truth, central consistent system state. That is what remote provides you. Now I want to tell you one more thing. I mentioned that remote provides you with collaboration. Now collaboration is not the only thing that remote provides. There is centralized visibility. integration with CI systems. For example, if you have a CI system like Jenkins, GitHub Actions, it would actually need a central repository, a remote repository from where it can check out the code. So CI systems also use these remote repositories. Access control and auditing is another. So when you are using a system like GitHub, GitLab to host your remote repositories, they provide you with access control and auditing, and of course backup of project history. So understand that the remote is not just restricted to synchronization or collaboration, it provides you so many other things as well. Now that we have this understanding of remote systems, let's see what I want to discuss next. So if I scroll down, there is type of remote repositories. Remote types differ by access control, not how Git stores or manages history. So whatever commands that we have used thus far, all of those commands and the commands that we are going to study in this lecture or the next lecture, they all work the same way in private and public repositories. But what differs is access control, and we'll see that difference in detail. So types of remote repositories, there is private and there is public. When it comes to access, restricted to authorized users only. So only the users that are authorized can even see that remote repository. Anyone who is not authorized will not even see that repository. Now again, I want you to understand it from a hierarchical level. There is an account. Okay, account could be for an organization, or account could be of a user. That for example, my account is called Cloud with Varjosh. In GitHub, my account is called that, and within that account I can have private repositories and I can have public repositories. And as I said here, access to private repositories is restricted to authorized users only, whereas when I talk about public repositories, anyone can view and clone. Now all the courses that I create, such as CICD, CKA, Argo CD, including this Git Masterclass, have their own public repositories. You are free to clone them, you are free to view them for your learning, but you cannot modify until and unless you have explicit write access. So this is the distinction. Public repositories are visible to anyone and everyone. Private repositories, you pick the people who are authorized to view. But when it comes to writing, when it comes to modifying something in the repository, both of these will require explicit write permissions. Since, as I already gave you an example, my repositories for the courses are all public, but you cannot modify them. Second is visibility, not accessible to public internet. Visibility, openly accessible on the internet. Write access, limited to approved contributors. Write access, limited to authorized contributors. Usage, enterprise internal sensitive system. So for example, if you are developing your application, the application that is for a company that you are developing, it is highly likely that that application will be hosted onto a private repository. All the changes will be governed in the private repository. The project history will be stored in the private repository. So most likely the production systems that you are working on will be leveraging private repositories. Examples, backend services, infrastructure configs, and so on will be hosted onto private repositories. Here the usage is open source, learning, community projects. For example, Kubernetes is the biggest project, and this project is hosted onto a public repository. Examples, Kubernetes, Terraform, public course repos that I and other content creators have provided to you. I hope the types of remote repositories is understood. Now let's go on to see what I want to discuss next. Authenticating with remote. Now see, I want my students to keep their mind open when it comes to authentication, because you are not restricted to just one method. The method that you choose to use depends on what you are going to do, what is your use case, and this could change based on application to application, project to project, organization to organization. So always, if you understand the foundational concepts, you will know which authentication mechanism to use. Now in this particular section we will be discussing GitHub mostly, but understand that other providers, other remote server providers, they also have similar mechanisms, if not same. Now when it comes to authenticating with remote, there are two things. First is authentication via GUI, and this is what we have been using. So if you go to your browser and then you type GitHub and then you authenticate using your account name, that is essentially using GUI workflows to interact with your remote system. And that remote system in our case right now is hosting all of these public repos. And then you have other mechanism of authentication when you are using CLI. So for example, right now we are using CLI to perform a push to a repository. Like we learned, if you have to do git push to a repository and that repository is hosted onto an account, then you must authenticate to that remote system. And here we'll be discussing this one specifically, but I want you to understand that authentication at large can be divided into two: GUI based and CLI based. So if I talk about GUI based, identity based login via SSO credentials. Now even if you are using your Google credentials or your Amazon credentials or your any other third party credentials to log in into GitHub, then essentially you are using SSO. Or if you have created an account within GitHub, in that scenario your credentials are scoped to only GitHub. Then second is session based authentication. So whenever you are using GUI, you are providing credentials of course once, but once those credentials are provided to the provider, under the hood you are using cookies and tokens. So understanding this point is critical. So one login, let's say you do a login, it creates a session, and that session is represented by a token, and that token is sent with every request. So credentials you have provided once, but underneath tokens are used. Now each request travels over a connection. And understand that in practice a single user interaction can involve multiple sessions, and if there are multiple sessions, then underneath multiple tokens can be used. But when we are accessing via GUI, we really don't care. We just provide the credentials once and underneath the tokens are used. Now why I am bringing this up? I am bringing this up because I want you to clearly know that tokens are not just limited to CLI. Even when you are using GUI, you are using tokens in a sense, be it indirectly, but you are still using them. Sessions use tokens internally, cookies, OAuth tokens used for manual operations, UI workflows. I hope this makes sense. And second is authentication via Git CLI. Now this could be programmatic access or machine access. I have further divided this into two sections: SSH and tokens. And if you see, SSH has typically for humans in parentheses, and tokens have typically for systems. I want you to take this with a pinch of salt because this is not something that is written on stone. If you have taken part in my CICD series, you know in that series we used tokens to authenticate with our remote system. So we are humans and we used tokens. And when I talk about SSH, I said typically used by humans, but GitHub has something called deploy keys, and those deploy keys underneath uses SSH, and that can be used by systems, by your CI/CD systems. Hence, what I am saying here is typical usage, but you may see both of these used interchangeably at times. With SSH, you have authentication, asymmetric key based challenge response, no passwords, and that is something we already know. When you generate SSH keys, you get a public key and a private key. Private key always remains in your system, that is secret, you do not share with anyone. And then there is public key. Public key is the one that is there in the remote system. So when we use SSH with GitHub, for example, then what would we do? We will be generating key pair, and then the public key will be uploaded onto GitHub and the private key will remain with us. And in this demo, we will be using SSH as our authentication medium. Second is identity. Private key proves identity. So understand, private key is proving your identity and then mapped to a user account on platform. So that is what I told you in the previous step. What we do is you generate a key pair and then public key is placed onto the remote system. Mapping is public key linked to user account on platform, and that's true because I will be uploading that public key onto cloud with Varjosh's account. Hence, anyone who has the private key can perform the actions in that account. And what actions can the user perform? Understand that when it comes to SSH, only authentication is taken care by the keys. When it comes to authorization, authorization is enforced by the platform. And what will be the authorization? Authorization will be similar to what cloud with Varjosh account has. Then we have authorization enforced by Git hosting platform repository permissions. Usage, developers, interactive CLI workflows, security, no shared secrets, resistant to pushing and credential replay. Now, what I will be doing is I'll be tying this together in a section where we'll discuss what to use, and all of it will make much more sense then. So let's discuss tokens now. Authentication, bearer tokens. Possession is equal to access, and that is what happens. So if you have a token, that token already has certain permissions tied to it. So tokens are essentially scoped to a certain things that you can do. For example, a token, even that token is associated with cloud with Varjosh account, but that token can be scoped to only read permission. So if someone is using that token, that someone can only use that token to perform read related actions. But here with SSH keys, that was not possible. With SSH, what happened was SSH was only used for authentication, and the authorization part was taken care by the platform itself. But with personal access tokens, PATs can be scoped to certain actions on the repository. Identity represents a user or service identity. What is service identity? Service identity is your CI systems, your automation systems. What is a user? Users are humans like we. Then authorization, fine-grained scoped based permissions, repo action level, that is what we discussed. Usage, CICD, automation, API, and non-interactive workflows. Security can be short-lived, rotatable, revocable, and auditable, and we all know that. Now let's go to my GitHub notes. So I'll go to my browser, and here I will zoom in a little. I will go to Git Masterclass, and if you are finding this helpful, I would request you to give this repository a star. Then I will go to part 2, and from here I want to take you to practical decision guide. So I have divided this section into two: human access and then non-human access. So for human access, local CLI usage, if you are an individual developer or DevOps engineer, then it is likely that you can use SSH keys for seamless passwordless authentication. Authentication is based on your private key proving identity. There is no login flow. Actions are mapped directly to your user account on the platform. Then enterprise environment. So even for human access, what enterprise environments will have is they would have configured something called SSO, and with SSO you would see other policies like MFA and so on. So this under the hood using HTTPS plus tokens integrated with IDP. IDP is your identity provider. So when you log in into your GitHub, you will be logging using the credentials that you already have. The credentials, they could live in a system like Microsoft's Active Directory, Okta, Azure AD, and so on. And when you are using that sort of authentication, then under the hood tokens are used. Understand what we are saying. SSH keys are limited to human users. There is something called deploy keys in GitHub where your CI systems can use it, but GitHub themselves recommend not to use them. They say use GitHub apps, and GitHub apps underneath also uses tokens. So keep these things in mind. At large, it is tokens that you should be using, but when it comes to single developer workflows, SSH can also be used. Now let's come to non-human access. So pipelines, scripts, automation systems, all of these are non-human access. They use tokens, and these tokens can be coming from GitHub apps, OIDC, and so on. Authentication is non-interactive, so there is no human login available. Token represents service or workload account. So if I have to summarize whatever we have understood this far, is modern system preferred token based access. Now those tokens could be PATs, personal access tokens, GitHub apps, OIDC, and so on. Now why is this? Why is the usage of tokens so prolific? It is because they support fine grained permissions, better auditability, and integration with identity systems such as Okta, Azure AD, Microsoft's Active Directory, and so on. So let's go back to the diagrams and see what I want to discuss next. And here also, SSH authentication, authorization enforced by platform permissions. Platform as in GitHub. Tokens, authentication plus explicit authorization via scopes and claims. And scopes and claims are part of tokens that you generate or the system generates. Now let's do a demo and connect with our remote system. So what I will do is I will go to my command prompt, and here I am in Git Masterclass part 2 project files. So what I will do is first I want to generate an SSH key pair. So let's start by doing that. I will paste a command here. What I am doing, I am using SSH keygen. I am saying the algorithm that you must use to generate this key is ED25519, and this is the recommended and secure algorithm. You should not be using RSA because this is the modern one. Then -C represents a comment. A comment can be anything, but I have kept the comment as cloudwithvarjosh@gmail.com. Always give meaningful comments to your keys so that you can read those comments and understand why did you generate that key. And then you have -F. Here you are specifying the location of the key along with what should be the key named. Now you can also not have this all together, and it will automatically generate the keys onto the default location, which is .ssh mostly in your home directory. But we want to be explicit with our naming so that when I look at this name of the key, I directly know that this key I generated to interact with GitHub and I used this algorithm. So keep the nomenclature descriptive so that it helps you in future. And I will now press enter, and this is asking, do you want a passphrase? I don't need a passphrase, so I'll press enter. I'll again press enter, and this says, yeah, your key is generated. Here is the fingerprint, and this is the location where your key is generated. So what I can do is ls-la, and then here I can write this so that I can show you the key pairs. And if I do that, you see there are so many keys here. The ones that we have generated right now, they have the timestamp of today. So if I select them, these are the key pairs. So this is the public key which has an extension .pub. This is a private key which does not have an extension. I want you to know that you can also have private keys which use an extension .key as well. So keep that thing in mind. Now, I want you to know one more thing. Private key remains in your machine and must never be shared. Public key, of course, we will have to add that into our remote system. And here the remote system that we are adding this public key is our GitHub. If this were a common Linux as such, then you would have uploaded this public key in your operating system. We have generated our SSH key, but there is one problem. How will SSH know that when this person wants to authenticate with a remote system, I should be using this key, this private key? SSH does not know that, right? So the point is, we will have to use something called SSH agent process. Now, this is a background process. What this will do is, this will bring the keys in the memory, the private key in the memory. And what happens is, whenever we are authenticating with a remote system, it will present that key. And again, I want you to know that private key never leaves your machine. Authentication happens via signing a challenge, not sharing the key. So even though our private key will be in our memory, it is not that while we are authenticating with the remote system, private key will be sent over the network. It does not work like that. I want you to know that clearly. Now let's do one thing. So let's run this command. I'll paste this here. Now what this is doing is starts a background process that manages your keys. I'll press enter, and then what I will do is I will run another command. Now what this command will do is, this command will load your private key into the agent to be used during authentication. So we are saying SSH add, and this is our private key. So this is loading the key into the agent. I'll press enter, and if you want to see whether this is loaded correctly or not, you can write SSH add -l, and this will show you that this key is loaded. Make sure that when you run this command, you see this, because this is imperative for authentication to work flawlessly. Now again, if you go to the GitHub notes for this lecture, I'll go to the top here, and then I will go to step 1. I have given a link. You can follow this link as well. The process remains the same. It is that if you are using a different OS, few steps will be here and there. At large, 99% remains the same, and the steps along with their meaning is given in GitHub notes. I would request you to keep this open while you are practicing along with me. So let's go back to the CLI, and here we have done this. Now what we will do is, we'll be adding this public key onto our GitHub. So what I will do is cat, I'll go to my home directory .ssh, and the name was cwvj, and then there is _ github.pub. So I will cat this file. What will happen is, I'll see the public key here. I will copy this, and now I will go to my GitHub account, and here I will click here, and then I will go to settings, and then what I will do is I'll go to SSH and GPG keys, and here I will click on new SSH key, and let's give it a title. It's cloud with varjosh -github, so that I know what this is for. And then I will paste the key here. Once the key is pasted, I'll check for any spaces, and then I will click on add SSH key. It will ask me for the pass key. I will give my fingerprint here, and this is done. Now our public key is added to GitHub, and never used access is read and write. Then what I will do is I will go to my command prompt, and here what I will do is to check whether the connection is working or not, I will write SSH-t, and here I will write git@github.com, and then I will press enter. Understand, github.com is the remote Git server, that is we already understand. But what is Git? So Git is the system user for Git over SSH. Now we will see this mentioned somewhere else as well, and then it will make much more sense. So for now, just understand Git is the system user used for Git over SSH, and github.com is our remote server, and our authentication is successful because this says hi cloud with varjosh, you have successfully authenticated. But GitHub does not provide shell access, which is understandable. Now let's do one thing. Let's go to our GitHub account and create a repository. So what I will do is let's go here, and then I will click on this plus sign, and then I will click on new repository. The repository name that I want to give this is cloud with varjosh, and I will call this Git practice. Git, yeah, I already see it here because I have been practicing cloud with varjosh Git practice. Then visibility is public, which is fine, and then I will click on create repository. Now this will give me some steps to perform. I choose not to use them because we are going to see everything step by step. I want you to concentrate on two things right now: HTTPS and SSH. So when you are using HTTPS, you would be using tokens, and this is the URL that you would be using to connect to this repository. And then with SSH, this is what you will be using to connect to your repository. And see, git@github.com, and that is something we also saw in the CLI. And then here is my account name, and then here is my repository name. This is my remote repository. Why this is a remote repository? Because this is created onto a remote system. And understand, even if this repository is public, this is the public tag that you see here, only users with write access can push changes. Everyone else can only read, and read implies cloning. Now let's go to our CLI, and here I will run git init, which will initialize this into a Git repository, into a local Git repository. So now what I will run is I will perform 3 dummy commits. Now why I am performing these commits? Because I want to show how the commits look in the local, and how these commits will look when we push these commits onto remote. So I'll paste these commits here. These are just 3 commits. I'm initializing the application, adding that to app.txt, then giving a meaningful commit message. Second, I am adding improving application header. Second, I am adding improve application header. Then I'm giving a meaningful commit message. Third, I am adding one more line in app.txt, and then I am committing this with a commit message. I'll press enter, and this will create 3 commits for me. Git log, if I run one line, I will see that I have 3 commits created. Now what I want to do is I want to add a remote system. So currently my Git does not have any knowledge about the repository that we have created here, and without that knowledge, how will the push be done? So what I will do is I'll come here and I will run git remote. Git remote is a command that will list out all the remotes that you have added, but for now I have not added any remote, which is why it is not showing me anything. So if I run git remote hyphen help, I can see what all parameters I have to give to this command. So I can use add to add a remote. I can use rename to rename a remote, remove to remove a remote, and I will let you read rest of it. For now, I will press quit. And what I want to do is I want to add a remote. Now I will write git remote add, and then I have to give a name to that remote. Now what you will see often is people call it origin, but you can call this anything. You can call this Led Zeppelin, you can call this Arijit Singh, or whatever you want to call it. But origin is something that is industry accepted, and I would rather say it has become an industry standard. So what you would see is people often name their remote origin, but I also want you to know this is not a hard limit. You can use whatever name you want to give, but be logical with your naming. So git remote add origin, and where is the origin that you want to add? What is the URL, or what is the path to your remote? And that is where this comes into play. So I will copy this, I will add this here. The command is git remote. I want to add a remote and I want to call that remote origin, and this is the complete path of that remote. I'll press enter now, and if I now run git remote and press enter, it says origin. And if I run git remote to get a more verbose output, if I run if I run -v here, then it will show me some more details. So git@github.com, and I want you to clearly know that if we were using HTTPS, then we would have used tokens, then SSH would not come into play. And if we were using tokens, we would have copied this path. So I'll go back here. Now what I want to show you is, let's run the command that we want to run. And that command is git push. And we know we already have 3 commits in our local repository. What we want is these 3 commits to go into our remote repository, so that if there is a developer tool, let's say with the name Ramesh, and if Ramesh wants to see what Varun has done, Ramesh can see it in the centralized place. Or Ramesh can pull whatever Varun has done onto his local system, and then Ramesh can do his work, push his changes, and then a third developer named Shwetangi can pull those changes as well, so that Shwetangi, the developer 3, will have the work that both Varun and Ramesh have done. That's so cool, right? So now what we want to do is we want to push whatever we have done onto remote. So I will run git push. Oh no, it failed. Why did it fail? And first it is saying the current branch has no upstream branch. Firstly, I want you to understand this concept. So what is upstream? It is just a mapping between a local branch and a remote branch. So upstream is the thing that maps your local branches to your remote branches. Now that we have understood this, I want you to know why this failed. So at this point, Git knows 2 things. First is you are on the main branch, correct? Second thing it knows is you want to push something, and that something is the 3 commits that we have already performed. But Git does not have any information about the remote. Then how can Git push? But Varun, you just added a remote, but I can add 10 remotes. How would Git know to which remote do I want to push? Right? And secondly, if we tell this that you have to push to that remote, then Git will ask another question: to which branch in that remote do I push to? So there are two things that we have to tell. First thing is which is the remote. Second is which is the remote branch. So let's provide that information and see what happens. Git push, the name of my remote dear Git is origin, and the branch where I want to push is main. But no, the main that you see here is the name of the source branch, of the local branch. Pay very close attention. What I have written here is main. This is name of the local branch. But Varun, then where is the name of the destination branch? Because Git would want to know the name of the destination branch as well. Yes. But what happens is when you write git push origin main, Git automatically adds a main here. So what Git is saying is whatever is there in my local main, push it to this remote in the main branch itself. So the syntax becomes, so let me press enter first and let's remove this main and see. Even if we do that, it will work. I'll press git push origin main. If your authentication is up to the mark, everything would be working. And if you would have used ssh-t to check the connectivity, to check your authentication, and if that worked, then this would also work. Now what we said is remote is the origin, source is the local main, destination is the origin main. So here we are calling this local main because this exists locally. What we will call the remote main, origin main, because we have named our remote origin. So this is the local main, and then where it has pushed to is the origin main. And if I run git branch -vv, then I will see the mapping. So it didn't show me the mapping because I have not done the mapping. We will see this mapping when we set the upstream, and we'll do that later. But for now, understand that when you write git push origin main, you are manually defining the mapping by saying main, and destination is automatically added as main. I hope this thing is clear. Now let's go to the browser and hit refresh here. You see app.txt here, and you see 3 commits. And if I click here, 29E150, 29E150. How good is that, right? And if I come here again, and then I can see there is main branch, and to the main branch it is pushed. But Varun, what if main branch didn't exist here? What would have Git done? It would have created a main branch and then pushed it. So with this command alone, if the main was not there in the destination, Git would have created that, and then changes would have been pushed. I hope all of this is making sense up till now. So let's come back to the question. So before we move forward, I want to show you the syntax too. So if I paste this here, this is the syntax. Git push remote. Here the remote was named origin, local branch, remote branch, local branch, remote branch. And typically you would see remote branch name is not added because Git automatically considers that the remote branch will be named same as the local branch. And we will see the other way around as well in a little while. Hold your thoughts until now, hold your confusions until then. So I'll remove this, and now what I want to do is I want to discuss about upstream. So what we want is when we write git push, everything should work, but git push is not working because it is saying you have not defined the mapping. Here we defined the mapping manually, but if we add a -u after the push, it will store that mapping for us, so that when we want to perform a push next time, we just write git push and it will work. And this command, this message is showing you the same thing, is telling you the same thing. So git push, I can either write -u or I can write set upstream, one and the same thing, origin main. And when I press enter, it says everything is up to date because we just pushed. But now if I write git push, it will not error out like before. It will work because this -u defined the mapping between your local and your remote branch. I hope all of this is making sense. And now let's run the command that didn't work the previous time. -vv, press enter, and now it tells you main has a mapping with origin main. Remember, I told you here this is called just main or local main, you can call it, and whatever is there in the remote is referred by what you named your remote and then the branch there. Now I want to show you one interesting thing. Let's see how this works when you have a feature branch. So what I will do is git checkout -b, and let's create a feature login branch. We have done this, and this time what I will do is I will write git push -u. This creates sets an upstream, I will say, and what I want to do is I want to push this to origin. My remote is origin, and then I want to push feature login branch commits that are part of feature login branch. And if we are taking the commits in the feature login branch, we will also have the feature login branch created in the remote. Understand, my remote system does not have a feature branch yet. So what I will do is I will come back to my CLI and I will press enter, and understand it will automatically add the remote branch name. And it says if I go there and if I hit refresh, one branch, now two branches. You see, feature login. Feature login does not have any new commits yet. It still points to the latest commit in the main branch, and that is from where we created the feature login branch. So you see feature login branch here. Now let's go here, and what I want to do next is I can again run git branch -vv. This will show me that feature login maps to this and main maps to this. I hope this is clear, but I want to do one more interesting thing. I want to call these branches in a different way. Let's create a new branch and push it with a different name. So let's do that. So what I will do is I'll come back to git checkout main. I'll come back to main, and here what I will do is I will write git checkout -b, and I will call this demo test. Okay, I am in demo test. What I will do is git push origin, and what is that I want to push? I want to push this demo test branch, and I want to push this as demo test new name. I'll just write this. Okay, I'll press enter. I have not typed -u. I should have, because I want to show you the output of git branch -vv as well. So let's also add -u here so that we can see that thing too. I'll press enter, and you see when we ran this, it showed us demo test is called demo/test new name in the remote. So if I go here and I refresh this, you see 3 branches, demo test new name, and in our local this is just called demo test. Now if I run git branch -vv, I see demo test is mapping to origin demo test new name, and here feature login to feature login and main to main, and origin is part of all of these. Now let's go back, git checkout main, and now what I want to do is I want to do some cleanup. So if I run git branch, I see there are 2 branches that I want to delete. So let's run git branch -d demo test. I'll press enter, and this says branch is deleted. Now will this branch be also deleted from remote? No. And that is the important concept you should be grabbing. since this is a collaborative environment, it is not just Varun Joshi who could be working with demo test. There could be other engineers who are working with demo test hyphen new name, and Git knows about that. If you perform a deletion here of the local branch, it will not automatically delete the remote branch for you. Now I also want to show you how to delete the remote branch from CLI itself. So what I will now run is git push origin. Okay, and now what do I want to do? I want to delete. And what is the name of the branch that you want to delete? I want to delete feature login from remote. And when I do this, it will delete the feature login from here. So you see, feature login does not exist now. And then what I will also do is git branch hyphen d feature login. I will delete this from here as well. And if I run git branch, I don't see any branch here. And what I can also do is I can come here, 2 branches are there. If I want to delete this demo test new name, I can just simply delete it from here. And if I go here, now I don't see that branch. I only have one branch now. So if I go to the CLI and if I now run git branch, I don't see any branch anymore. But I want to show you one more thing. So I will run here git checkout -b demo new. Okay, I'll press enter. And this time what I will do is git push -u origin, and I want to push demo new. And this time let's push it with the demo new name itself. And I'll press enter. And this will perform the push. And if I go to the remote system, I see that this is created here. Now what I can also do is I can delete it from here. So I will go here. Let me go to the branches, and then I will delete it from here, deleted, and then I will delete it from here as well. So I will first do git checkout main, and then here I will run git log first hyphen one line, and I see origin main, origin demo test new name, origin demo new, and so on. So what I will do is git branch -d demo new. I'll press enter. Okay, I'll again run the same command. Ideally, we don't have any of these branches, but why are these names still here? Remember, we created a mapping using -u. So the remote branches I deleted from this CLI, you don't see them here. And which was the branch that we deleted from here? If I scroll up, origin, I deleted feature login from here. The remote branch feature login was deleted from this CLI. I don't see that here, but other branches that were deleted from there, from the GUI, I see those 2 branches here. And why is that? The reason for this is currently the references, the local references to these branches still exist because we used -u to create that mapping. To remove those local references to remote branches that no longer exist, we should be running git remote prune origin. Now what this will do is this will remove any references that are no longer needed. I'll press this, and then when I see it said it pruned these 2. And then when I run that command again, I only see main and origin main, which is expected. And if I run git status, this says on branch main, your branch is up to date with origin main, nothing to commit, working tree is clean. I hope you have understood whatever we have discussed in this part. Now let's go to the diagrams and see what I want to discuss next. Understanding git fetch and git pull. Now I want you to imagine a scenario where there are 2 developers. These 2 developers are, let's say, working on a feature login branch. Developer 1 performed 3 commits pushed those 3 commits to app1 repo, and she logged off at 5 p.m. At 6 p.m., developer 2 logged in, and developer 2 worked till 2 a.m. at night, and developer 2 also performed, let's say, 10 commits. And now app1 repo, the feature login branch, has 13 commits. When developer 1 joins the next day, she logs in at 8 a.m. Developer 1 sees that she only has 3 commits in her local branch because she does not have any visibility on what developer 2 has done in the feature login branch when she logged off. But understand, from a logical perspective, when developer 1 has logged in the next day, developer 1 would want to know what changes developer 2 has performed, what are the commits that developer 2 has performed. So how can developer 1 bring changes that developer 2 has done while she was not around onto her machine? That is, my friend, where git fetch and git pull comes into the picture. So far, changes moved in one direction, from your local machine to the remote, and that is what we saw in the previous section. We performed 3 commits and then we shared those 3 commits to our remote. In real projects, others also push changes. It's not only Varun Joshi who is pushing changes. There is Ramesh, there is Shwetangi, there is Seema, there is so many other developers who are also pushing changes. So your local repository can become out of sync. What you want is the place from where you start your work should be the latest. Hence, Dev 1, when she joins back the next day, she wants to know what developer 2 has done in the feature login branch so that she can carry forward the work from where developer 2 left, not from the place where she left. Hence, we have git fetch and git pull. As simple as that. Git fetch downloads remote changes without modifying your local code. Now, this is the critical piece here. Now, let's say when developer 1 left for the day, she has something in her working directory which she did not commit. Maybe she was editing a Kubernetes manifest which she left midway because she had to log off, or she was working in an ingress manifest where she had almost written down all the cluster IP services that were supposed to be used, but she had to do a final check before committing that. So she left those changes in the working directory, and alongside she was also working on a code where she introduced a new function, and that part also she left in between because she thought I will continue this tomorrow morning. But when she logs in tomorrow morning, she also wants to see what developer 2 has done without disturbing the work she left when she logged off the previous day. So how can she ensure that she can see the changes that developer 2 has done without disrupting her working directory? She can do that using git fetch, because git fetch downloads remote changes without modifying your local code. Lets you review using git diff, and we will see how git diff works to see what changed. Updates remote tracking branches, example origin main. So we saw what is origin main. Origin main is the remote branch. In her scenario, this would be origin feature login. So when she performs a git fetch, what will happen is her remote tracking branch, that is origin feature login, will be updated with whatever work her dear friend developer 2 has done. As simple as that. Git fetch non-disruptive, git fetch download changes, no local updates, git pull download plus merge into local branch. So git pull can modify your code. Now, Git pull downloads and merges changes into your local branch, and when you are merging changes, you must understand if the changes are conflicting. If developer 2 modified the ingress in a way that she did not, in that case, of course there will be merge conflicts. And dear friends, you will not understand these things if you do not understand what is merge conflict. So do watch part 1 in case you need a refresher. But git pull may result in a merge conflict as well. So git fetch is just fetching your changes. Git pull is performing a fetch plus a merge. Simple. Typical workflow: use git fetch to review incoming changes, use git pull to sync when ready. Prefer git fetch for controlled updates, use git pull on trusted branches. So it all comes down to what is that you want. So now that we have this theoretical understanding, let's go to the demo. So I will go to my browser, and here I already have app.txt. Now, if there were a developer 2, developer 2 could have pushed, but here unfortunately only yours truly, Varun Joshi, is here. So Varun Joshi has already performed push, but to simulate another developer, what we can do is we can modify this file directly via the GUI. Now we are simulating developer 2. If there were an actual developer 2, developer 2 would have pushed whatever developer 2 has done. So here we are simulating that. So I'll go to app.txt, I will go to edit, and I will add a line here, and that line will be add search functionality. I'll add this, I'll copy this from my notepad, and then I will paste this here. So a fourth line was added and app.txt was modified by a different developer. I'll commit these changes and Copilot will think and give me a good commit message. Add search functionality to application. Again, see, this is imperative in nature. It is giving instructions here. So I will also write a chore here for completeness, because I want my commit messages to adhere to a certain format. And then I will directly commit this to the main branch. And I want you to clearly know that up until now we are directly dealing with the main branch. We are committing to the main branch, we are pushing to the main branch, but things are soon going to change when we move to the next section, which is PR, pull requests and code review. So let's hit commit changes for now. And I have a new file. If I go to my Cloud with Varjosh Git repo, I see 4 commits. Previously, I only had 3 commits. Now, if I go back here to my iterm, I will clear my screen. I will again run git log 1 line. And this will show me I only have 3 commits, which is understandable. So the situation right now is remote repository has a new commit. Local repository does not have this commit. Now our local repository is out of sync. And what did we learn in our diagrams? If I move little ahead, shared point of synchronization accessible by all developers. So right now our local is not in sync with our remote. So we have to do that sync, and what we know, we have git fetch and git pull for that. So let's get to work. So I will first run git status. This will not tell me that your main is ahead until I run git fetch. So I will run git fetch now. Now, whatever changes are there in the remote, I have those changes in my origin main, in my tracking, but I do not have them right now in my cat app.txt. The 4th line is still not here. But if I now run git status, what do I see? On branch main, your branch is behind origin main by 1 commit and can be fast forwarded. And we know what fast forward is. It just moves the branch pointer. It's not like a 3-way merge where a merge commit is created. use git pull to update your local branch. Nothing to commit, working tree clean. But I don't want to run git pull directly. I don't know whether the remote changes. I want those changes on my system right now, on my local right now, before I review what actually changed. So what I will do is I will run git log one line, same thing here. Now I will run main dot origin main. What I am saying, I want you to compare main with origin main. Press enter, and this says chore add search functionality to application. So this is the commit that is there in your remote. C1 latest commit on origin head. Let's go to the browser. C1 is the fourth commit. So this command showed you the latest commit on the remote. But Varun, I still don't know what has changed inside the file. I have just seen the commit message of the fourth commit that is there in the remote and not there in my local. But how do I check what has changed in the file itself? And my dear friends, we have git diff that will show you that. But before we do that, we know cat app.txt only had 3 lines. Now what we will do is, now we will run git diff. Show me the difference between main that is available locally and origin main that is my remote branch. And is there a specific file you want to see? Yes, I want to see what changed in app.txt. Now this is useful when you have multiple files. Right now we only have app.txt, so supplying this message does not make much sense here. But if you had multiple files and you had to see what changed in this file, what changed in that file, then this would have helped. So with this, let's press enter, and you see it is telling you add search functionality was added to app.txt. So good to use git diff, and git diff is something you would be using all the time. So master this command. So for now we have seen that git diff is used to compare local with your remote, but the functionality is not limited to that. We will see how we can use git diff locally as well to compare, working with staging with last commit, and so on. Now let's run this without app.txt. This will also give us the same input because we only have app.txt. Now that we have understood that these changes are fine and I want these changes to be there in my local system as well. So what I can do is I can now run git pull. And what is git pull? We all shout git pull is git fetch plus merge. That's all git pull is. I'll press enter, and one file changed, one insertion. Okay. And if I now cat that file, cat app.txt, we have the fourth line here, dear friends. And if I run git log one line again, fourth commit is there in our system now. We see that our local main is also pointing to the latest commit on that branch. So head is the currently checked out branch, and which is the currently checked out branch? Main. And we know the branch points to the latest commit on that branch, and that commit is this one. I hope you have understood everything. And before I let you go, I want to tell you one more thing. When you run git fetch, so there could be multiple branches that are being tracked, multiple remote branches like feature login, bug fix, hotfix, and so on. When you run git fetch, it will fetch all the remote tracking branches, all the changes that you have done in your remote tracking branches. If you want to be explicit, so for example, right now we just ran git fetch. Okay, if you want changes for a specific branch, then you can always name that branch. So for example, you could have said git fetch origin main. In that scenario, it would have only brought the changes that were made in the main. But since in our example there is only main, it does not really matter. But I want you to know this nuance as well. Git fetch by default will bring all whatever has changed in all the branches that are being tracked. But when it comes to git pull, it only works on the currently checked out branch. So if I run git pull from here, then it will only work for the main branch, and that is understandable because git pull is kind of destructive in nature, right? Because it will change your local with respect to remote. So here you want to review things. So here git was a little conservative. It said when we run git pull, the default behavior will only impact the currently checked out branch, but git fetch is not making any changes locally. It is just bringing in the changes and updating your remote tracking. In that case, it said, okay, let's update all the branches that are being tracked for the remote. I hope that makes sense. Okay, now, okay, I want to discuss git diff now in detail. So I'll go to my browser and then I will go to the GitHub notes, and from here I want to go to git diff. Understanding git diff. So in our previous demo, we used git diff to compare local state with remote and inspect what changes would be pulled. Now let's formalize and extend that understanding. Git diff shows the line by line difference between two states in Git. These states could be your working directory versus the staging area. How does the file in working directory look, and how it is different than the file that you have already staged? Understand, let's say you are working on a file and you staged that, but after staging you realized, oh no, I should have staged it after making some more changes, and you did some more changes, but now those changes you have done are not in line with your current thought process. So what you do is, let me compare the working directory, the file that is there in the working directory, with the file that is there in the staging area. In that case, you can use git diff. What if you want to compare the file that is in staging area with your last commit? You can use git diff for that. One branch versus another, local branch versus remote branch, this we have already seen. So git diff is extremely powerful. So if I have to summarize git diff in simple terms, it answers one question: what exactly has changed? Now, be it you are using it locally in your working, staging and commit area, or you are dealing with a local versus a remote situation, it will just tell you what has changed. And this is something that you will be using all the time. So now let's go back to the CLI, and here I will clear my screen, git branch, and we only have main branch, and that branch, if I run git status, will show your branch is up to date with origin main. And if I run git fetch, this will not fetch anything, and even after this, if I run git status, it will show my branch is up to date, and that is what we want to see. On branch main, your branch is up to date with origin main. Now here I want to create an isolated branch, so I am already in main. I will run git checkout, and this time let's call this checkout -b, and this time let's call it demo diff, because we are understanding diff. Now we are in the demo diff branch. Here what I want to do is, I want to add a commit here first. So I will just copy this, because in this one, in the first one, we are going to compare the working directory with the last commit. So our commit is initialize application config. We are creating a new file, config.txt, git add config. We are moving this to the staging area, and then we are adding a commit message, chore add initial config. I'll press enter, and this says the commit is done. Now if I run git diff right now, it won't show you anything, and I'll tell you why it is not showing anything. Allow me some time. And now what I will do is, I will modify the file that is there in my working area. So I will copy this, and then I will add it here. So what I am adding now is, I'm adding add environment specific settings in config.txt. Previously it had initialize application config, and I will press enter now. Now what has happened is working directory, the file that is there in working directory is not in line with what we have committed. So let's now run git diff. What is git diff showing to me? Git diff is saying that when I compare your working directory with the last commit, I see this has changed. You have added this line in the working directory, which is true. If I add cat config.txt, you see add environment specific settings we have added. Previously, git diff did not return anything. Why is that? Because if you look here, what is git diff? Git diff compares working directory versus the staging area. If nothing is staged, it effectively shows changes against the last commit, which is why it may appear similar to git diff head. So git diff, what it did was, since there was nothing in the staging area, it compared what we had with the last commit and there were no changes. Hence git diff did not return anything here. But when we compared the working area with the last commit, it told us that there is a difference. Now let's do one thing. Let's also now stage this file. So I'll do git add config.txt. Now I have staging. In staging area, I have a file that has both of these. And in the committed area, in the last commit, we have a file that only has one line, initialize application config. Now what we want to do is we want to compare the staging area with the last commit. And how can we do that? We can do that by using git diff. First, I'll just run git diff. It will not give me any output. Why is that? Because working directory and staging area are identical. Working directory has 2 lines, right? And staging area also has 2 lines, right? Git add config, it had 2 lines only. So our working and staging area are identical. Hence git diff did not return anything. But if I run git diff -- staged, then it told me that you see there is a change. You have this added. I hope this is making sense to you. Now we have understood all of these commands, and local versus remote we have already seen. This we have already seen. Working versus last commit, if I run git diff and then I add a head here, this will also show me that this has changed. Because what do I have in my working area and last commit only had one line, initialize application, but the working area now has a second line, which is why this is showing me this. I hope this is understood, and it is quite simple if you get a hang of it, and if you clearly understand what is working area, what is staging area, what is last commit, all of this will make sense. And now what I will do is I will just run git checkout main, and then I did not want to see this error, but anyway, this error we will see later in this lecture, so do not worry about it. So for now, what I will do is I'll just commit everything that is there, git commit -m, and then the message will be chore adding commits. Okay, now I will switch to main. It will allow me to go back to main now. It has allowed now. Previously it did not allow. And why it did not allow? Hold your horses. So now what I will run is git branch -d, and then what is the branch that I want to delete? I want to delete demo diff, and this will also not allow me to delete this with just a -d flag, because I have not merged that branch anywhere. So if I press enter, it is saying error, the branch demo diff is not fully merged. That is why it is not. So the point is, what git thinks is they have performed certain commits in a branch demo diff and they have not merged it anywhere. So maybe they need it and they are deleting it by mistake. So that's a very good functionality. So if you do not have any commits in that branch, it will let you delete those branches. And we have seen that. So we created so many branches while we were performing push, right? We created feature login, we created demo test, and we were able to delete those branches. But here we have a branch which has commits which have not been merged. If we would have merged this with main, then this would not give us this. But we know that we want to delete this branch, so what we can do is we can use a uppercase D, which will forcefully delete this. I'll press enter, and now we see that branch is deleted. I'll clear my screen. Git branch, I don't see any other branch than main. So let's see what I want to discuss next. I'll go to my diagrams. I'll scroll down, and the interesting topic, that is pull requests. Now, if I have to define pull requests in a simple way, I would just say pull requests are a way to review your changes before a merge. Now, whatever we have been doing thus far, we have been dealing with multiple branches. We are performing merges. If there are conflicts, we are resolving those conflicts and then merging. But there is no review, so to speak, which will tell if this is merged, then something will break. So that is what a PR is. PR is a way via which you can review the changes before a merge happens. So let's see what are the problems with direct push. First is primary branch represents stable, releasable system state, and primary branch could be named main, it could be named trunk, primary, release, and that nomenclature depends on you. But that main branch has the code that is tested and works like a charm in production. That branch always have releasable code, and that is your primary branch. So what happens is you do not want anyone to directly push to that branch. So for example, let's say main in our example would have been a primary branch. In that scenario, we would prohibit anyone to push directly onto main, because maybe their changes from their perspective are good, but when those changes are introduced in our main branch, maybe our code does not work as expected. Maybe it changes something that breaks a specific feature. So we don't know those things. Hence, you will always see in production that releasable branches, direct pushes are not allowed. So if you try to push to a primary branch, you will not be able to push. And the word that we use to define this is protected branches. We say a branch is protected if direct pushes are not allowed to that branch. And you would see often that releasable branches, they are protected, hence direct pushes are not allowed. And here we are conveying the same thing. Direct pushes introduce unreviewed changes into stability. Issues surface late, risking builds, deployments, and workloads. Hence, we must have means via which, before merging the changes onto a branch, the changes are reviewed. Now, first thing is direct pushes are not allowed in protected branches. That's one side of things. But you must be pushing onto a different branch, correct? And then that different branch must be merged with a protected branch, correct? And that process is called raising a pull request. So this is, understand this as a security mechanism, okay, as a mechanism via which your code stays clean, your branch, that is the primary branch, stays releasable. So first what you do is you prohibit anyone to push onto your primary branch. That's step number one, so that no one can push. Second, what you do is when there is a feature branch, let's say here you can see a feature login branch, and when someone wants to merge this feature login branch with main, they cannot perform that merge directly. Up until now, we have been performing that merge directly, but what PR and code review process says, you cannot merge things that have not been tested. And for that merge to happen, you first must perform what is called a review. And that is what a pull request is. In simple terms, PR is a way to review changes before merge. So PR pull request is popularized by GitHub. Everyone uses this term now. Merge request is the term that is used by GitLab. If you ask me, I like the term merge request better, but who cares? GitHub is more popular, so you would often see people say pull requests. So, what are pull requests or merge requests? Changes are proposed, not directly pushed to main. Work happens in isolated branches. So, your feature branches, your bug fix branches, your hot fix branches. And once the work is done, you raise a PR. And once that PR is approved, then the merge happens. Now, we will see how the review is done and all of those things later, but at large, understand that before merging things onto your main branch, onto your primary branch, there must be a code review which ensures that whatever is being merged to the primary, whatever is being merged with the branch that holds your production ready code, is tested. So next is pull request targets primary branch for integration. So now let's discuss this validation before merge. So changes reviewed before entering stable branch. That is what I told you. Whenever changes are to be moved from feature to main, they are reviewed. Diff shows exact changes between branches, and we will see that in the UI as well. Automation validates correctness. Now, what is automation? Now, what happens is when a PR is raised, what will happen is your code is tested. Now, how the code is tested, there are automation systems. These are often called CI systems, like Jenkins, GitHub Actions, or GitLab CI. What they will do is, as soon as a PR is raised, they will perform build validation, they will perform certain tests, they will perform linting, policy checks, infrastructure validations, and so on. Now, how many tests are performed, what is the intensity of those tests, how many tests, and so on, depends on your application, depends on your use case. For example, if you are dealing with a banking application, they would have to adhere to certain compliance standards. Maybe your tests for that specific application also involves compliance level security checks, but you are also dealing with a manufacturing application that may not have those many tests involved. So keep your imagination open. The number of tests that are performed, the level of scrutiny that an application has to go through before that PR is approved, can differ based on application to application. So there is automation that validates correctness. Second is approvals. There are both manual and automated approvals. What are automated approvals? Now let's say I told you that a testing is performed. Now if that testing is successful, then the automation approves that change. And then there is a manual approval as well. Manual approval, as in your team lead or manager will see that, okay, the CI ran successfully, so the code is fine, but is the code design wise appropriate? Do we need a new release of this application right now? Whatever functional changes that this code brings, are they acceptable right now? So that is manual layer of approval. Maybe your manager or team lead will perform that manual approval. Understand that in production systems, you will typically see that there are both automation and manual approvals. Automation is your CI processes, building your application, compiling it, linting it, running tests, creating artifact, and so on. Then there is also a manual approval. Again, there could be certain corner cases where everything is automated, there is no human involved in approving, but it's highly likely that you will find both automation and manual approvals in place when you are dealing with production systems. The last point is only approved changes are merged into main, and that is understandable. If everything is approved, only then your branch will be merged with the main. I also understand that this can be confusing for some folks, which is why what we will do is we'll first see a flow diagram and only then we will move on to our demo. So I want to show you this pull request workflow in production so that you understand how the process works end to end. Wherever you see these orange icons of Git, that implies that stage only involves your local system. If you see both of these icons, that implies that step involves both local and your remote server. In our example, the remote server is GitHub, which is why you see a GitHub symbol here, the icon here. And then step 5, you see that you also have Jenkins icon here. So Jenkins I am using as a CI server. Hence you see in this step your remote server and your CI server is involved. In step 6 you also see both of these involved, and finally in step 7 you see your remote server and your local Git involved. Now that we understand the architecture of this diagram, let's understand what is being done in each of these steps. Step 1 is create a working branch. Now working branch, what happens is often all the teaching folks they call feature branches, but it is not always a feature branch that you are creating. It is not that always you are releasing features. You could also be fixing things using hot fixes. You can also be creating a bug fix branch. You could also be creating a spike branch and so on. Hence, I am using the term create working branch. Branch from stable main. So this is the branch that you create from your primary branch. In our example, that primary branch is main here. Second is isolate work from system. So why do you create a branch? Because a branch is an independent line of development. So you create a branch and that working branch could be feature, bug fix, hotfix, spike, etc. In the second step, what you do is you implement your changes locally. So your feature branch, for example, can have multiple commits because you are working on a feature, let's say, that brings the login page. So maybe you had 10 commits, 20 commits. So you will keep on working on that feature branch. Not only you, maybe only you have ownership to the feature branch, or there is a group of developers or DevOps engineers that are working on that branch. So understanding this point is critical, that feature branches are not only limited to you, and we have already seen that in the collaboration workflows as well. Develop and commit changes here, that this is what you do, and then work remains private and isolated. So up until now your work is there only in your local system. Now I said multiple developers will come into picture when you have something centralized. So in the next step here, once this step is performed, then you can have multiple developers working on the same branch. But understand that there would be a developer first who first creates that feature branch, who initiates that work, and once that work is initiated, he or she will push that onto a remote branch, so that whatever she is doing, whatever that developer one is doing, can be seen by other developers and they can also contribute. So step 3 is push branch to remote. Now why do we have two icons? Because pushing is performed by your local Git, and where the push is performed to the remote. So that is why you see push branch to remote has both of these icons. Publish branch to remote repositories enable collaboration and PR creation. So enables collaboration. So once the work is there at a central place, everyone else can collaborate, or the allowed people can collaborate. And PR creation. So step 4 is create pull request. Propose changes into protected branch using pull request. Initiates validation and approval workflow. Now this is extremely important. Now a lot of folks have confusion that, Varun, whenever we push something to the feature branch, wouldn't the CI run? Now if I talk about earlier workflows, I mean 2020, 21, I saw a lot of projects where the CI build was performed. And when I say CI build is building the application, running tests and so on. Okay, because how do you review the code if you are not testing your code? So consider whenever I'm saying continuous integration, if you do not come from a DevOps background, this word might seem alien to you, but I'll try to make this, DevOps agnostic, so to speak, so that even if you are coming from straight a development background or from an IT background, you can still make sense of this. So CI systems are essentially systems that are building your code, reviewing your code, and so on. So previously what used to happen was whenever a push was performed in the feature branch, then also a review used to happen, CI used to trigger, and whenever a pull request was created, then also the CI used to trigger. Now the problem with this approach is the commits are the same, then why are we running CI in this step as well? There is no point, right? Because the commit is same. Secondly, CI has costs. So if your CI is running so much, even when you are pushing onto feature branches or any of the other working branches, then it does not make sense. So what happens is the CI only runs when pull requests are created, which happens in step 4. So what I'm saying in simple terms is you could also see certain systems where CI is triggered in both step 3 and 4. But typically in production scenarios where resources are used intelligently, efficiently, then you would see that the CI systems only run upon PR being raised. And this understanding this distinction is important. First, the code is pushed to the feature branch and then nothing happens. Okay, multiple collaborators could be collaborating, but once those collaborators are happy with their work, that we can release a PR, we can raise a PR so that our work can be merged, then the PR is raised. But again, I also want you to know that there could be certain scenarios where a certain developer pushes, maybe he's a senior developer in your team, when he pushes to the feature branch, then the CI runs so that the PR is only raised for code that has been tested at some level. That is also there. So keep your mind open, okay, because these things are subjective and I'm throwing these concepts at you so that you widen your imagination, not to confuse you. Then you have create pull requests, propose changes into protected main, initiates validation and approval workflow. So then we have review and validations. Checks runs on every push to branch with open PRs. Now let's say you opened a PR, but your check failed. And as soon as the check fails, you are sent back to step 2 because the check has failed. Now you as a developer will have to fix what was wrong, correct? So you fix that and again this is repeated. Your check has failed, you again push it, but you do not create a pull request because the pull request is already created for you previously. That pull request is not automatically closed. So you push again, and then that's what this point is saying. Checks run on every push to branches with open PR. All required checks must pass, required approvals must be satisfied. Only then, once, let's say if you also have manual approvals, there will also be a human icon here. Once that human also approves, only then you move to the next step, and next step is merge into main. So approved PR is merged into protected branch, triggers downstream pipelines. Now understand, when a merge has happened in the main branch, you have a new code there, correct? Now that code must be deployed onto some environment, and that some environment could be your staging environment or it could be your production environment. And staging environment is nothing but a pre-prod. So before running your code onto production, you want to run the code onto the staging environment and then perform various checks, and then only if those checks succeed, only then you promote your code to your production environment. So that is what this step is doing. Approved PR is merged into main and triggers downstream pipelines. So what happens is, in step 6, what you are also doing is you are building the application, compiling, packaging, running tests again on the merged code, creating deployable artifact. This could be your binaries, your container images, then deploying the application onto environments. Now those environments could be staging and production. So in summary, this is what step 6 is doing. And in step 7, we all want a clean environment. So we perform deletion of the local branches. And let me tell you, it is a very good feeling when your code gets merged into main and you are deleting your feature branches, because I have seen feature branches run for 6 months, 8 months, year to develop that feature. And once that feature is merged into main, it gives immense happiness. So I hope the flow is understandable. Now that you understand this flow, let's work on the demo part. So what I will do is I will first go to GitHub and I want to do it production grade. So let's do one thing. Let's make our main branch protected. So let's do that. I'll go to settings and then I will go to rules, and in rules I will go to rule sets, and here I will click on new rule set, new branch rule set, and this rule set I will call this protect main, and then enforcement is protect main. Sorry, I think I cancelled that. Protect main, and here I will activate this enforcement is active, and bypass list I don't care about this right now. Target branch, here I will click on add. So you can add the default branch, and if you look at this, if I duplicate this one and if I go here, leave, and if I go here, my main branch is the default branch as well. So I can also click here, include default branch, include all branches, but I will click on include by pattern, and here I can write main. So you can use anything that you want that satisfies the purpose of main being protected. So here are the branch rules we can have. Restrict deletion, this is fine, I want this. And then block force pushes. Now force pushes is if I add hyphen force, then also do not allow anyone to force push. So pushes on this protected branch will not be entertained. And then what I want to do is require a pull request before merging. So this is what I want to choose. Now here I will change the required approvals to 1. Understand, you cannot be the one who raises the PR and also approves it. So if you do not have a secondary GitHub account, I have my personal account, which is why I'm saying required approvals is 1. But if you don't have a secondary account, then you can keep this to 0. But I want to show you how things are done in production, because there is a manual reviewer as well. That is why I have chosen this. It is your choice what is that you want to choose, and I would encourage you to read all of these and see. Allowed merge methods, now you can choose merge, squash, rebase. Merge we have already studied, squash and rebase we will be studying in the part 3 of this series. So for now, let's keep this to default, and I will click on create here. Rule set created. Now I'll go to my CLI, and here I will create a branch git checkout -b, and I want to call this branch feature search. Okay, I'll press enter, and then what I will do is I will add just one commit to this, and this is my commit: enhance search functionality with filters, and I'm adding that in app.text. Git add app git commit, and this is my commit message. I'll press enter, and if I cat app.text now, 4 lines were already there. Now we have added a 5th line, that is enhance search functionality with filters. Now I will write git push -u origin. And what is that? The branch that we are pushing? We are pushing the feature search branch. And here we are adding -u so that we set the upstream as well. So we have performed a commit and we have pushed that. So what we have done is we have pushed the feature search branch to origin feature search. Understand, all of these demos are connected, whatever we are doing from start to finish, because I wanted to show you the production flow from start to finish, which is why I'm not creating new files and new commits so that you know how the flow works end to end. So if I go back to my browser, okay, I'll go click here. What do I see here? Feature search had recent pushes 33 seconds ago. Compare and pull request. So compare and pull request is you can compare the difference between what I have and what I have, as in what is there in the main branch, with the feature search branch, and we will specify that as we click here. So for now, let's click on compare and pull request, or you can also go to pull request and create a new pull request. So let's click here, compare and pull request, and you see base is main. So what it is doing is it will compare feature search with main. Main had 4 lines, feature search has 5 lines. So we will see how that works. Add a title, I will use the default one, and then I will come here. If I scroll down, this is showing the comparison to me. So it is saying that your main only has 4 lines. The new commit that is coming, the new change that is coming, has the 5th line, enhance search functionality with filter. So what it is doing is it is comparing main and feature search. This is base because this is where we are trying to merge. This is where we are raising the pull request. So this shows you the comparison. We saw compare and pull. So this is the compare part. Now we will create the pull request. So I would encourage you to have proper descriptions here so that your leads and managers can understand. You can also have markdown here. I'll click on create pull request. So now if we had a CI system, upon PR creation, that CI system would trigger and do certain checks. Git Guardian is available to us by default. So I am using that. It's available with my GitHub account, and you might also see this. It says merging is blocked. Otherwise, if I would have selected 0, I would see here merge this. But I don't see that merge here anymore. Why don't I see it? Because I have said there is a one reviewer. There is one reviewer. At least one approving review is required by reviewers with write access. Now, how do I add a reviewer? So what I can do is I'll go to settings, and then I will go to collaborators, settings, collaborators, and this is a repo level setting. And then here I will click on add people, and my personal account is Varun Joshi 0404. So I will see that this is my account. I'll click here, add Varun Joshi 0404 as collaborator. So now Varun Joshi belonging to the account Varun Joshi 0404 is now a collaborator, and this says pending invite. And now I will go to my browser. This is the browser I use daily, Edge browser. So I will make this full screen, and then I will open GitHub here, and then the name of that repository is cloud with Varjosh Git practice. I'll search for it. I would have also received an email on my email address that is associated with the account, this, that there is someone who wants to collaborate, who wants to add you as collaborator. Do you accept that? So if I go here, cloud with Varjosh, this here is seek @cloud with Varjosh has invited you to collaborate on this repository. Do you want to accept that? I will click on view invitation, and then I will say yes, I accept this invitation. And now I am successfully added as a collaborator. So if I go to pull requests here, if I click here, and then if I see the same thing here, but if I go to files changed, and if I go here in this drop down, let me zoom in as well. Sorry, I forgot to do that. I see approve here, request changes, and comment. So I, as a reviewer, can also reject this, okay, by adding a comment or by asking them to do something else which they have not shown me, which my developers have not shown me. I have that option. But if I go to my cloud with Varjosh account, if I go to this where I had pull request, so if I go here, go to pull request, and if I click here, I go to the same place, files changed. Here I don't see approve. It is blocked. Pull request authors can't approve their own pull request. That is why I told you, if you have a different account, if you have a secondary account, then only use this. So I'll go here. I will click on approve and then I will click on submit review. So I'm in my personal account, Varun Joshi 0404. So I'll click on submit review, and this now in my personal account itself, I have the option to merge pull request, but I want to click on merge pull request via my cloud with Varjosh account. So let me refresh this, and then let me go to pull requests. And if I go here, then now all are green. Now I have the authority to merge this pull request. So if I click on merge pull request, it is asking me for a commit message, and I want you to contrast this right away with fast forward merge. Here, understand, there has been no branch divergence. Okay, and if you're not understanding these terms, you have not watched part 1 properly. So there is no branch divergence when we perform a git merge. When there is no branch divergence, there is no new commit created. Okay, there is no merge commit created. But when you raise a PR, even when there is no branch divergence, there is a merge commit created, and which makes sense, so that we know that there was a pull request that resulted in that merge commit. And this commit message will be authored by this. And I'll show you one very interesting thing in a little while. I'll click on confirm merge, and once we are done here, it is giving us an option to delete this branch right away. Because like I told you, if the merge is successful, then why do you want to keep the branch? You delete it. I'll click on delete branch here. The remote is deleted, not the local. And here, if I go to my this, now my this is app.text in the main branch. If I click here, I should see the 5th line, enhance search functionality. And if I look at the commits, I have a 6th commit now. And if you see here, this shows me what is the 6th commit. This commit resulted in from a pull request, and this is this. I hope everything makes sense to you. Now what we want to do is, I want to show you one more thing. I'll go to my iterm, and then I will run git checkout main, and right now in local app.text shows only 4 lines. The 5th line is not shown. So let me run git pull directly this time, because we know we want those changes. Git pull, and this is so interesting. You have walked the entire circle now, the entire flow. Now if I cat app.text, you see the 5th line is here, enhance search functionality with filters. Now I want to show you one more thing. Git log, 1 line. No, not 1 line. I have to show you the entire log. All these commits, they had my email address, right? But any commits that we fetched from remote, they do not have the email address, and that is done for your security, because GitHub doesn't want to show you the email addresses. This is for security and privacy, that it is not showing the email addresses, because your collaborators not necessarily are from the same company. They could be your someone that you have hired for remote work. They could be some other organization. So that is why this is there for security reasons. We made changes in the remote. We are seeing those changes in our local. We have walked through the pull request process, and we have also merged it. We have also had one manual reviewer. So I hope everything is connected. Now that we understand these things, I want to discuss something else. Remember what we did? We made our main protected, and I told you that when something is protected, you cannot directly push onto it, correct? I mean, it depends on what is your rule set, but one of our rules in our rule set was to disallow push. Let's see how that works. So what I will do is, I am already in my main branch and I will add a commit. And I'm using something that I already have. Echo hotfix applied directly on main app.text. I'm moving that to staging area and then I'm committing. So this will work. If I run git log one line, I'll see that there is a commit here. But let's see if we can push it. So I will write git push origin main. I could have just written git push, it would have worked. Let's see if this works. Remote rejected. Let's add a force. It doesn't work, right? So this is so fun. So now let's do some cleanup. So what I will do is, I'll clear my screen. I will directly rm-rf, use this with caution .git so that everything goes. ls rm-rf, I'll also remove app.text. But when I talk about my repository has everything. I only have main here because we deleted that branch because of our cleaning process. And if I want to delete this repository, I can go to settings. In this repository, I'll scroll at the very bottom and then delete this repository. It will ask me to type that name again. I will copy this and then I will paste this here, delete repository, and voila, the repository is now deleted. Now let's go back and see what is that I want to discuss next. There is only one topic that remains, and that topic is git stash. So let's now understand what exactly is git stash. Now before discussing git stash, I want to tell you a property of git. Git cares about your work. It will not allow you to switch branches if switching a branch can result in your unfinished work getting discarded. So Git's aim is, you only discard things that you are allowed to discard by your administrator. Git by default will not be discarding any of your work. But Varun, why would it want to discard my work? If I have to switch a branch, I will just switch my branch. Why will Git have to modify my work? But it will. So for example, if you look at this diagram here, we have a commit B where we have added my name is Varun. And then in commit C, we added my name is Varun, I live in India. And then from commit B, there was a feature branch created. And in feature branch, you are editing a file, intro.txt, the same file that is being worked here. My name is Varun Joshi. Now, firstly, I want you to know that a working directory represents the checked out branch commit. Okay, for example, if I am in feature login, here there is no commit. But if I talk about main branch, there is a commit C. So if I am working in the feature branch and if I'm editing this file and I want to switch back to my main branch, git checkout main, then Git will have to discard my changes to switch to that branch. Why? Because if I move to this branch, then the working directory must be updated to match the checked out branch commit, and that is my name is Varun, I live in India. Now if Git allows me to switch here, then whatever I have written here, my name is Varun Joshi, this will be gone. Because if I move to this branch, then cat intro.txt should ideally be showing my name is Varun, I live in India. But if I have modified, if I have this in the working directory, these will be gone. Hence, Git will prohibit you to perform that checkout if that checkout will result in Git modifying whatever changes are there in your working directory. So when you are working with feature intro update, your working directory had my name is Varun Joshi. But if Git would have allowed you to switch, these changes would have gone, and Git does not want that. That is the reason you have Git stash. Again, if you understand these concepts separately, it would make much more sense. First concept is Git won't allow you to switch branches if Git has to modify your file, or if Git has to get rid of your changes, discard whatever is there in your working directory, then Git will not allow you to switch. Git stash is a method that you can use to park your changes somewhere and switch the branch. Make sense? Let's read it for all the dots to get connected. Why Git stash? Need to switch context with unfinished changes. That is what we discussed here. Git blocks actions that would overwrite your uncommitted changes. So whatever is there in your working directory that is uncommitted, if Git allows you to switch, it will have to override that. So Git blocks it. Committing incomplete work is not always appropriate. Now, some of you might be thinking, if I have uncommitted work, I can quickly commit it onto the feature branch and then switch. Then the switch will be allowed, Varun, right? Yes, you are right. But understand what we discussed initially. All the commits must be focused. You should be doing something. You should not be performing commits for the sake of performing commits. So in that case, what is that you do with your unfinished changes? That is where Git stash comes into picture. So what is Git stash? Temporarily saves your uncommitted changes outside branch history. Now what happens is, when you had changes, you run git stash to park these changes somewhere, and feature intro update already points to commit B, and then it will allow you to switch. Restores, this is the key point here, restores your workspace to the last committed state, that is head, and the last committed state is this. Lets you safely switch context and reapply changes. Now here is a quick decision guide. Commit when changes are complete and meaningful. So what to do if you have uncommitted changes and you want to switch? You commit when changes are complete and meaningful. You stash them, Git stash, when changes are incomplete but need to be saved. Discard, obviously you can discard your changes if whatever you are doing is not that important. Now some of you might be thinking, but Varun, why would I have to switch a branch while I'm working on something? Imagine your junior comes running to you and says there is something wrong with production. Can you see what happened? In that scenario, you will have to switch to main and see what code is there that is running in production. Or maybe you want to quickly check something in the main branch. Maybe your junior comes and asks you a doubt about the main branch. Then you will have to switch. So there could be plethora of reasons for you to switch to a different branch when you have unfinished changes in the current branch that you are working. And Git stash is a way via which you can park your unfinished changes somewhere, so that once you are ready, once you come back to the branch, you can bring those changes back to your working directory and continue your work. And the major thing that I told you is Git will not allow you to switch branches if Git feels that switching the branch would result in whatever changes he has uncommitted. I hope this makes sense. So I also want to discuss what you see on the left, that is case A. No file update required, switch is allowed. So for example, we created, as part of commit B, we added a line, my name is Varun, in intro.text. And this is the main branch. Then what I did was git checkout -b. I created a new branch called feature intro update. And then this resulted in creation of a new branch and also switching to that branch. And then what I did was I have intro.text, my name is Varun, same, but when I created a new branch, both of these start pointing to the same commit B. Why commit B? Because main already has this as the latest, which is why main is pointing to B, and feature intro update does not have any commit right now, so it will point to the commit from where it was created. It points to that commit. Then what I did is I came to my working directory. I modified intro.txt to have my name is Varun Joshi. And then if I tried to check out, the checkout was allowed. Why the checkout was allowed? The checkout was allowed because working directory remains unchanged, because the checked out branch points to the same commit. So no file modification is required. That's why it allowed you to switch, because both of these are essentially pointing, both of these main and feature intro update are essentially pointing to the same commit, which is commit B. Hence working directory changes were not to be modified, hence Git allowed you to switch. But when I talk about this scenario, working directory must be updated to match the checked out branches commit, and the checked out branches commit was commit C, but the switch is blocked because this would modify this file. My name is Varun Joshi would be lost if Git allowed you that. Hence Git does not allow it. In simple terms, Git stash allows you to park your changes and switch the branch to do your work. Git does not block switching because branches differ. It blocks only when your uncommitted changes would be overwritten, modified, or lost. Keep that point in mind. Now, with this distinction, let's go and perform a demo. So I will clear my screen so that you have a clean state, and then I will write git init, and this time if I pressed enter, this will be initialized. But what I want to do this time is I want to show you something interesting. I want to write git stash demo. Now what this will do is it will create a directory called git stash demo and also initialize it. If you see, it is saying that initialized empty git repository in this git stash demo. So I can now cd into git stash demo, and I see main here because main is the branch that we are currently working on. Now what I will do is I will add two commits, and these two commits I'm adding as a baseline commit so that we can work through them. And these commits are pretty simple. In the first commit as well, I'm adding the same line, my name is Varun. In the second commit as well, I'm adding the same line, my name is Varun. And I'm doing this so that we have two commits while we start working here. So if I press enter, you see there are two commits already, and we are in this state like we saw here. Now what I want to do is I want to git checkout, and this time what I want to call my feature branch is intro update, like you see in those images. Okay, intro update, I'll press enter. So this has created a new branch and switched me to that new branch. Now let's write that same thing here. My name is Varun was already there. Now I am adding my name is Varun Joshi in intro.text. So if I press enter, and if I now try to git checkout main, this checkout will be allowed. And why this checkout is allowed, we have already discussed that. So if I run git log -- one line, you see that both of these branches are pointing to the same commit. So the working directory, the file that is in the working directory, need not to be modified if I switch to main branch, which is why this was allowed. Now what I want to do is I want to have this case B. I want to show you case B where Git will not allow our checkout, and we have seen that in our previous demo as well. The checkout was not allowed, but this time we want to see it with some context and understanding. And again, why this was allowed, because the current is equal to target, so Git does not need to update the file. Now I will add one more commit in main. So what we are doing is we are creating a commit C, and when I do that and when I run git log one line, this time I see now main has moved ahead. Main is pointing to this commit, but feature intro update is still pointing to the same commit place. So these two branches are now pointing to different commits because their latest commit is different. Now what we will do is we will git checkout feature intro, and then what I will do is I will add one more line here. Okay, and that line is same what we saw here. I'm adding this line. My name is Varun Joshi. So I'll press enter. And now let's try to check out main. Git checkout. And it says your local changes to the following files would be overwritten by checkout. And this is that file name. Please commit your changes or stash them before you switch branches. So it is aborting. Again, working directory must be updated to match the checked out branch commit. So if I switch to main, then I should ideally see this line, right? These two lines here. My name is Varun. I live in India. But if it allows me to switch, then whatever is there in my working directory right now, cat intro, my name is Varun Joshi, these changes will be lost. Hence, Git will not allow me to do that. And that is what you saw. Now, how do I do it? What I can do is I can write git stash. I'll just write git stash. I'll press enter. And this says saved working directory and index state work in progress on feature intro update and this. Now, what I can also do is I can run git stash list to see my stash list, and I can have multiple stashes. And then if I have to bring back the changes that were there in a stash, we will see how to see that. For now, I will run git checkout main. Now, since I have parked my changes, I can now freely switch to main. And once I have done that, I can here also run git stash list. It will tell me this. Now, what I will do is I will come back to my feature branch. And how do I bring whatever I had in my feature branch here, whatever I had in my intro.txt? Because right now here intro.txt just has my name is Varun. Why does it have my name is Varun? Because we created it from commit B, and commit B had my name is Varun. Commit C had I live in India. But what I now want is I now want my working directory to be back to my name is Varun Joshi. So how do I do that? Git stash pop. Now I could have also supplied this here. I could also supply this here. If you have multiple stashes, you can call out the stash that you want to pop. So I want to pop this stash. I'll press enter, and you see if I now run cat intro.txt, whatever was there, my name is Varun Joshi, is back in my working directory. So I hope you understand what stash will do for you. And that was the last topic. I will let you go to the browser, and I will encourage you to go to this part 2 and then read about git stash. I have added some notes that will help you on understanding git stash in a better way too. So that concludes part 2 of the Git masterclass. In this lecture, we moved from local Git workflows to real world collaboration. You saw how remote repositories act as a shared system, how authentication secures access, how push, fetch, and pull help synchronize changes across developers. We also explored PRs and understood how teams introduce control, validation, and review before changes enter a stable branch. Finally, we looked at Git Stash and how it helps manage context switching without polluting commit history. At this stage, you should have a clear understanding of how Git is used in production environments to manage and control changes across teams. In part 3, we will go deeper into advanced concepts like rebase, squash, and production grade end to end workflows, and understand how teams maintain clean history while scaling collaboration. If you have any questions, feel free to ask them in the comments section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much. Hi, I am Varun Joshi and I welcome you to part 3, the final part of this 3-part Git masterclass. In this final part, we focus on something that is often overlooked but critical in real world system: how Git history is structured, refined, and maintained at scale. We will start by understanding the limitations of merge and why history can become difficult to read in complex projects. From there, we will introduce Rebase and see how it helps maintain a clean and linear history. Next, we will go deeper into interactive rebase, where we will learn how to clean up commits, combine changes, and prepare meaningful history before sharing code. We will then move to squash at the platform level and understand how teams control and how changes are recorded when integrating through pull requests. Finally, we will cover cherry pick and see how we can selectively apply specific commits without bringing in entire branches. Throughout this lecture, we will combine concepts with hands on demos, focusing on how strategies are actually used in production environments. So, without further ado, let's get started. So let's start with understanding Git rebase. Now, firstly, I want you to understand one thing very clearly. Up until now, what we have been doing is we have been creating feature branches or any working branches, and then we have been merging those branches onto the main branch or the primary branch. But will this flow always be this one directional? Can't we have something in main that we want our feature branches or working branches to access? For example, let's say you created a feature branch, you created a couple of commits, and then you went on a vacation. And once you came back from vacation, the main progressed and the main now has 10 new commits. But you do not have any information about those commits. In that scenario, what you would be doing is you would want whatever changes were performed in the main when you were enjoying your vacation to be available to your feature branch, so that you are working with the latest code. And understand, whenever you are working with these feature branches or any of these working branches, you want to be working with the stable releasable code at all times. And where does the releasable code resides? That code resides in your primary branch, in your main branch. Hence, whenever your feature branch is not in conjunction with the main branch, then what you would want is you would want the latest code to be available to your feature branches. So the crux of what I said is the flow of merging, the flow of integrating one branch into another is not just limited to bringing in whatever was done in feature to main. It can also be vice versa. You may also want to bring whatever was done in main to your feature branch. So if you see this example here, when feature login was created, it was created from commit C. So whatever was available till commit C will be accessible to feature login branch, but whatever was done in commit F will not be available to feature login branch. What we want is whatever was done in this branch should also be accessible to feature login branch. And we did the opposite of this in our merge lecture. So if I go here, what did we do? What we did was we brought in the changes that were performed in the feature login branch to the master branch in our example, and that resulted in a merge commit. But today we are discussing a different scenario. Today we are saying we have this feature login branch, but we want this feature login branch to also have access to whatever was done in this commit F, and that is what we will be discussing today. Now, Before I start saying anything, I want you to clearly understand that when we talk about integrating changes from one branch to another, now this could be any branch, this could be working branch, this could be the primary branch. The crux is whenever you want to integrate changes between two branches, you have two ways to do it. You have merge, which we have already seen before, and then we have rebase, which we are going to see right now. Understand the final result of both of these from a code perspective is the same. The code outcome will be the same. How merging and rebasing differ is how the history is represented. So that is why I have a line here: same code outcome, different history representation. Now that you have this basic idea that whenever you want to integrate changes between any of the branches, you can use merge or rebase. Now let's understand the nitties and gritties on how differently the history is represented when we are dealing with merge and when we are dealing with rebase. So that's why I have kept this refresher section here, so that if you have learned about merged 10 days back, your memory is still fresh. So let's understand what we know about merge. Now merge, as we understand, is of two types. You have fast forward merge and a three-way merge. Simple way to understand is whenever there is branch divergence, then you have three-way merge. And what exactly is branch divergence? Branch divergence is a situation when there is parallel development. So we created this feature login branch from C, but after C, master also has a commit and feature also has a commit. Hence there is branch divergence, and whenever there is branch divergence, a three-way merge is performed. A three-way merge, in simple terms, it creates a merge commit, whereas the fast forward merge occurs when there is no branch divergence, and you see there is no merge commit created when we talk about fast forward merge. Now let's go back here. So what we know about merge: combine changes from one branch into another, that is obvious. Preserves full history including divergence. Now I want you to clearly remember, when we wrote git log one line graph, then we saw the branch divergence and we also saw the integration points. Now what is branch divergence? We just learned. What are integration points? Integration points are essentially the merge commits. So when I talk about merge, you will see that the history is preserved including the divergence. Creates a merge commit when branches diverge, and we know this from our three-way merge lecture, that whenever there is a three-way merge, a merge commit is created. Merge commit has two parents, both histories. Now this is an important point. So if I talk about commit G has two parents. It is F and E. So when I talk about this merge commit, if this merge commit, we have to go to C from this merge commit, there are two ways. I can go via F and I can go via ED as well. So there are two ways via which from commit G we can reach C, B and A, because this merge commit has two parents. Now the next point is results in non-linear history, branching visible. Now I want you to understand this term very clearly: linear versus non-linear. Now let's forget about Git for a moment. In plain English, linear means a straight line. Non-linear means a graph-like structure. It goes up, it comes down, like our life. Our lives are non-linear. We have happy moments, we have sad moments, we have neutral moments, and so on. So linear, straight line; non-linear, a graph that goes up and down. So what we know about merge is it results in a non-linear history. And why we are saying merge results in a non-linear history? Because there are merge commits. Now if I have to refine this line further, it says results in non-linear history, but I would say only three-way merge results in non-linear history, because if I talk about two-way merge, there is no merge commit. Hence what you see is a straight line, and hence with fast forward merge you have a straight line because there are no merge commits. But when I talk about three-way merge, you see a merge commit. So history is still linear when you are using fast forward merge because everything is represented in a straight line. But when I talk about three-way merge, you have non-linear history. And why the history is non-linear? Because you have a merge commit and you have two ways to reach a commit. Hence the history is non-linear when you are dealing with three-way merge, and it is imperative that you understand this point because that is one critical difference between merge and rebase. Merge results in a non-linear history. Branching is visible, shows how development actually happened over time. So when I talk about merge, it will tell you exactly how things progressed. It will tell you when divergence happened. It will tell you exactly where are the merge commits. So you have a very clear history. Now you must be thinking, but Varun, I like long history. What is the problem if I know exactly when was branching done, when divergence occurred, when there were merge commits? If I know all these things, it is good, isn't it? Why would I want anything else than long history? Now there are consequences of long history. For example, interpreting a graph rather than following a straight line. So like we saw when we ran git log one line hyphen hyphen graph, what we saw was we saw everything. We saw the divergence, we saw the merge commit and so on. And when you are troubleshooting things deep, you may not want to see all of these things. You want to see a straight line which simplifies everything for your troubleshooting. Of course, for projects that are smaller in size, long history may not matter that much. But when you are dealing with enterprise grade applications where there are hundreds, thousands of commits performed per day, there are several branches created per day, several merge commits created per day, in that case you may not want to see that history all the time because it makes debugging more complex. Code reviews become harder because changes are spread across branches and commits. So you at times want history to be simplified. Now understand one thing very clearly. I am not telling you to not use merge. I am not telling you to use rebase all the time or vice versa. What I am telling you are the differences between merge and rebase, because I want you to choose the strategy of integrating different branches based on your requirement, not based on what is a standard, because there is no standard. It depends on your use case whether you want to use merge or you want to use rebase. Now I understand we have not talked deeply about rebase yet. We will do that in a little while. Now that we have this understanding, let's see why rebase exists. I'll also zoom in a little more here. Yes, why rebase exists. Frequent branching creates complex history. We know that. Merge preserves history but adds branching. We know that. History becomes harder to read over time. We know that. Need a cleaner linear sequence of changes. So when you want a cleaner linear sequence of changes, then my friends, rebase is your best friend. And I assure you, after this demo, if any of you was afraid of rebase, you won't be anymore, because we'll be dissecting this step by step, inch by inch. Then there is what is rebase. Moves your branch onto the latest base. Interesting. We are calling it rebase. Rebase. We are redoing something. And what are we redoing? We are redoing the base. That is why it is called rebase. For example, if you see this diagram, what we saw, the base was initially C, and that is from where feature login branch was created. What rebase will make it appear is that this branch was created from F. I am just telling you a high level view right now why this is called rebase, because when you look at it, when you look at the history, it will appear as if this feature login branch was created from F, not from C. That is what rebasing will do for you, and that is why it is called rebase. You are changing the base, so to speak. Then the second is does not create a merge commit. Extremely critical point. When you are dealing with three-way merge, a merge commit is created always, but with rebase there is no merge commit. Produces a clean linear history on that branch, and we will see how this looks like. Let's come here now. So let's say you are a developer or a DevOps engineer. You want to bring the latest main into the feature branch. So you want essentially whatever was done in commit F should be available in your feature login branch, because as we all know, both merge and rebase are doing the same thing. They are integrating different branches, but how they do so is different. One preserves the entire history, which is merge. Then another is rebase, which makes the history linear for you. The end result is the same code outcome, different history representation. When I talk about merge, preserves true branching history, the actual timeline. When I talk about rebase, rewrites branch history into a linear sequence, and we know what is linear, a straight line. Now let's see what happens under the hood when you write git checkout feature login and write git rebase main. Now previously when we were dealing with merge, we were just using merge in place of rebase. Rest everything was same. We used to check out our feature branch, and from that branch we ran git merge main. And here as well we are checking out the feature login branch, but instead of merging that, we are using rebase, git rebase main. Now when you run this command, what happens? What git will do is it will identify the commits not in main. So what are the unique commits in feature login branch? D and E, my friends, are the unique commits that are in feature login branch. So it will identify these commits. Now if this had more commits like Z, X and so on, it would have taken those commits also into consideration, because it is identifying the unique commits. What are the unique commits which are unique to feature login branch? In our example right now, those commits are commits D and E. So it will identify them, and then it will temporarily remove them from the feature branch. And once it has done that removal, it will move the base from C to F. So these commits D and E are now removed, and previously their base was C. Now the base is changed to F, and once the base is changed to F, then these commits which were temporarily removed, they are replayed as commits D dash and E dash. Critical thing to understand is when you are rebasing, both your commit hashes for D and E will change, because we are replaying the commits. The commit hashes will change. That is why if you see this line, these are represented as D dash and E dash. So after you have performed this rebase, if you check main, your main will have 4 commits like it had before, because we are not doing any changes to main. This point is critical to understand. Even when if we were running merge, we were running git merge main, we were not changing anything that was there in main remained as is. Similarly, if I go here, when we were performing git merge feature login in master, we checked out master and then we ran git merge feature login. Here as well, we were performing the changes in master. Feature login remained as is. Understand the branch that is taking the merge. For example, if I'm merging feature login with main, then main will change, feature will remain as is. Similarly, here if we are bringing in the changes from main, that is we want to integrate main with our feature login, in that scenario main will remain as is. And you see it right here, main had 4 commits before, it has the same 4 commits now even after the rebase, but feature login has changed. It previously had commits D and E, but now the base has changed and D dash and E dash appear. The critical thing to understand is the commit hashes changed and why we are calling it a rebase, because we are changing the base. In our example, we are changing the base from C to F. Now history is linear. I hope rebase is understood. One final section, merge versus rebase. Merge preserves history, creates a merge commit, understandable. Rebase rewrites history, no merge commit, like we saw in this diagram. Merge keeps branching structure non-linear, we have seen this. And this is, again I'm repeating, this is limited to 3-way merge. If you perform a fast forward merge, then your history will still be linear. So when we say merge creates non-linear history, the specifics of that is 3-way merge creates non-linear history. If we are performing fast forward merge, if fast forward merge is performed, then the history is still linear. Rebase produces a clean linear sequence of commits like we saw here. Both same final code, different history representation. This is the critical point, and this is a favorite interview question, and most definitely rebase and merge, you will be tested on these things. So understand the foundations, then no matter what scenario is thrown at you in the interviews or in your production scenario, you would have your way out somehow. Okay, now let's go to the demo of a rebase. So I will go to my command prompt. Okay, so I am in part 3, project files is the directory where I am in. So what I will do is git init, and then I will be creating a directory called git rebase demo. This will create the directory and also initialize this for me. So I'll run this. It says initialized empty directory. Now if I cd into this directory, my prompt will have main here, because main is the default branch name I am using, and we changed this from master to main in our part 1. So now I will run here. Now I will create 3 commits. So what we will be doing is we will be replicating whatever we saw here, so that you can relate what we learned in theory with what we are doing in the demo. So what I will do is I'll go to my command prompt again, and from here what I will do is I'll create 3 commits. Okay, I'm copying the 3 commits and I am pasting it here. So understand what I am doing. What I am doing is I am creating a file app.txt. I am adding application initialized a line in that file app.txt, and then I am moving that file to the staging area. Then I am committing it, and the commit message is chore initialize application. In the second and the third commit, I am doing things a little differently. So if you see, I am not running the stage command here, but in the commit part, I am directly adding a flag -am. So what git commit -am will do is, once a file has been staged at least once, so app.txt has been staged at least once in this first part. So once a file has been staged at least once, git commit am can be used to automatically stage and commit further modifications to that file in a single step. So if I write this, then what it will do is it will stage and commit in one go, and that is what we are doing. So we are adding 3 commits. So I will press enter now, and if I run git log one line, I see 3 commits here. Okay, this we have seen multiple times. Now I want you to understand one more thing. In production, you will be running things like git fetch and git pull. Remember what we discussed in our previous lecture. What we discussed was remote repositories, and we learned our primary branches like main, release, production. These are often protected, and protected implies you cannot directly push to these branches, right? There is always a PR process involved. So let's say if you were working in production and you would want to know whether your feature is in line with whatever is there in main. In that scenario, once you come to your office, the first command you would typically run is git fetch and git pull workflows, so that you know when you were gone whether main progressed further or not. If it did progress, then you would want to bring in those changes, and like we are going to do in this demo, we will be integrating those changes onto our feature branch or onto your working branches. So now what I will run is I will create a feature branch. What I will run is git checkout -b, and let's call this, like we have done before, feature login. And once I do it, I will press enter. And if I now run git log one line, we see that head points to the currently checked out branch, which is feature login, and our feature login branch points to the commit from where it was created, and main points to the latest commit in the main branch. So when this branch is created, this points to the commit from where it was created. And like we saw here, so if I go take you back to the diagrams, we have done these 3 commits, and we have just created the feature login branch. There are no commits in the feature login branch. That's why feature login is pointing to commit C, and main is also pointing to commit C, because we have not performed these things yet. Now let's go back here. Now I want to show you parallel development. What is parallel development? Because I'm doing this to have branch divergence in this demo, so that we see it clearly how things are there in production. Because in production you would often see there is branch divergence and merge conflicts occur all the time. In our scenario, in this demo, we'll be seeing rebase conflict. So merge conflict, rebase conflict, you will see these all the time. I don't want you to be afraid of these things. If you understand the foundations, what we are doing, what is a conflict? Conflict is same part of the file is modified differently in different branches. In that scenario, there will be a conflict. And if there is a conflict, you resolve that conflict. And how do you resolve that conflict? You resolve that conflict by choosing what changes you want to preserve and what changes you want to discard, or maybe you want to have both the changes. So you decide these things while you are resolving conflicts. And conflicts, like I said, in this demo, we'll be seeing rebase conflict as well. So what we'll now do is I will git checkout main. Okay, I'll go to main branch, and in main branch I will perform a commit. And once I perform this commit, and I will paste it here, and the commit we are performing is creating a file cwvj.txt, and we are adding cloud with varjosh teaches real world DevOps, and there is a commit message as well. So now what we have done is we have reached at this stage. We have created a commit F in our main branch. Now what I want to run is git log one line so that I can show this to you here as well. You see there is a latest commit in main, and now main is pointing to that commit. Previously main was pointing to this commit, but now since this one is the latest commit in the main branch, it is pointing to this commit, and feature login is still pointing to the commit from where feature login was created. Now what we want is, now we want to perform a couple of commits in the feature branch. So that is exactly what we are going to do now. So I'll copy the commits real quick. I'll check out the feature branch first. I'll go here, I'll paste it here. So I'm checking out the feature login branch, and then understand what we are doing. We are modifying cloud with, we are creating a file cloud. Hold on. If I run ls, you see cloud with varjosh.txt. If I cat this file cloud with varjosh.txt, you see whatever we added in that commit. Okay. But if I git checkout feature login, if I run ls, I don't see cloud with varjosh.txt here, because understand, cloud with varjosh.txt was created based on this commit, and our feature login branch does not have visibility to that commit. So that's why it cannot see cloud with varjosh.txt file. I hope you understand this from our part 1. Now what I'm doing is, since I'm already in the feature login branch, I want to create 2 commits in that branch, and those 2 commits are here. So what I'm doing is I'm creating the same file cloud with varjosh.txt, but I'm adding a different content. I'm adding in it cloud with varjosh focuses on production grade training. Previously I added something else. I added, if I look, yeah, cloud with varjosh teaches real world DevOps, but this time I'm adding something else, and I am doing this so that I can show you rebase conflicts as well. And then I am just adding one more commit, and this commit deals with app.txt, which is accessible to both our branches, but the content here would be different. We are adding one more line here. So I'll press enter. And if I now run git log one line all, and I'll also add graph here, then I will see the entire structure. Now the thing I want you to concentrate on is the divergence, right? Here is the 4th commit that we created on main, and this is where we created cloud with varjosh.txt file. That is why you see a divergence here. And then these 3 commits are common to both main and feature, and then feature has had 2 more commits, and this is exactly what we have shown in the diagram. So if you go here, these are the 2 commits in feature, these are the 4 commits in main, and this one is just personal to main, and these 2 are just personal to feature login. So if I go here, you see 1 2 3 4 5 6 commits. 1 2 3 4 5 6 commits in total. Now that we have this understanding, I want you to know one thing very clearly. After rebase, history becomes linear because the divergence is no longer visible and no merge commit is created, even though divergence originally occurred. So here we see the divergence, but when we perform rebase, this divergence will be gone. Woof. So let's do that. Okay, so let's now we are already in feature login branch. So what I will run is git rebase main, and I will press enter. And read these messages all the time, because they will tell you exactly what you should be doing next. So they are saying there is a conflict. We understand that. Then it is saying hint, resolve all conflicts manually, mark them as resolved with git add, and then git rebase continue. So what it is telling you to do in plain English is, first resolve the conflicts. Once the conflict is resolved, you add the file, you move the file to the staging area. And once that is done, you run this command git rebase hyphen hyphen continue. And if you want to get out of what just happened, you can simply run git rebase skip and it will take you out. So read these messages very clearly. Another thing I want you to notice is here you see rebase hyphen I. Now, many of you might already know about interactive rebase. We'll be discussing that next. But here rebase hyphen I is a prompt that indicates that there is a rebase in progress. It is Git's internal sequencer. It does not necessarily mean an interactive rebase. Okay. So keep that in mind. Now what I want to do is I want to go to my Visual Studio Code and I want to resolve this conflict. So if you see part 3, there is a dot here. And if I expand this cloud with varjosh.text and this has an exclamation mark, that implies you must be fixing certain things. Now it is telling me that from mainline you have cloud with Varjosh teaches real world DevOps, but in your feature login branch, Varun, what you have is cloud with Varjosh focuses on production grade training. Now what is that you want to do? Do you want to accept the current change, accept the incoming change, and then accept both changes, or you can compare changes? We already know what is to be done, but I also want you to know if let's say Visual Studio Code was not there. So if I come here, if I cat cloud with varjosh.text, you will see something similar here. What you can also do is you can open Vim and only select what you want to have. But since I have Visual Studio Code, I want a click mechanism. So what I want to do is, what is that you want? I want to accept both the changes. And you ask why, and I say because both of these lines are true. Cloud with Varjosh teaches real world DevOps, check. Cloud with Varjosh focuses on production grade training, check. So I will accept both the changes. Now my file has both of these. I will close this. And now if I run git status, my friends, I would see that you can add this. So I will run git add. What was the file name? This was the file name. Press enter. And I still see rebase hyphen I here. And I will write git rebase continue. And I do not have to remember this. The prompt told me that once you have done this, you run git rebase hyphen hyphen continue. I'll press enter. And now it says, do you want a different commit message? So just for the sake of having a different commit message, I will add here my name so that you know that this is resulted from, whatever we did here. So I'll save this, and then you see rebase hyphen I is now gone since we have resolved the merge conflict. Since we have resolved the rebase conflict, that is gone, and rebase has completed successfully, which is why this has completely gone now. What I can now run is the same command like we ran before. Git log one line all hyphen hyphen graph. Tada! You don't see any divergence. The number of commits, they are the same. 1, 2, 3, 4, 5, 6. 6 are the total commits. And here as well, if I go to my diagrams, I see 6 commits. So the number of commits have not changed. And why they have not changed? Because rebase does not create any merge commits. It just replays your commits. And I want to show you one more thing. Here was the commit, right? Feature introduce CWVJ learning philosophy content, and commit ID ended with E4. E4 still exists, right? But both of these commit hashes have changed. So if I go here, the commit hashes were 9DBE, and here you see 0BCC. I also want you to know one more thing. Since here there was a rebase conflict, we have changed this, we have added VJ, but the commit message for the last commit, we have kept it the same. So if I now cat app.text, I see all of these things that were there before. And if I git checkout main, and if I run cat app.text, you see this is not there because this was added as part of feature. So that commit remains, but the commit hash has changed. We have a linear history, and that is what we wanted. Now, as a final step, feature login is in line with whatever was done in the main, right? Now, what I can do is I can go to main and merge this feature login with main, because eventually whatever was done in feature login has to be accessible to main. Only then whatever feature you have worked on will be available in the main line. So what I will now do is I will run git merge, and what is that I want to merge? Feature login. So I'm merging feature login to main, and once I have done this, if I now cat crowd with varjosh.text, I see both the lines in the main line of development as well. Previously, only this existed there. Now, after performing this merge, I have both these lines available. And if I cat app.text now, I see all the 4 lines. And this line was added as part of feature branch. I hope all things are connected, but I see one more problem. That problem is I said that main is often protected. So is there any point in performing this merge? No, right? Because my main has this. If I push this, I will be denied because main is protected. So what is the way in production? In production, what you do is once you reach till this step, okay, once you have rebased your feature login, what you will do is you will push feature login to your remote. And once feature login is pushed there, you will perform the changes, as in you will be raising a PR, and upon that PR approval, the merge will be performed in your remote, because you do not push directly to your protected branches. And I want to show this flow to you. So I will go to my browser, and here is my homepage for Cloud with Varjosh, and Git Masterclass is the repository where you can find all the notes. And if you have not already started, I would request you to please start this repository if this is helping you out. So I'll go here, and then I will go to part 3 because this is where I want to show you. And if I scroll down here, you will see production workflow and rebase in practice. So I will click here, and this will clearly show you the typical production workflow. Work on your feature branch, rebase your branch with the latest main, push your feature branch to remote. So these two we already did. Then it is saying push your feature branch to remote, create a pull request from feature login to main, and we have already done this in our remote repository lecture. After approval, the platform performs the integration. Now here you can perform a merge, a rebase, or a squash, and we will see both of these options later. But for now, understand whatever merge that we performed here in the CLI, you can perform this merge in the platform as well. Now, another question that comes to mind is when to use rebase and when to use merge. Now, I will tell you one thing. Whenever you are dealing with shared branches, what are shared branches? Shared branches are the branches where multiple developers are working. There are multiple collaborators. So when you are dealing with shared branches are not rebased. Now, why is it? Because we have seen that when we are performing rebase, the history is changed. Because if I go back here to my diagram, you see D and E were rewritten as D dash and E dash. So it is rewriting history. And when there are multiple collaborators, imagine you have pushed to a remote branch, modified commit, and when another developer performs a pull, he or she will realize that now he or she has duplicate commits. So you don't want that, because history, when is shared between many developers, it does not make sense to change it, because if you rewrite history, it can cause divergence across local clones, duplicate commits after sync, broken or confusing histories for collaborators. Now, mostly whenever you are working on a feature branch, you will be the single person working on that feature branch. Hence, you are free to, perform rebase. But when you are working with shared branches, it is likely that you will see that rebasing is not allowed because it rewrites the history. But if you are a single developer, like the workflow we performed right now, you would often see this performed. You would be working on a feature branch, and if main has progressed, you will be bringing in the changes that were performed in the main onto your feature branch. So understanding this flow is critical. When to use merge, when to use rebase, understand these points. And I would urge you to go and read the GitHub repository to strengthen your knowledge. Now that we have understood rebase, what I want to discuss next is interactive rebase. So I'll scroll down, and this is interactive rebase for you. Previously, what we did was, this is the diagram that we saw before, exactly the same diagram. Now, when we were performing rebase, what we saw was whatever was there in, feature login, whatever unique commits were there, they were replayed, right? And that resulted in different commit hashes. But it did everything automatically. There was no user control, and that is what rebase is. It will choose your unique commits and then it will rebase them. And at times you may want to combine related commits, you may want to reorder commits, you may want to edit commit messages, you may want to remove noisy or unnecessary commits. So for example, let's say you are implementing a feature in a local branch, okay, and you have created 10 commit messages, and 10 commit messages, in the first one you said modifying some login code. In the second commit message as well, you wrote modified something else because the code was not working. Third commit, modified again because it didn't work. And this carried on for 10 commits. And understand, in production implementations, when you are working on a feature, it is highly unlikely, I'm not demoralizing you, but this is the truth, you will not get things right at the very first time. So you will have multiple commits where you will be performing the commits, testing, and so on, and that will result in so many noisy commits. And at times, or most of the times, you don't want that. You want, if let's say 5 commits you troubleshooted something, you only want to just keep one commit. You want to consolidate those commits into just one commit, and that is understandable. You want a cleaner commit history. And what we learned in the very first lecture, what we learned was commits must be focused. If you are doing troubleshooting in 10 different commits, then it might not make sense, right? So you would want to combine those commits. And rebase at its default state does not allow you to do that. Hence, interactive rebase was born. Now, interactive rebase, what it does is, it will allow you to combine related commits, it will allow you to reorder commits, it will allow you to edit commit messages, and so on. And if this is hazy right now, don't worry, when we do the demo, all of the things will be connected. So what is interactive rebase? Replace commits with user control instead of automatic replay. So you will have control over how things are done. But Varun, why would I want anything else other than interactive rebase? I want full control over how things are rebased. Why would I use default rebase? Understand, there are different use cases, okay? You may not always want to perform changes. You may want whatever was done should be available as it is. And like we saw in our example, when we were bringing in changes from main to our branch, we may not want to change anything, and this will get more clear when I discuss the usage patterns. But for now, I want you to understand, if you are working on a feature branch, you have 20 commits, okay? You don't want to send all the 20 commits, if those 20 commits are noisy to your remote. Why would you want that? You would want your superiors or your leads to only see critical junctures within that featured login branch. You may not want to show everything. In that case, if you have 10 commits, you may choose to consolidate them into just 3 commits, 2 commits, or maybe even a single commit, so that when things go to remote, only that single commit is visible and everyone superior to you do not see the noisy commit history. In that case, you can use interactive rebase. Opens a to-do list of commits, oldest to newest, so that you can pick and choose what you want to do. Rewrites history, creates new commit hashes, and this behavior is similar to rebase. Now if someone asks you what is the difference between rebase and interactive rebase, so rebase will just replay your commits. Interactive rebase will replay your commits but will give you an option to reshape your commits, and reshaping can be done using any of these means. So combining is also reshaping, reordering is also reshaping, editing is also reshaping, removing is essentially also reshaping. Now I want to discuss these two usage patterns so that you know that interactive rebase can be used in two specific ways. So I'll go to my GitHub repository, I'll go at the top, and then here interactive rebase usage 1. Now usage 1 is rebase plus reshape. So whatever we did in the previous demo, what we did was just rebase. Now the use case for interactive rebase is you can rebase plus reshape commits at the same time. So for example, if you wanted to change anything about these two commits, you could have done that. Now this is one usage, and we will see this in the demo to make it more clear, but for now this is the usage pattern 1. And then second is reshape recent commits, and this is available for local branch cleanup. And see, you will be using both of these depending on your requirement. I am showing both of these to you so that you know that interactive rebase is not only limited to local branch, because this is the use case where you are only dealing with a branch. Within that branch, you are changing the commit messages, reshaping the commits, and so on. Here, while you are integrating changes from a different branch, you are also interactive rebasing. You are reshaping the commits. So now that we have a high level view of both these scenarios, let's go to the CLI and perform a demo which will make things much clearer to you. So I'll first go through the diagrams, then I'll go to my iterm, I'll clear my screen, I will go one back, I will rm-rf this git rebase demo, and now I will run git init, and this will be git interactive rebase demo, and I'll press enter, and then I will cd into git interactive rebase demo. Now what I'll do is I'll create one commit message. So I'll copy this, I'll paste it here, and what we are doing is we are creating app.text initial app setup, and then we are moving that to the staging area, and then we are committing it initial setup. So I'll press enter, and this says one commit is performed. So if I run git log one line, then I'll see just one commit message. Now what I want to do is now I want to create a new branch. So I'll run git checkout, and this time I will call this branch feature login like we have worked with before. So I'll press enter, and again if I run git log one line, I would see feature login is created, and it points to the commit from where it was created. Now I want to do iterative development, so I'll create certain noisy commits in the feature branch. So what I'm doing is, watch it very carefully, okay? So I'm creating 3 commits, and the first commit is add login UI, and the feature is add login UI. Then I'm saying fix adjust login UI. Then I'm saying refactor cleanup login UI. So if you see, these are noisy commits, and I'll press enter, And if I run the same thing again, git log one line, then you see these three commits are logically related and represents a single feature development incrementally. Okay, so they are better represented as just one single commit. Why do I have to have these three commits if these three are like an umbrella view of a single commit? And that single view is add login UI. And that is what we just discussed in our GitHub repo, that usage 2 is reshape recent commit. So this is when you want to interactively rebase your local branch. That is when you will use this git rebase -i head 3. But when you want to, interactively rebase, here instead of git rebase main, you can write git rebase -i, which stands for interactive rebase, and it will work similar to what we saw in rebase. It is just you have an opportunity to reshape the commits. That's the only difference. So we are not doing this in the demo, we are doing this in the demo. Okay, so let's go here. Okay, now what I want to do is I want to combine all these three commits into a single commit. So what I will now do is I will do git rebase -i head 3. Now what this will do is it will check the latest three commits. Okay, now if I would have done 5 here, it would have checked the last 5 commits. Then if let's say you must be thinking, Varun, what if I have 50 commits? How do I know the number of that commit? In that scenario, you can pick any of that commit ID. Instead of head 3, you can just write that commit ID here, and then it will take any commits onwards to that commit ID. So if you write this commit ID, it will choose this, this, and this. So here I only have 3 commits and I'll write head 3. Now once I write this, I will press enter, and it has opened a Pandora box at me. It is saying you can use all of these things: pick, revert, edit, squash. Squash is something that you will often use, which is used to consolidate, and it says use commit but meld into previous one. So we are not saying discard it, we are saying consolidate it, meld it with the previous commit. And here it is saying what is that you want to do with this commit. And understand, you see the oldest commit first here. So this is the oldest commit, this is the second commit, this is the third commit. So oldest is first, but when you run git log, by default what you see is the latest commit first. Here you are seeing the oldest commit first. So now what I will say is, do one thing, my friend. I'll go into insert mode. I will say you pick this commit. And what does pick implies? Pick says keep commit as the base commit. So I am saying use this as the base commit, and then squash this one, and then also squash this one. So what we are saying is, when I say squash, you already know it will meld. So first you consolidate this with this, and then this with the result of this and this, and that is understandable. And I will let you explore other options. Okay, there are many options that you can choose from. I'll hit escape shift ZZ to save this, and now it is asking what is that the commit message you want to have. And here, so that we can identify it, I'll go into insert mode and I will add here VJ, and I will escape shift ZZ. Now see what would happen. If I run this again, git log -one line, our 3 commits are gone and there is just one commit. So it has taken one base commit and then squashed the 2 commits into that. Now I want you to know that you cannot run squash in all the 3 commits. Okay, you have to pick at least one base. So you pick one base and then you use squash. So here, like we said, if I go to this definition again, if I go to draw.io, we have essentially reshaped our commits and combine related commits. So this is what we have used, and you can use any of these based on the options we saw on screen. So I hope interactive rebase is understood, and you also have a clear understanding when to use interactive rebase. And it is simple. When you want to reshape the commits, the commit messages, the contents, combine related commits, then what you can use is interactive rebase. But when you want something simple, something automatic, something that will take care of rebasing in itself, then you use interactive rebase. Now that we have understanding of interactive rebase, I'll clear my screen. I'll go one step back, and then I have to show you one more thing before I end this demo. I'll go into that directory again, and here I am in feature login branch. So what I will do is I will run git switch main. Oh, I have see, up until now we have used checkout to check out different branches, but you can also use switch to check out different branches. So git switch main will do similar function to git checkout main, but git switch is the latest one, is the modern one when you want to switch branches. So I would suggest you to use git switch whenever you have to switch branches. Now previously we have used checkout, and like I said, they're essentially doing similar things, but checkout is a little heavy, and I will let you read about them. I've added how they are different in the GitHub repo, so I don't want to break this flow, so I'll let you read that. But in modern systems I would suggest you use git switch. So I'll switch to main, and what I now want to do is I want to bring in the changes that were performed in feature login to main branch as well. So if I do ls and if I cat app.text, I see initial app setup only. Now let's run git merge feature login, and once I do that and then I cat app.text, then you see whatever things were done, all the three changes are there. See, we did not modify any content. We just said that you pick a certain commit and squash rest of the two commits. So that is what we have done. I hope this is crystal clear to you. Now I will just perform a little cleanup. So I will go one step back and I will delete the directory that we created for interactive rebase. I'll clear my screen, and now let's go back to our diagrams and let's see what I want to discuss next. Squash merge, concepts and behavior. Now understand, whatever squash we did right now, that was part of interactive rebase, but there is a squash and merge functionality that is available in the platforms like GitHub. We will see all the strategies that are available in platforms like GitHub, which are used to integrate changes from one branch to another. Now understand, we are talking about platform because when you have pushed something into your feature branch, you would want to, whatever you have done, you would want to integrate those onto the main branch. So to do that, since locally we cannot do that because main branches or primary branches are often protected. So in that scenario, these platforms like GitHub, GitLab and so on, they have their own functionality which will let you integrate feature branches or any working branches with your main branches or your primary branches. So those integration strategies offered by these platforms, they are primarily three, and we'll come to this later, but I want you to know that squash and merge is the term that GitHub uses, and we have also seen squash as part of interactive rebase. So these two things are different. Do not get confused between them. Right now what we are discussing is squash merge. Squash merge is something that is provided by the platform GitHub in our example, and GitHub calls it squash and merge, but in often conversational terms you would hear people say we are performing a squash merge. No one would say we are performing squash and merge. So I'm bringing these points because I don't want you to get confused when someone mentions squash merge and not squash and merge. So both of these are synonyms, so to speak. You can use either of them based on your comfort level, but squash merge is often what I have used. Squash at platform level is commonly referred to as squash and merge. Now, squash interactive rebase versus squash platform. Squash interactive rebase, local commit history rewrite before sharing. Now, why do I write before sharing? Is that before sharing whatever you have done with the remote, what you would want to do is you may want to perform interactive rebase, and then you may want to share it with the remote so that your commits are shown as you want to show them. Understand? Because see, you are a local developer, you could be doing so many things in your commit history, and your commit history will not always be clean, because I have been there. I have had 30 commits just to troubleshoot a single problem, and I don't want my team leads or my superiors to see how bad my commit history was. In that scenario, I would never want to share my history until and unless I interactively rebase it. So that is what we did in our previous demo. So local commit history rewrite before sharing. Squash is, again, a platform level squash is something that combine commits during PR integration on the target branch. Now this is extremely important, and let's see this with an example. So let's say we are on remote. So this is something that is happening in GitHub. Nothing is local right now. Okay. So you have two commits, A and B, and then in your main branch, that is your primary branch. And then let's say there is a Varun Joshi developer. Varun Joshi created two commits locally, and then Varun Joshi pushed those two commits to the remote. And now remote looks like this. It has two commits, C and D. Now, depending on what sort of strategy you are using in your platform, you could have three strategies. Like you could have a merge strategy, a squash and merge strategy. This is what we are discussing. Or you could have a rebase and merge strategy. Again, I would say, like I mentioned before, rebase is not used in shared branches. So it is highly unlikely that in platform you are using platform as in, remote systems I'm talking about, you would be using rebase and merge. This is highly unlikely because main is the primary branch, and you would not be using rebase and merge when a PR is raised from this branch to integrate with this branch. Then you would, highly unlikely you would be using rebase, because as we have learned before, rebase rewrites the history and we don't want that. Locally, of course, you would be performing rebase all the time in your feature branches. That's okay. But in shared branches, you won't be. And again, see, do not quote me on these things, because these are subjective things and depends on how you are dealing with your application. What I am telling you as a general recommendation is what you would mostly see, but there are always corner cases. So we have, let's say, this. Then what we did is changes push to remote, pull request created, yes, and then you chose squash and merge, and then you finally delete your feature branch. That is the typical flow that you would see. So what squash merge will do is combines feature commits into a single commit. So even if you have 20 commits in the feature, squash and merge will just result in one commit. And that is so good, because you don't want your main to be so polluted. You just want the crux, and that crux could just have a commit message: this is feature cloud with Varjosh authentication. That's it. You don't want to see what Varun Joshi did in 10 different commits. I just want to know what he did in a single commit message. That's it. I don't want to see how his work progressed. In that scenario, you would use squash and merge, or squash merge. Combines feature commits into a single commit. No merge commit created, only main history is updated. You may choose to delete that after this. I mean, this step, that's why I've written optional, or you could delete the feature branch. So if you see here, we have deleted the feature branch. That's why I have not shown that. And you see A, B and C and D commit. These C and D commits, these commits are combined into a single commit called X. Combined into single commit CD resulted in X. Now this is what we are going to see. Now again, in here I don't have branch divergence, which is why I won't see a conflict. But understand, in production you could see conflicts as well. In that scenario, you will have to resolve the conflict. And platforms like GitHub, GitLab, they have specific UI settings which will compare whatever you are doing. Like we saw in Visual Studio Code. In Visual Studio Code, we had a UI which asked us what is that you want to do. Do you want to accept the current change, incoming changes, or you want to compare them, or maybe you want to keep both of them? We saw those things, and those things are also available in platform. Understand, whatever we are discussing right now, this diagram, this is part of the platform GitHub, GitLab, or so on. Now that we have understood what squash merge is, I want to discuss the integration strategies. Now this is the strategy that we will be concentrating, and this is the strategy that we used in our previous lecture where we were discussing remote repositories. We discussed this in detail. Now I want you to know, create a merge commit. Now this is simply called a merge strategy. Now GitHub calls them with these elaborated names, but when we are talking in general terms, we would just call this merge. This would be just called squash, and this would just be called rebase. So I don't want you to be confused when people mention these like this. Okay, so what would a merge commit do is preserves history, adds merge commit. Now even if there is no branch divergence, platforms like GitHub, they will create a merge commit. So keep that in mind, and we saw this in our previous lecture as well. Squash and merge, one commit, clean and minimal history, and that is what we are going to see today. Rebase and merge, linear history, commits replayed individually, and like I mentioned before, it is highly unlikely you would be using this for your main branch. What squash does: platform combines all feature commits into a single commit, no merge commit created, maintains linear history on main. That is understood. There is no merge commit created. So merge commit is only created in your first one, that is the create a merge commit. The name implies this, and I'll show all these three to you in the UI when we go to the demo. And the last one is feature branch unchanged, only main affected. Now if you choose to delete it, you can, but like we have discussed before as well, feature will remain unchanged, only main will have the changes integrated. The changes that are performed here will be integrated as a single commit. Understand, there are ways to integrate changes from one branch into another. These are the three ways that are available at GitHub. When we were dealing with local, we discussed two ways. There is rebase and then there is merge. But when we are talking about remote, there are three ways: rebase, squash, and merge. Understand, local as well, you can have interactive rebase where you have an option to perform squash as well. So I hope all these dots are getting connected, and I am covering everything so that even if you do not understand these things at once, but when you watch this again with some experience or with some troubleshooting, then all of these things start to connect from lecture 1 to lecture 3, from part 1 to part 3. And I have taken this snip from GitHub itself so that I can show you exactly what will happen. So create a merge commit. All commits from this branch will be added to the base branch via a merge commit. Squash and merge, the two commits, it says two commits because I was doing this demo where we had two commits. So that's why it said two commits. If I had 10, it would have said the 10 commits. Okay. The two commits from this branch will be combined into one commit in the base branch. Rebase and merge, the two commits from this branch will be rebased and added to the base branch. And of course, when we are rebasing, our hashes will change. The history will be linear. Now that we have understood this, let's go to the demo. And I have something interesting in the demo, and I'll tell you that as we progress. Okay, so let's go to our platform first, because let's do it the production way. So I will duplicate this tab here. Let me go at the very top, and then I will go here. I could have done that from there itself. New repository, and I will call it PWVJ Git practice. Yeah, this one. This is what I'm naming my repository, and visibility will be private because I wanted to do this production style, because I want end to end story to be told in this demo. So I'll click on private, I'll click on create repository, and my repository is created. Now we want to access this repository from our local system, and we have learned this on how to do this in our previous part 2. But in part 2 we used SSH as our strategy to log in, but this time we used SSH as a strategy to perform push and pull. Okay, that was our authentication with the remote. But this time I want to use personal access tokens. Now understand, when you are a single developer working on your repository, it's highly likely that you would use SSH. I am using personal access token here because I have already shown you how to use SSH, and I wanted to also show you how you use personal access tokens. Now again, I want you to know that you will often see in production SSO based authentication integrated with identity providers. Identity providers like Ping, Okta, Microsoft's Active Directory, Azure AD, and so on. So in that case, SSO handles user authentication and identity verification. Now, Git operations are typically performed over HTTPS. So whenever you are using personal access tokens under the hood, which is likely when you are using SSO, or you are directly using personal access tokens like we will be doing in this lecture. So Git operations are typically performed over HTTPS using tokens issued after SSO authentication. But right now we will be generating that token manually. So let's go here, and I will go to settings, and these are global settings. Okay, these are not settings for this repository, these are settings for my account. Go here, and when we were dealing with SSH, we created that SSH key here. I mean, we uploaded our public key here. And since now we are dealing with personal access tokens, I want you to go to developer settings, which is at the very bottom of that screen. Personal access tokens, fine grained tokens. Now tokens classic, I think they impact all the repositories, but fine grained tokens, you can give access to a specific repository using fine grained tokens. So I'll click on generate new token, and the token name could be CWVJ squash demo, and resource owner is cloud with var josh, expiration is 7 days, and then all repositories no, public repositories no, only select repositories yes. And here I will search for the repository I just created, cloud with varjosh git practice. I'll click here because this is a private repository, know that, guys. And I'll scroll down, add permissions, and here I'll search for content. Okay, so contents, I'll check this, and this says contents, repository contents, commits, branches, download. These access I have, but I don't only want read only access, I want read and write. Here you can choose repositories that the user using that personal access token has access to. So I'll click on generate token. I say I have read it, generate the token. You only see this once, and even if you see my token, that is of no use because I'll be deleting this repository anyway. And anyway, this is a repository that has no important thing. We're just using it for practice. So just keep a note that this is only shown once. You should copy it somewhere safe. I'll copy it and I'll paste it onto here so that I can use it later. Okay. And then what I now want to do is I want to add this repository as remote in my local. So what I will do is, previously we used SSH, but this time I'm using HTTPS because I'll be using personal access token. I'll be copying this name, and then I will go to my terminal. And here first let me git init, and here let me git init, and let's call this cwvj, and this one is git practice. And then I'll cd into cloud with varjosh git practice. And what I will do now is let's perform two commits in the main branch. This is a main branch. I'm performing two commits. I'm creating app.text, initialize cloud with varjosh platform, feature add cloud with varjosh core configuration. I'll press enter. So git log one line, I'll see two commits have been done. So now I will run git remote add origin. We have seen this in part 2 as well. I'll go back there. I'll copy this HTTPS path. I will paste it here. Okay. Now we have just added, but we cannot push until and unless we provide some authentication. Now what you can do is you can run this command to provide authentication. Now again, I have written all these steps in the GitHub repo. You can go and check that out. But here is the place where you want to add the personal access token. So what I'll do is I'll come here. I will quickly remove this, and then I will go to my browser. I will copy this token. I'll come to, I'll paste it here, and then I will press enter. Okay. So if I run git remote, I can see origin is here. If I run git remote -v, run this with caution because this will show your personal access token. So this shows my personal access token as well. Now, so what I will now do is I will create a feature branch, and I'll also perform two commits in the feature branch. So this is my feature branch called cloud with varjosh -auth. And then I am performing two commits here, and I am modifying app.text itself. I'll press enter, and this has created that branch and created the commits as well. So if I run git log one line -all, I see everything here. So main had two commits, then I created a feature branch, and now feature also has two commits. So what we are essentially doing is we are at this state right now locally. We have not pushed anything. Now let's perform that push. So what I will run is git push -u to set the upstream origin main, and this will push the main branch to our remote. So if I go to my browser, I go here and I click here, then I see main here. So only one branch is there right now, main, because I've only pushed main. And if I go to app.text, I see both the lines that we added in the main branch. So if I go back to my terminal, I can run the same thing for our feature branch, git push -u origin, and this is feature cloud with varjosh auth. And if I hit refresh here, I now see feature branch as well. And if I go here, I see that these two lines are added in my feature branch. Understand that main does not have any visibility to these two lines, because these two lines were performed based on these two commits, and main does not have any visibility on these two commits. But what I also want you to notice, my friends, is if I go to main, I see here compare and pull, and that is exactly what we saw in part 2. So now I want to compare and pull request. So I'll click here. So it will first compare the file, and then you can raise a pull request. That's why it is called compare and pull request, not just pull request. So compare, if I scroll down, it is comparing. It is saying your base is main and you are comparing that with feature branch. Here is what was there in your main, and these two lines have a plus sign because it is saying these two lines will be added. Now add a title. You can add a good title, good description. You can even use markdown here, and I will simply click on create pull request. Now comes the interesting part. So here is merge pull request, and this is something that we have used previously. We have clicked on merge pull request and a merge was performed. But if you click on this drop down here, then you see different options. You can perform a merge commit like we discussed in our theory part, you can perform squash and merge, or you can perform rebase. So I will perform squash and merge. And I want to show you one more thing. I'm getting so excited here. Just give me a moment. I'll open this in a new tab. I will go to settings. Okay. And you remember we protected our branch in our part 2. So we'll just click on new branch rule set. And if I scroll down, okay, and here we said require a pull request before merging. Okay. And here were the allowed merge method. So what you can do is you can disallow certain methods. So if I disallow merge and disallow rebase, then only squash will be allowed in my branch. And that is so powerful, friends. Imagine I don't want anyone to use rebase. I can uncheck this. I only want squash, or I only want merge. That's, I mean, dependent on what I choose. So you can choose these options. You can choose any one of them, all three of them, or two of them based on your requirement. What is that you want to allow? Okay. I'll go back here, and this time I will click on squash and merge. Squash and merge. And again, it is asking me to have a commit message. So I can write full feature was developed here for authentication. Now this could be anything. Okay. Now I will press confirm squash and merge. Now see how interesting this would be. We have done this, and it is asking me you can delete the branch from here itself. We will delete it from the CLI because we trust in CLI. Then I'll go here and I'll go here, and tada, 3 commits. We only had 2 before. And if I click here, what is the third commit? The third commit is the one that we just created. How good is that? Now see, feature login branch. Now I don't need that, right? Because I have already merged the changes, right? And like I told you, feature branch is not impacted. Okay. So if you go to app.txt, you still see those 4 things here. And those 4 commits are visible here. So all these 2 commits are from, main branch, because this is the point from where we created the feature branch, and these 2 commits we performed in the feature. So if I go to back to my diagrams, feature login still has access to all of these commits. That's why we said feature branch will remain unchanged. Only main now has the squash merge commit that you see. It has combined all of those 2 commits into a single commit. And if I go to the file, you see all the 4 lines are here. I hope you understand these points. Now let's go to our CLI and perform certain cleanup. So what I will run here is I will run git switch main, okay, git branch -d, and the name is feature branch. I don't want this branch. So what I want to do is I want to delete this branch from remote as well. So what I'll do is git push origin, delete feature cloud with var Josh. Actually, I have tab completion is not working because locally I've deleted that branch. So this should work now. Now it has deleted the remote branch as well. So if I go to the browser, I go here, I only see one branch. Feature branch is deleted. I hope this flow makes sense end to end. Now what I can do is if I run git log one line here right now, I only see 2 commits which we performed before. I don't see the third commit. And why don't I see that? I don't see that, my friends, because I have not performed a git pull. Git pull is used to bring the changes that are there performed in the remote. So if I run git pull now, it will bring me the third commit. And if I now run that command again, voila, I see the third commit. Origin main points to that commit, and full feature was developed here for authentication. This is what we added as the commit message. And you see origin head, origin main, and your main. So this main is your local main, and this origin main is your remote main. Both are pointing to the same commit, which is what we want, because right now we have everything that is to be pulled. If I run git pull again, it will say everything is up to date, my friend, already up to date. And head is pointing to the currently checked out branch. And which is the currently checked out branch? Main is the currently checked out branch. I hope all of these things are clear to you. Now let's do actual cleanup. So I'll go one step back, rm-rf, I'll remove that directory, and then I will go to my browser, and I'll also delete this repository. I don't need this repository anymore, right? It is cloud with Varjosh git practice. I don't want to accidentally delete my git masterclass, you know. And then I will copy this name, and then I will paste it here. And I've done that before. I've deleted this, and then I will also delete my personal access token. I don't need this as well. So both of these things are deleted. I would also ask you to do this cleanup once you have done your job. Now, the last topic for today is cherry pick. So I'll go to my diagrams. I will scroll down and let's discuss cherry picking. Cherry pick concepts and behavior. So what we have seen thus far, we saw that when I talk about local git, you have two ways via which you can integrate one branch with another, correct? There is merge, and then there is rebase. Now I want you to know that when you want to integrate the entire branch, of course these methods work well and you have a solid understanding of both of these methods. But what if I don't want to integrate the entire branch? I just want to pick a certain commit and bring it to my branch. But Varun, why would I want that? Because maybe there is a single commit that has something you need. There are many use cases where you would want to pick a specific commit, and that is exactly what cherry pick will do for you. As the name implies, cherry pick something that you want. So pick a commit from a different branch that you want to integrate into your branch. Why cherry pick exists: merge and rebase integrate entire branch into another. Both operate at branch level, includes all commits. What if only a specific commit is needed? That is when you use cherry pick. So what cherry pick does: applies selected commit onto current checked out branch. So for example, if I have checked out the feature branch, and if I run git cherry-pick C is from the main branch, then it will bring that commit onto my history as well. And when it brings that commit, of course the work that you have done as part of commit C will also come here. Again, it is not copying, it is creating a new commit. So same change, new hash, creates new commit with same changes, different hash. So understand, it is not the same commit that comes here, it is just a new commit that comes here. May cause conflicts if same code is modified. Of course, that makes sense. If you have added a third line here, let's say Varun Joshi is my name, is the third line, but as part of commit F, the same file has a third line, Varun Joshi is not my name, then of course there will be a conflict and you will have to resolve that conflict. And again, I'm giving examples that we use in daily conversational English, but in reality this could be modifying a function that you added in as part of commit C, and in commit F that function is modified differently. So in that scenario you will have a conflict. Maybe the cluster IP port in this was 80, but the cluster IP port in this is 81, then that is also a conflict. So you will have to resolve those conflicts before you can cherry pick. And it's not just cherry pick, even rebasing, merging. If there are conflicts that Git cannot resolve automatically, then of course you will have to resolve them manually. And why do conflicts occur? When you modify the same line in the same file, then conflicts occur. Now that we have a fair idea, theoretical idea of cherry pick, let's go and perform a demo for cherry pick. I'll go to my terminal. I will, let's say, git init. This time let's call this cloud with varjosh cherry pick, right? Demo, cherry pick demo. And then I will cd into this. And then the first thing that I will do is I will add 2 commits, and then we'll see the logs. I'm doing this little quickly because we have seen this 100 times now. And so first commit app.text, second commit, we modified app.text, added one more line here, and we are using commit -am. We are staging and committing at the same time because at least once the file has already been staged. Now I want to check out, I want to create a new branch, and this time this branch is feature cloud with varjosh -auth. Again, see, I performed 2 commits in the main. Now I am performing 2 commits in the feature branch. I'll press enter. I want to show you something now. I want to go back to the diagrams. 2 commits, these commits we have performed, okay, and these 2 commits also we have performed. Now what I want to do is, because I want to show conflicts, I will purposefully create a conflict and then we will cherry pick. So what I will now do is I will go back to the main branch. Okay, git switch main. Okay, now I am in the main branch. Now what I'll do is I'll modify app.text in the main branch, and then you will see what will happen. I'll go here. So what I have done is echo authentication validation logic, fix authentication validation logic. So this is our third commit here. Now what I will do is I will introduce a conflicting change on feature. So let's git switch feature. And here what I will do is I will add something different here. If I come here, I paste it here. Here I added fix authentication validation, and here I am adding update authentication validation logic feature version. I'll press enter. So we have done conflicting changes. So if I cat app.text here, I see the 4th line is this. If I git switch main, and if I cat app.text here, I see we have done this 3rd commit here. Now here the 3rd line is different, but here the 3rd line is different. So there will be a merge conflict, and that conflict we will have to resolve before the cherry pick is completely finished. So let's now do that. Identify the commit that has to be cherry picked. So what I will do is I'll first go to feature branch, git switch feature, and here let's write git log one line all, and I'll also add graph so that you can see the divergence as well. So these 2 commits were initially performed. This commit was performed then in main, and the feature branch has 3 commits. These are the 3 commits, and also these 2 commits will be part of the features history. Now that we have this, what I want to do is this part is not available in feature. So the 3rd line that we saw there when we catted that app.text in main branch, yeah, fix authentication logic, validation logic, this we don't have. What I want is I want to bring this change onto feature branch. Now instead of integrating the entire branch, I want to just bring this change. Now this example is simple, otherwise you would have seen multiple commits here, and then we would have only selected one commit, but for simplicity I am doing this. Now what I will do is I will write git cherry-pick, and this time what is that I want to cherry pick? I have to give the commit ID. So the commit ID I want to cherry pick is this one, right? Because that is the change we want to bring in feature. So I will press enter now, and again conflict, merge conflict in app.text, and it is exactly telling you once you resolve the conflict, you write this and then you write git cherry-pick continue, similar to what we saw in merging and rebasing. So I will go to my Visual Studio Code now, and here I'll expand this app.txt. Now it is telling me exactly. Okay, now first two lines it is saying will remain the same, but if you choose the current change, then these three lines will add it. If you choose the incoming change, then this line will be added. So after these two lines, do you want these three or do you want this? Now you have to make this choice. Now here what I will choose is accept both, and if I do that, everything is here. So now I will go back to my terminal, and here I will run git add app.txt, and then you see cherry here, git cherry-pick continue, and again it is asking me what is your message. Let's keep this message as is, and I'll save this, and now let's run git log one line all. Let's have graph as well. You see what happened. 1 2 3 4 5 6, these 6 commits existed before, but you have this one new commit, and you can see 6 commits that existed before. 1 2 3 4 5 6, 97 was that. 97 is here, but you have one more commit, and this commit is this one, C dash. And you see we have the same commit message. We have fixed resolve authentication validation issue, and here as well we have the same commit message, because when it was asking us to modify the commit message, we didn't modify it, we kept it as is. That's why you see the same commit message here as well. I hope cherry-pick is also understood, and that was the last topic I wanted to discuss. But before I let you go, there is one more thing I want you to do. Go to the GitHub repository for this lecture, and I have added one section here, Git integration and history strategies revision. Okay, so this is a table because we have seen so many concepts: merge, rebase, interactive rebase, squash, that is platform based, cherry-pick, and so on. So this will give you a high level view of everything of whatever you have learned. So do check this out. This concludes part 3, and with that the Git masterclass. In this final part, we focused on how to structure and control Git history using rebase, interactive rebase, squash, and cherry-pick. You saw how different strategies can produce the same final code but very different histories, and why that matters in real-world systems. Across all 3 parts, we moved from understanding how Git works locally to collaborating across teams, and finally to shaping history in a way that makes systems easier to understand, review, and maintain. At this stage, you should not only be comfortable using Git commands, but also confident in choosing the right strategy on context and trade-offs. If you have any questions, feel free to ask them in the comments section and I will reply. If this helped, do consider liking, sharing, and subscribing. It will mean a lot to me. Thank you very much.